Dear friends, today the exam is done. Yes, Engineering Services 2024 is over. Paper level was tough. It was tough in GS as well as it was tough in engineering in across the branches. अब जब पेपर टफ है तो सभी के लिए है, कट ऑफ इज एक्सपेक्टेड टू कम डाउन। तो दोस्तों इससे परेशान होने की ज़रूरत नहीं है। आपका पेपर का कट ऑफ डाउन आएगा। डिफ़िकल्टी लेवल दोनों पेपर में हाई था, आप इसमें चेक करिए और जो पिछले सालों के जो कट ऑफ रहे हैं उनसे कट ऑफ डाउन आएगा। हाँ, मिनिमम 15% स्कोर आपको हर पेपर में इंश्योर करना है ताकि एक बेंचमार्क से आप ऊपर रहें। और अगर हम बात करें इस बार डिफ़िकल्टी लेवल की तो पेपर लेंदी बहुत था। जैसे जीएस में जो मैथमेटिक्स का सेक्शन है, इन रीजनिंग एप्टीट्यूड का सेक्शन है, आईसीटी, ये सारे बहुत लेंदी क्वेश्चंस थे। इसी तरह से टेक्निकल में भी कैलकुलेशन में देखा, जैसे मैं अभी सिविल का पेपर देख रहा था तो उसमें पेपर के क्वेश्चंस बहुत ही लेंदी है, टाइम टेकिंग है। मैकेनिकल में भी क्वेश्चंस लेंदी है, इलेक्ट्रॉनिक्स इलेक्ट्रिकल में भी क्वेश्चंस के जो आंसर्स हैं वो ऑप्शंस बड़े वेग से हैं। तो ये सभी के लिए है। और जब भी पेपर टफ आता है उसमें एक ही बात है कि कट ऑफ कम हो जाएगा, बाकी परफॉर्मेंस सबकी डाउन होगी। तो इसमें कोई घबराने की बात नहीं है। So one by one, all the subjects will be discussed by the concerned teachers of the MEDE। आप मेरे सेशन के बाद, मेरे सेक्शन के बाद आप वो सेक्शंस आप गो थ्रू करेंगे। Now I am going to speak about certain more things। एक अच्छी खबर है जिसकी अथेंटिसिटी पर आपको हो सकता है सवाल हो, क्योंकि अभी ये पब्लिक डोमेन में नहीं आई है, और वो है रेलवेज की वैकेंसी को लेकर के। देखो दोस्तों, मैं बहुत ही इंटरनल इन्फॉर्मेशन से बात करता हूँ और कोई हल्की बात नहीं करता हूँ। जब भी कोई अथेंटिक न्यूज़ होती है तभी मैं उस चीज़ को मैं आपके सामने लेके आता हूँ। तो मुझे कुछ ऐसा पता लगा है बहुत ही इंटरनल सोर्सेज से कि रेलवेज में जो अभी तक पिछले 4 साल से रिक्रूटमेंट हो रहे थे IRMS के थ्रू, वो रेलवे के लिए बहुत ज़्यादा वर्केबल नहीं हुआ। समहाउ जो ऑफिसर्स, इंजीनियरिंग ऑफिसर्स जो इंजीनियरिंग सर्विस से पहले सेलेक्ट होकर जाते 2020 के पहले, अब उनके प्रमोशंस हो चुके हैं और वो AEE का जो लेवल होता था इनिशियली, इंडक्शन लेवल, वहाँ की पोजीशंस लगभग खाली हो रही हैं और वहाँ पर ऑफिसर नहीं है। और जो नए रिक्रूटमेंट हुए हैं IRMS के थ्रू, वो इंजीनियर नहीं है। रेलवे इज इन दी एक्सपेंशन प्लान। अब बहुत सारे नए प्रोजेक्ट्स आ रहे हैं। अभी आपने बजट में देखा होगा कि रेलवे हैज प्लान दी 3 न्यू कॉरिडोर्स, बुलेट ट्रेन है, इधर बहुत सारे न्यू एक्सपेंशन प्लान है। रेलवे इज द लाइफ लाइन ऑफ द इंडिया। तो अब रेलवे को रियलाइज हुआ कि हमारा शायद वो डिसीजन IRMS वाला शायद उतना सही नहीं है। तो रिसेंटली मैंने सुना है कि रेलवे बोर्ड ने ये डिसीजन लिया है कि लेट अस गो बैक टू द रिक्रूटमेंट ऑफ द इंजीनियर्स। अब इसमें एक बात यह आई थी कि इसका रिक्रूटमेंट कहाँ से हो, क्या IRMS सेपरेट एग्जाम कराएं या फिर इंजीनियरिंग सर्विस से लें। तो UPSC को ये उनसे पूछा गया तो UPSC ने कहा कि उनका शेड्यूल ऑलरेडी बहुत पैक्ड है अराउंड द ईयर, सो दे हैव टू सजेस्टेड कि बेटर टू गो फॉर इंजीनियरिंग सर्विस, क्योंकि अल्टीमेटली स्टूडेंट्स वही हैं, इंजीनियरिंग सर्विस का भी एग्जाम लिखेंगे, IRMS का भी सेपरेट एग्जाम लिखेंगे। सो दैट इज माई इंफॉर्मेशन सेज दैट कि आने वाले समय में इंजीनियरिंग सर्विस 2025 में रेलवे की वैकेंसीज भी आएंगी। दिस इज माई कॉन्फिडेंस एंड दिस इज माई एक्सपेक्टेशन। लेकिन दोस्तों, इसमें एक चीज आपको ध्यान रखना है कि ये अभी कोई फॉर्मल नोटिफिकेशन इसका नहीं आया है। जो मैं बात कर रहा हूं ये कुछ मेरी ऑब्जर्वेशंस और कुछ मुझे जो पता लगा है वो है। अब इसमें कोई लास्ट मोमेंट में कोई चेंज हो जाए या कैबिनेट कभी, क्योंकि कैबिनेट को अभी अप्रूव करना है, बट बोर्ड ऑफ रेलवे बोर्ड ने और MR ने इसको अप्रूव दे दिया है, सहमति दे दी है। अब इसका जो मेन सहमति आनी है वो है कैबिनेट से। तो कैबिनेट से जैसे ही आएगा फिर उसके बाद गजट में नोटिफिकेशन के लिए जाएगा और उसके बाद ये इम्प्लीमेंट होगा। तो 2024 में तो ये वैसे भी नहीं होने वाला, ये 2025 की एग्जाम साइकिल की बात कर रहे हैं। आप लोगों को ये लग सकता है कि मैं इसलिए बात कर रहा हूँ कि बहुत सारे स्टूडेंट्स कमेंट लिखते हैं, मैंने देखा है कि आप तो इसलिए बात कर रहे हैं कि कोचिंग की बात है, स्टूडेंट यहाँ आएंगे। मेरा दोस्तों ऐसा नहीं है। आप सिविल सर्विसेज में जाएंगे तो भी नेक्स्ट IAS है, इंजीनियरिंग सर्विस के लिए आएंगे तो भी MEDE है। तो मेरा कंसर्न वो बिल्कुल नहीं है। मेरा कंसर्न ये है कि जो इन्फॉर्मेशन है, जो मुझे पता लगा है, उसमें अगर कुछ अथेंटिसिटी है तभी मैं उसकी बात कर रहा हूँ। तो थोड़ा सा आप वेट करिए, हो सकता है कि आने वाले कुछ महीनों में आपको ये इन्फॉर्मेशन बहुत ही गवर्नमेंट के ऑफिशियल नोटिफिकेशन से ये जानकारी आपको मिलेगी। और अगर ऐसा नहीं होता है, क्योंकि ये चीज़ें मैंने जो भी सुनी है वो भी मेरे किसी सोर्सेज से ही मुझे पता लगा है। अब वो सोर्सेज मुझे लगता है कि रिलायबल है, लेकिन अगर कोई लास्ट मोमेंट कोई ऐसा चेंज आ गया, कुछ हो गया, तो फिर ये इसके लिए कुछ नहीं कर सकते। पिछली बार गजट नोटिफिकेशन होने के बाद इंडियन रेलवे मैनेजमेंट सर्विसेज का अलग से एग्जाम होना था, उसके बावजूद भी डी नोटिफाई कर दिया गया। तो अब ऐसी सिचुएशन के लिए हम लोग कुछ नहीं कर सकते। तो इसलिए कोई भी अनप्रेडिक्टेबल कंडीशन हो जाए तो नहीं कह सकते, बट देयर आर हाई चांसेस दैट इन द कमिंग टाइम रेलवेज विल बी नाउ द पार्ट ऑफ द इंजीनियरिंग सर्विस। दूसरा, अब आते हैं कि आगे की बात। तो दोस्तों, मेड इजी जो आप 2.0 देख रहे हैं, दिस इज आफ्टर 2 decades we are restructuring the teaching methodology, teaching concept, type of questions, difficulty level of teaching, and we are integrating the technology in the teaching in a better way। तो ये धीरे धीरे इसका जो इफेक्ट है आने वाले सेशन में, अगले जो 2-3 महीने, 4 महीने, 5 महीने में इसका इफेक्ट आपको क्लासरूम में दिखाई देगा, और ऑनलाइन कोर्सेज में भी दिखेगा, बट मेजरली क्लासरूम में दिखाई देगा। और मेरा ये बिलीफ है, देखिए मैं अपने बिलीफ की बात करता हूँ, कि मेरा ये बिलीफ है कि जो लर्निंग एनवायरनमेंट क्लासरूम का होता है, जब आप क्लास में बैठ के पढ़ते हो तो अपनी सारी प्रॉब्लम्स घर पे छोड़ के आते हो। सिलेबस ज़्यादा है, लॉन्ग लॉन्ग आवर्स क्लास करनी पड़ती है, और जिस तरह से क्वेश्चंस का डिफिकल्टी लेवल बढ़ रहा है उसमें आपको प्रैक्टिस भी करना है, सॉल्व भी करना है, कॉन्सेप्ट भी लर्न करना है। तो ये सब चीज़ें ज़्यादा अच्छी क्लासरूम में हो पाती हैं। इसलिए मैं हमेशा सजेस्ट करता हूँ स्टूडेंट्स को कि अगर आप मैनेज कर सकते हैं तो ऑनलाइन कोर्सेज की बजाय क्लासरूम को प्रेफर करिए। बट जो लोग नहीं आ सकते, जिनकी फाइनेंशियल प्रॉब्लम्स हैं, या जो जॉब में हैं, कॉलेज में हैं, अब ऑनलाइन है तो आप ऑनलाइन भी पढ़ सकते हो। मेड इजी के कोर्सेज में थोड़ा सा डिफरेंस होगा। ऑफलाइन में थोड़ा जो इन डेप्थ टीचिंग होगी और जो ऑनलाइन में होती है, थोड़ा सा उसमें फ़र्क होगा। और ऑफलाइन में हम लोग ज़्यादा समय डिवोट कर पाएंगे, क्योंकि वहाँ स्टूडेंट ज़्यादा घंटे पढ़ सकते हैं, ज़्यादा टाइम क्लास में बैठ सकते हैं, उनका कॉन्सेंट्रेशन लेवल भी रिलेटिवली बेटर होता है। दैट इज़ द रीज़न। तो दोस्तों, ये तो था कि मेड इजी 2.0, और इसी 2.0 के रिस्पेक्ट में मैं फर्दर ऐड करना चाहूँगा कि कॉलेज में जब आप फर्स्ट ईयर में जाते हैं, सेकेंड ईयर में जाते हैं, तो उस समय आपके जो कॉलेज के टीचर्स हैं, कुछ अच्छे कॉलेजेस हैं, डेफिनेटली इंडिया में कुछ अच्छे कॉलेजेस हैं जहाँ पे अच्छे टीचर्स भी हैं, लेकिन बहुत सारे प्राइवेट कॉलेजेस में या कई जगह ऐसा देखा गया कि टीचिंग में कॉन्सेप्ट नहीं डेवलप हो पाते। तो इस पॉइंट को ध्यान में रखते हुए मेड इजी ने एक नया इनिशिएटिव लिया है, और वो है इंजीनियरिंग कॉन्सेप्ट्स। तो जो फर्स्ट ईयर सेकेंड ईयर वाले बच्चे हैं, those who are students of first year BTech and second year BTech, for them we are launching a course which is called ENC, Engineering Concepts। अब ये क्या है ENC? Concepts of Civil Engineering, Concepts of Computer Science, Concepts of Data Structure, Concepts of Mechanical Engineering, Concepts of Electrical Engineering and Concepts of Electronics and Telecommunication Engineering। तो जो बेसिक कॉन्सेप्ट्स हैं वो सारे कराए जाएंगे बाय द रिनाउंड एंड एक्सपीरियंस्ड टीचर्स ऑफ मेड इजी, और ये पूरा ऑनलाइन कोर्स होगा, और वीक में इसके 4 days a week क्लासेस होंगी, और 2.5 घंटे आप लेट आवर्स, लेट इवनिंग क्लास पढ़ सकते हो। और यहाँ पर ये जो कोर्स होगा, इसमें गेट या आईएएस की तैयारी नहीं होगी, लेकिन ये इंजीनियरिंग के कॉन्सेप्ट जो आपके सेमेस्टर में यूजफुल होंगे, सेमेस्टर एग्जाम में जब आप कैंपस रिक्रूटमेंट ट्रेनिंग प्रोग्राम में जाओगे वहाँ, या कोई इंडस्ट्री में जाओगे वहाँ पर, या आगे चल के गेट आईएएस की तैयारी करेंगे तो आपकी इनिशियल लेवल की प्रिपरेशन अच्छी हो चुकी होगी। मान लीजिए कि जैसे सिविल का कॉन्सेप्ट है, शियर फोर्स बेंडिंग मोमेंट बनाना नहीं आता आपको, प्रिंसिपल स्ट्रेस समझ में नहीं आते, टॉर्सन बेंडिंग में अंतर समझ में नहीं आता, तो जो बेसिक कॉन्सेप्ट्स है ना, वो बेसिक कॉन्सेप्ट्स आपको बहुत अच्छे से कराए जाएंगे। बट इसमें गेट की या आईएएस के एग्जाम के सॉल्यूशंस नहीं कराए जाएंगे, वो आपके बेसिक कॉन्सेप्ट पर होंगे। सो यू विल बी इंजीनियर बाय नॉलेज, नॉट सिंपली बाय डिग्री, बट यू विल बी इंजीनियर बाय नॉलेज। तो ये कोर्स स्टार्ट होने वाला है। आप सोचते होंगे कि फीस जरूर हाई होगी, तो दोस्तों इसकी फीस हाई नहीं है। इट विल बी जस्ट 500 रुपीज पर मंथ, एंड इट विल बी इन अ ईयर आप ज्वाइन करते हैं एक साथ में भी 5000 पर ईयर, और इससे आप अपने सारे कॉन्सेप्ट्स क्लियर कर सकते हैं, अच्छे टीचर से पढ़ सकते हैं। तो ये आपका कोर्स स्टार्ट हो जाएगा। दिस विल स्टार्ट फ्रॉम द मंथ ऑफ जून। तो जून से ये बेसिक कॉन्सेप्ट्स ऑफ इंजीनियरिंग लॉन्च होगा, और इसमें सारे कॉलेज के फर्स्ट ईयर सेकेंड ईयर वाले बच्चे ज्वाइन कर सकते हैं। लेकिन जो स्टूडेंट थर्ड ईयर और फाइनल ईयर में हैं उनको मैं सजेस्ट करूंगा कि आप गेट या गेट प्लस आईईएस मतलब इंजीनियरिंग सर्विस या फाउंडेशन कोर्सेज में आइए। उनके लिए ये बेसिक कोर्सेज उतने अच्छे नहीं होंगे, तो उनके लिए अलग कोर्सेज हैं, वो गेट और गेट प्लस ईएससी के कोर्सेज हैं। तो ये बेसिक कॉन्सेप्ट ऑफ इंजीनियरिंग स्टार्ट होने वाला है। फिर मैं अभी, क्योंकि आपका प्रीलिम्स हो गया ईएस का, गेट का भी एग्जाम हो चुका है, तो अब जैसे ही गेट का रिजल्ट आएगा हम आपको गेट के रिजल्ट के बाद तुरंत पोस्ट गेट काउंसलिंग सेशंस कंडक्ट करेंगे एंड दीज पोस्ट गेट काउंसलिंग सेशंस विल बी ऑनलाइन। और इसमें आपको ये बताएंगे कि किस गेट के कट ऑफ पर कौन सा कॉलेज मिल सकता है, किस रैंक पर पीएसयू के चांस है, पीएसयूज में क्या पूछा जाता है, आपको तैयारी कैसे करनी है। तो ये सारी जानकारी जो गेट के रिजल्ट के बेसिस पर आपको आगे जरूरत पड़ेगी वो आपको प्रोवाइड करेंगे गेट के रिजल्ट के तुरंत बाद, और ये सभी स्टूडेंट्स के लिए अवेलेबल होगी, ये ऑनलाइन प्रोवाइड करेंगे। फिर जो स्टूडेंट्स रैंक अच्छी लाएंगे, उन जिनको इंटरव्यू कॉल आ सकता है किसी पब्लिक सेक्टर का, तो उनके लिए पब्लिक सेक्टर्स के लिए इंटरव्यू की प्रिपरेशन कराएंगे, ग्रुप डिस्कशन जहां रिक्वायरमेंट है तो वहां जीडी की भी प्रिपरेशन कराएंगे। तो ये भी आगे कंटिन्यू होगा। इसके बाद दोस्तों जो लोग इंजीनियरिंग सर्विस का एग्जाम लिख रहे हैं, अच्छा इसी में एक बात और ऐड कर दूं कि अगर आप अपनी गेट की परफॉर्मेंस को, एक्सपेक्टेड परफॉर्मेंस को चेक करना चाहते हैं तो मेड इजी हैज लॉन्च्ड गेट रैंक प्रिडिक्टर। तो आप गेट रैंक प्रिडिक्टर में जाकर के आप मेड इजी की वेबसाइट से आ जाइए गेट रैंक प्रिडिक्टर के लिंक पर, और वहां पर आप अपनी रैंक प्रिडिक्ट कर सकते हैं। दैट इज अ वेरी गुड सॉफ्टवेयर विच विल गिव यू गेट रैंक प्रिडिक्टर, एंड दिस इज एक्टिव नाउ, और आपके सारे पेपर्स के लिए एक्टिव है, जो कोर ब्रांचेस हैं आप इसको चेक कर सकते हैं। अब हम बात करते हैं कन्वेंशनल प्रैक्टिस प्रोग्राम की। डियर फ्रेंड्स, आप सोचते होंगे कि शायद कन्वेंशनल प्रैक्टिस प्रोग्राम इज विद द एम ऑफ ओनली आईईएस, लेकिन ऐसा नहीं है। ये कन्वेंशनल प्रैक्टिस है कॉन्सेप्ट बिल्डिंग प्रोग्राम। आपने साल भर ऑब्जेक्टिव ओरिएंटेड होकर के पढ़ाई की है और कई लोगों के कॉन्सेप्ट्स उतने अच्छे नहीं हैं, तो डेफिनेटली दिस इज यूजफुल फॉर दोज हु वांट टू इंप्रूव देयर कॉन्सेप्ट्स। 400 लगभग 350 टू 400 आवर्स की क्लासेस हैं, एंड वी हैव केप्ट इट हाईली सब्सिडाइज्ड, क्योंकि वी डू अंडरस्टैंड कि दिस is very tough time for the students to invest again, so we have kept it the subsidized, और subsidized fee is available for the next 2 weeks till 4th of March। आप इसको कर सकते हैं एनरोल। इसमें ऑफलाइन एंड ऑनलाइन दोनों तरह के ऑप्शंस अवेलेबल है। आप ऑफलाइन कोर्स ज्वाइन कर सकते हैं, ऑनलाइन कोर्स ज्वाइन कर सकते हैं। तो दोस्तों ये है कन्वेंशनल प्रैक्टिस प्रोग्राम विच विल हेल्प यू इन engineering service means, if you write later civil services means, if you write forest services means, if you want to go for the BARC, you want to go for DRDO, you want to go for any next year gate examination, this will help। लेकिन ये उनके लिए है जो पहले एक बार तैयारी कर चुके हैं या पहले कोचिंग कर चुके हैं। जो बिल्कुल फ्रेशर है उनके लिए मैं रिकमेंड नहीं करूंगा कि आप कन्वेंशनल प्रैक्टिस प्रोग्राम ज्वाइन करें। So this will be good for English medium students as well as for the Hindi medium students. So this is the conventional practice program. देन जून के महीने में एक यहां पर रैंक इंप्रूवमेंट बैच स्टार्ट होगा, एंड दैट रैंक इंप्रूवमेंट बैच इज फॉर दोज स्टूडेंट्स हु वांट टू इंप्रूव देयर गेट रैंक। बाय दैट टाइम रिजल्ट विल बी डिक्लेयर्ड, एंड इफ यू डिसाइड to improve your rank, so in the month of the June we will start the rank improvement batch for the GATE 2025. then those who are very fresher, अभी अपनी जर्नी ही स्टार्ट ही कर रहे हैं, and you want to take a decision for you go for IES or GATE or public sector, what are the future prospects, उन students के लिए there will be a online webinar which I will take on 21st of March, and this will be very useful, 21st of February, this will be very useful to those who want to decide their career towards the engineering service, GATE, public sectors, या फिर career for engineers, what are the options for engineering graduates, and this will be highly useful. Recommend to your juniors, they can join in this webinar in YouTube, Made Easy YouTube channel. तो ये आप जरूर ज्वाइन करिएगा, those of you who are planning for the future. तो this is one information. And now we have the offline and online batches which are starting. Some batches have already started, some are starting in the month of February. अभी 29 February से भी batches हैं. Then there will be batches in March, then there will be in May and June. So there are multiple batches, and we have the offline centers in Delhi, Bhopal, Jaipur, Hyderabad, Calcutta and Pune. So if you want, you can definitely attend either offline, or if you want, you can enroll for online. तो दोस्तों ये तो इन्फॉर्मेशन हो गई इस एग्जाम से और मेड इजी से रिलेटेड। एक इन्फॉर्मेशन मैं और शेयर करना चाहूँगा कि इफ़ यू हैव बीन मेड इजी स्टूडेंट नाउ this session or the earlier session, and if you want to if you have missed any subject, आपके कॉन्सेप्ट वीक थे या नहीं कर पाए किसी वजह से, आपकी हेल्थ खराब हो गई थी, ऑफलाइन क्लासेस आप पूरी तरह से नहीं कर पाए थे या की थी लेकिन सब्जेक्ट वीक रह गया, तो फॉर सच स्टूडेंट्स वी आर गिविंग एन अपॉर्चुनिटी टू रिपीट 2-3 सब्जेक्ट विदाउट एनी एडिशनल कॉस्ट। आप आकर के उस अपने सेंटर पे क्लास कर सकते हैं। एंड एज आई हैव ऑलरेडी सजेस्टेड कि देखिए ऑनलाइन और ऑफलाइन में थोड़ा डिफरेंट है, और ऑफलाइन की जो टीचिंग की डेप्थ है वो हो सकता है कि ऑनलाइन से डिफरेंट हो, वर्कबुक भी वहां पर डिफरेंट है। इस बार नेम ऑफ द वर्कबुक ऑल्सो हैज बीन चेंज्ड, और इनफैक्ट स्क्रैप्ड, वर्कबुक को स्क्रैप करके हम नया ला रहे हैं, दैट इज which will be implemented after 2 months। तो ये सारे चेंजेस हैं, there are so many improvements, and since you are a मेड इजी स्टूडेंट, जो मेड इजी के ऑनलाइन स्टूडेंट्स हैं उनके लिए ऑलरेडी पहले ये फरवरी तक था, जो वीडियो वैलिडिटी उसको 31 मार्च तक तो ऑलरेडी बढ़ाया जा चुका है, बट वी विल फर्दर इंक्रीज इफ इट इज रिक्वायर्ड। जो गेट ऑनलाइन टेस्ट सीरीज थी उसको बार्क के एग्जाम तक के लिए बढ़ा दिया गया है। इफ यू हैव registered in made easy gate online test series, then we have already extended for the टिल बार्क, और बार्क एग्जाम के लिए कुछ यूट्यूब पर कुछ सेशंस भी कुछ टीचर्स लेंगे, एंड दोज विल बी फॉर द स्पेसिफिक टू द बार्क। तो मेड इजी इज अ वेरी स्ट्रक्चर्ड ऑर्गेनाइजेशन। आफ्टर 2 decades वी हैव रीस्ट्रक्चर्ड अगेन, और मेड इजी की क्वालिटी, टीचिंग क्वालिटी वेल नोन है, यहाँ के टीचर्स सभी बहुत अच्छे हैं, एंड इंपॉर्टेंट इज दैट कि दिस इज अ टीम वर्क, ऑल द टीचर्स यूनाइटेड टुगेदर दे आर टीचिंग। और मेड इजी की जो क्वालिटी है वो रेयर कहीं और आपको रिफ्लेक्ट होगी, इसीलिए मेड इजी के रिजल्ट बहुत अच्छे हैं। और मेड इजी इज ए होलिस्टिक इंस्टीट्यूट, यहाँ पर चाहे टेस्ट सीरीज हो, चाहे स्टडी मटेरियल हो, कंटेंट हो, टीचिंग हो, टाइमली कंप्लीशन ऑफ सिलेबस हो, बेसिक टू एडवांस हो, सारी चीज़ों का ध्यान में रखा जाता है। एंड इफ यू वांट एनी सपोर्ट फॉर सिविल सर्विसेज, डू नॉट हेजिटेट, and we have the next IAS, and next IAS is a one stop solution for the civil services। और दोस्तों एक और अनाउंसमेंट है, वो है मैनिट, MENIIT, दिस इज मैनिट, मेड इजी नीट, मेड इजी नीट IIT। सो वी हैव स्टार्टेड रिसेंटली एन इनिशिएटिव फॉर द नीट एंड IIT JEE। अभी तो इसका इंस्टीट्यूट सिर्फ दिल्ली में है, वी हैव द 2 centers in Delhi, but this is a very focused and quality oriented initiative of the made easy। You must be thinking so many things are there, but yes, made easy is all about the quality commitment। So wish you all the best। Now your technical sessions will start। Stay hope, और आपके अच्छे रिजल्ट के लिए मैं आपके लिए शुभकामनाएं और आपके लिए प्रे करता हूं कि ईश्वर आपको सफलता दे और आप खुश रहें हमेशा। विश यू ऑल द बेस्ट, लव यू ऑल, थैंक यू सो मच।
Good evening all. So now you are free from this prelims examination. I hope that you might have done well, and we got around 13 questions from electrical paper, 13 questions, and all are simple questions except one or two where I don't find the data to be sufficient or the options are not matching. Otherwise all are direct questions. All these 13 questions can be finished in a matter of 15 minutes if you have been made easy student. Considering this question is to find the transfer. This is the standard second order system. We have discussed this in the class as well. I mean, we have discussed this during our discussions. Answer is directly option B. How to find the transfer function using voltage division formula, voltage across this impedance, capacitor 1 by SC upon sum of all the impedances multiplied by the input voltage. This is the transfer function, which becomes 1 upon S square LC plus SRC plus 1, which can be rearranged as 1 by SC upon S square plus S into R by L plus 1 by LC. A second please. It should be option A. 1 by LC upon S square plus S into R by L plus 1 by LC, which is option A. Option A. Now, we are given with the block diagram, transfer function of a system. Question is to determine the stability of the system. We have to form the route array, no other way. S to the power 5, S to the power 4, 3, 2, 1, 0. 1, 2, 4, 6, 2, 5. 8 minus 6, 1, 4 minus 5 minus 1 by 2. This much is enough to say the system is unstable. No need to complete the route array, because we know a concept where in a row which is not 0 completely, if any element is 0 or negative, system is unstable. Straight away, this is an unstable system. Answer to the question is option A. I think a question is missing. I'll write that question, no issue. In the sequence, it seems that a question is missing. Question is to find the transfer function of the system whose polar plot is given. Actually, I mean, it's a problem of highlighting the things. The polar plot given is actually this. This is the polar plot, right? Where the phase is always minus 90 degree when omega varied from 0 to infinity, while magnitude varying from infinity to 0. Phase being minus 90, that is only one option, that is option A. Its phase is 0, its phase is minus 180, its phase is plus 90. Minus 90, only option A, no other. Which are the following statements correct regarding the root locus? Say root locus, which is obtained using open loop transfer function by varying the open loop gain. It is to study the complete characteristics of the closed loop system. It's not only about stability, it is also about the response analysis. RH criteria, it describes the stability of a system as a function of open loop gain, Routh-Hurwitz criteria. But root locus, that describes stability as well as the transient characteristics. So option A, it can be used to analyze and design the effect of the loop gain on system transient response and stability. Yeah, it is applicable for both. It is answer A. Taking this question, this is where I am feeling that it is an incomplete question, missing data, and certain options also there is a controversy. Something is missing in this question. Either they forgot to give the value of gamma, because the question is about finding the transfer function of a single stage passive lag lead compensator. To discriminate a lag and lead, the value of gamma should be given, because that gamma will be less than 1 for lead compensator, greater than 1 lag compensator. So what exactly the value of gamma? Nothing mentioned. See, the compensator parameter, if I say x, it is actually ratio of 0 unpole, Z by P. If this is less than 1, we call it to be lead compensator. If it is greater than 1, we call it to be lag compensator. And in case of lag lead compensator, lag stage comes first, lead stage comes next. So if you find the ratio of zeros and poles over here, in option A, I get it to be 1 by gamma, gamma, compensator parameters. In option B, I get it to be 1 by gamma, 1 by gamma. I am talking about compensator parameter. In stage 3, I get it to be gamma, 1 by gamma. In option 4, it is 1 by gamma, gamma. Right. See, it cannot be both gamma, or 1 by gamma, 1 by gamma. No way for that. It has to be 1 by gamma, or gamma, 1 by gamma. But for that, the value of gamma should be given. Because if gamma is less than 1, then 1 by gamma greater than 1, and if gamma greater than 1, 1 by gamma less than 1. So there is a controversy. Moreover, two such options are seen. You see that D and A, they are correlating with the compensator parameters. So I say that it's not a complete question, either the options are wrong or the question statement is wrong. I am not providing answer to this. I say that missing data I say, or options does not match. Taking up this, which of the following statements is correct regarding the state variable approach over transfer function? See, we can use state variable to provide feedback in order to obtain the desired characteristics from the system if it is controllable system. So state variable feedback, which is used to obtain the desired location of the pole to meet the desired characteristics. Yes. It includes initial conditions. Yes. And state model, this is not unique. It is a transfer function which is unique, but state model it is not unique. We have the differences, 6 to 7 differences between transfer function and state model. So answer to the question is option B, that state variables can be fed back and it is considering initial conditions, and state model of the system is not unique is the correct answer. Answer to the question is option B. Considering this is very easy. Question is about controllability. This is in standard form and this is in triangular form, upper triangular matrix. So what is these are repeated eigenvalues, this is distinct eigenvalue, no need to use the Kalman's test to check the determinant and everything, waste of time. In case of upper triangle matrix, the condition for controllability, the last row of B should be non-zero for repeated eigenvalues, and for distinct eigenvalue also the row of B should be non-zero. This is non-zero, this is non-zero. Direct answer that the system is controllable. Direct answer, no need of calculation. If the initial state vector x of t naught can be found from u of t and y of t measured over a finite interval of the time t naught, then what? This is the definition of observability. If I can change one state to the other state by applying input within finite time, it is controllability. And if I can observe the state variables in the output over a finite time, that's called observability. This is the definition of observability. The system is said to be observable. This question. Open loop transfer function of a system is given. The question is, what is the time response subject to the step input? See, the step response of first order system is a 1 minus e to the power minus t by t. What is a? Input amplitude, and if the transfer function is not standard. Say standard first order transfer function is 1 upon ts plus 1. Sometimes it will be k upon ts plus 1. Standard input is u of t. Sometimes it will be some alpha u of t. So for me, a is nothing but k multiplied by alpha. But you have to be careful, given is open loop transfer function, we have to refer to closed loop transfer function for response analysis. What is the closed loop transfer function of the system? 20 upon 0.21s plus 1 plus 20. This is in pole 0 form. Converting it into time constant form, 20 by 21 upon 0.21 by 21s plus 1. This is the time constant of the closed loop system that we require, which is 1 by 100. 1 by 100. What about a value? The value of a is going to be, it is this k, 20 by 21 multiplied by the input amplitude, which is 0.8, which is 0.76. So answer to the question is 0.76 1 minus e to the power minus t by t is 1 by 100, which is 0.01. So answer to the question from the option says option B. Where is that option? Which I have messed up. Option B. Yeah. Now the rest of the questions will be taken care.
So let's start the discussion for further questions with respect to the subject control system. Let's deal with the question. What is the transfer function Cs by Rs corresponding to the following differential equation? Very simple question. Directly we can take here the Laplace and we are going to get what? S cube plus 4s square plus 6s plus 3. I am directly taking here C of s common. So what it is? S square plus 6s plus 4 bracket close is nothing but what? R of s. R of s. So what will be your Cs by Rs? Our Cs by Rs is equal to s square plus 6s plus 4 divided by s cube plus 4s square plus 6s plus 3. So let's see the option. S square plus 6s plus 4, s cube plus 4s square plus 6s plus 3, like that. The answer of this particular question is A. Let's move for the next question. What are the steady state error? What are the steady state error for the input of 3 ut, 3 t ut and 3 t square ut, means like step input, ramp input and then a parabolic input, respectively to the system shown in the figure, where the function ut, obviously it's a unit step. So what will be our GSHS? Our GSHS is going to be what? 120 s plus 2 divided by s plus 3 s plus 4. This is nothing but what? Type 0. This is nothing but what? Type 0. For a particular type 0, and obviously based on the option we are not going to go to analyze this particular function much as we did in the GATE exam, but for this particular question based on the option directly we can move ahead. First of all, I am very interested to find out Kp, that is nothing but what? Limit s tends to 0 gs into h of s. So directly I am going to put here 0. So it will be what? Something 120 multiplied by 2 divided by 3 into 4. 3 into 4. Like this we are going to get something. And what do you mean by A? In general we use the formula for steady state error. Like for this we will use A by Kp. We use A by Kp for this particular function. So what will be your A? Is nothing but what? 3, and then this value is nothing but what? 120 multiplied by 2 multiplied by 3 multiplied by 4. So here we can solve a little. We can say here this is 2, this is 60, this is something around, just a minute, here I am just doing something, that is nothing but 1 plus Kp, okay, 1 plus Kp, 1 plus Kp. So A divided by 1 plus, A means what? A means what? A means 3 divided by 1 plus Kp. What do you mean by this? This is nothing but what? 2, then this is 60, then this is 20, like this I am putting here 20, we are going to get what? 3 by 21. 3 by 21, with respect to that we can directly mark the answer. And as you know very well with respect to steady state error, as for a particular type, as we are moving for the next like step input, then ramp input, then parabolic input, with respect to that in the table we have studied the corresponding steady state error going to be infinite. So we are not going to discuss that much. Come to the next question. Come to the next question. This is also a question. This is also a question with respect to steady state error. Okay, when the input is again in the same format, 4UT, 4TUT and something like that, step, ramp, parabolic. This is what? This is what type 1 system. This is what type 1. We can easily find out. Okay, I am not going to write too much here because already you know the concept. This is with respect to type 1, and with respect to type 1, for step input the steady state error will be 0. The steady state error is going to be 0. But with respect to this ramp input, the steady state error is going to be A upon kV, where A is nothing but what? Now 4. And what is now kV? kV is nothing but what? Limit s tends to 0. kV is nothing but what? Limit s tends to 0, s into gs hs. Okay, so now it is 4 divided by this as is going to cancel. 100 multiplied by 2, 100 multiplied by 2 multiplied by 3 divided by 3 into 4. Like this it is going to cancel. Like this it is nothing but 2. Now what? Now here it is what? 50. Now it is what? 50. And if we are going to observe, just a minute, just here I am going to write down directly the calculated value. Okay, I just want to write down directly the calculated value, and the calculated value is going to be, here also I am writing A, directly the calculated value is going to be 1 by 25. So obviously it is not going to be the answer, and obviously for the parabolic it is going to be infinite. The answer of this particular question is nothing but B. The questions are very simple, and as we have to solve within seconds, then only we can attempt the other question. In that way we have to proceed further. Like that all the questions have discussed with respect to the subject control system. For the other subject, the other faculty members going to deal. Thank you.
Dear students, welcome to the session. Greetings of the day. Let us start with question number 62, electrical machines. What are the important characteristics that must be satisfied for the materials used to build core of the transformer? As we know, the core should have a high permeability and it should produce least possible losses. Losses should be as minimum as possible. Highest permeability material. So, '62 answer is B. High permeability, low hysteresis and eddy current losses. Next question is 109. A 3-phase 60 Hz 25 HP Y connected induction motor operates at a shaft speed of almost 1800 rpm at no load. As you know, induction motor at no load operate almost near to synchronous speed. So, synchronous speed is given in the question. This is synchronous speed ns. It operates at full load 1650 rpm. This is the operating speed n. Now, what you are asked in the question is important. Observe carefully. The speed of rotor field with respect to rotor. Speed of rotor field with respect to rotor means speed of rotor RMF with respect to rotor. Nothing is mentioned in the question, simply given an induction motor. It is not rotor fed obviously. So, it is basic stator fed only, conventional type only. So, stator fed, rotor RMF or stator RMF or absolute flux or any flux with respect to stator, answer is ns. With respect to rotor, answer is SNS or ns minus n. So, here very clearly rotor magnetic field with respect to rotor. So, it should be SNS or ns minus n. ns minus n, answer is 150. These two okay. Next, rotor field with respect to stator field. It is not stator. If you break, you will get a problem. If you break, you will get a problem. It should be read like stator field. It should be read like stator field. Rotor field with respect to stator field. You know that in induction motor, in the air gap, stator magnetic field, rotor magnetic field always runs in synchronism, in sync with each other. So, stator field with respect to rotor field or rotor field with respect to stator field, the absolute flux inside, they run at synchronous speed, as you know that with respect to space. So, between them the speed will be 0. The magnetic fields must be stationary with respect to each other, is an important condition for production of torque. So, answer is C. Next, the rotor input of a 3-phase induction motor running with a slip 10% is 100 kilowatt. What is the value of the gross power developed by the rotor? Gross power developed by the rotor or power developed or rotor output, all are same. In this question, the data given is slip. Slip is 10%, means 0.1, and rotor input is 100 kilowatt. And you were asked what is the gross power developed, means rotor output. So, gross power developed is, rotor output is 1 minus S times rotor input. As you know, in the power stages we discussed many a times. The power going on to the rotor, slip times the power will be lost as rotor copper loss. The remaining power, that is 1 minus S times rotor input, is rotor output or gross power developed. That is 1 minus 0.1 into 100 kilowatt, which is nothing but 90 kilowatt. So, answer is C. Next, what are the values of maximum step rate for permanent magnet and variable reluctance stepper motor? Step rate is basically steps per second. how many pulses or how many steps we can give per second. In that, when you compare permanent magnet and variable reluctance, permanent magnet always have a lesser stepper rate compared to variable reluctance. Variable reluctance inertia is lesser and it will have a higher stepper rate. So when you compare here, maximum pulses you can have is 300 for permanent magnet stepper motor, and for variable reluctance it can be more than that. They can never be equal. Variable reluctance stepper motor will always have a higher stepper rate compared to permanent magnet type. That is the basic difference between these two. So maximum you can go for 300 pulses for permanent magnet, 300 is maximum. And now in this 300 which is quite wrong, 300 and 1200. Why 1200 we can support is, in variable reluctance definitely the maximum step rate is higher compared to permanent. So answer is A. Next, consider the following statements regarding ideal transformer. When we start discussing the transformer, first we keep the heading ideal transformer and we say resistance of the windings is 0 and the permeability of the core will be infinite. Reluctance is absolutely 0. Magnetizing current requirement is negligible, 0 we say, right? Same logic. The winding resistances of the primary and secondary of the transformer are 0. This is the right statement. The eddy current loss of the transformer is 0. Yes, this is the right statement. The core of the transformer is having finite permeability. No, infinite permeability. This is a wrong statement. This is not correct. And what you are asked is, what is the statement which is not correct? So your answer should be 3, C only. This is the answer. They didn't ask you what are the correct statements. They asked you what is the wrong statement. This is a wrong statement because for ideal transformer, the permeability should be infinite, not finite. Next, in this question you will see there is a transformer basically operating at 220 volts 50 hertz supply. This is first V1 F1, imagine. Next, what is given is the same transformer is operating with 220 volt, voltage remaining the same but frequency has been reduced. These type of questions we solved in the class like anything, right? So if voltage is remaining same, if frequency has been reduced, immediately how to move on to formulas like this. You know eddy current loss, PE proportional to B square F square, pH proportional to B power 1.6 F. This particular question don't belong to B constant because V by F ratio is not constant. V1 is 220, F1 is 50, V2 is 220, F2 is 40. So if you take V by F ratio here, if you take V by F ratio in the second case, V by F ratio is not constant. So B max is not constant. So if you substitute in place of B max V by F, then PE proportional to V by F. If you keep V square, it will come. If you keep V by F, then in place of B, PE proportional to V square. Next, if you keep in place of V by F here, what you will get is pH proportional to V power 1.6 into F power minus 0.6. This is what you will get. Let this be equation number 1. Let this be equation number 2. Finally, we have to look on to these two equations to solve this question because B is not constant or V by F ratio is not constant in this particular question. Now, eddy current loss depends on V. What is mentioned V? V remains same. As V remains same, eddy current loss remains same in this particular case. Now, what happened to F? F reduced 50 to 40. So, if F is reduced, automatically pH will increase. If F reduce, because minus, F reduce, it is the denominator. So, pH will increase. So, eddy current loss remains the same, hysteresis loss will increase. Hysteresis loss is increasing, eddy current loss remains the same. Answer is D. So, these two equations will help to solve this question because B max is not constant or V by F ratio is not constant. (1100) by 415 volt delta star transformer feeds power to 30 kilowatt 415 volt 3-phase induction motor having efficiency 90% at full load, power factor 0.833. What are the ratings of the transformer and line current of the low voltage side respectively? To solve this, I will draw a simple figure to make you understand the situation. This is the situation given in the question. A delta star transformer 1100 by 415 volt is supplying a 30 kilowatt induction motor. You all know rating of induction motor is communicating you output, very clear, at full load obviously. And if you notice in the question, very clearly given full load, perfect. That word is enough, very authentic now. We can say directly this motor is operating at full load, which means the output of this motor is 30 kilowatt. Efficiency of this motor is 0.9 and operating power factor of this motor is 0.833. This is situation of the motor. Now, we have to immediately come back to input of the motor. Why? Because the transformer output is input of this motor, because the transformer is feeding it, very clearly written, it is feeding power. So, we have to find out input of this motor to find out the current here. If this is IL, if this is VL, you have to find out IL. Once you know IL, we can easily say what is the rating of the transformer and we can say what is the current supplied by the transformer also on low voltage side. Simple now. First, you know efficiency is output by input. So, input is output by efficiency 30 by 0.9, that will be 33.333 kilowatt. This is input of the motor in kilowatt, and you know input of the motor can be written as √3 VL IL cos phi. This is 33.33 kilowatt. Here what is the data we know? Cos phi. Next VL, that is 415 volt. From this what we can calculate IL. So, IL is 33.333 by √3 into 415 into cos phi 0.833. If you solve this, you will get 55.67. This is the current supplied by the transformer secondary or low voltage side. That is what asked in the question. Line current of low voltage side respectively. Line current of low voltage side, this one, IL is 55.67. Now what we have to calculate next one is rating of the transformer. What is the rating of the transformer? √3 VL IL. Output of the transformer is nothing but rating. So √3 VL IL. We have to always specify rating of the transformer in kVA. So √3 VL IL, that is √3 into 415 into IL is 55.67. (40 kVA). So in this question, what all you have to do is you have to calculate input of the motor from the given data. That input should be considered as output of the transformer in kilowatt. From that we can calculate IL because power factor is given. Operating power factor of the motor is given at full load. Now once you know IL and VL, we can calculate rating of the transformer √3 VL IL. Next question. The kVA rating of an ordinary 2-winding transformer increases when connected as an auto transformer because, you know, already in the class we discussed many a times, if you reconnect a 2-winding transformer as an auto transformer, there is a power transfer happening conductively, which is the speciality of an auto transformer. Transformation ratio increase, not a valid statement for this question. Secondary current increase, no. Energy is transferred both inductively, conductively. This is the key factor. The speciality of an auto transformer compared to a 2-winding transformer is here. It lies in conductively transferred power. This is the magic actually. What happens in auto transformer is this only. So once you see this word, you can directly say answer is C. The kVA rating of an ordinary 2-winding transformer increase as well as efficiency also increases because output has been increased or power transfer has been increased. So answer is C. Simple question. Thank you so much. Now from now onwards my colleague will take over.
So hello everybody, welcome back. Just I am going to discuss DC machine and synchronous portion. तो चलिए देखते हैं. क्वेश्चन तो थोड़े easy to moderate ही लगे, right? The lap connected armature winding is suitable for. बताओ lap connected में क्या होगा? तो in lap connected basically what we can see, number of parallel path is equal to A is equal to P. एक कलर क्यों नहीं चेंज हो? ठीक, A is equal to P, right? तो now see here, if number of parallel paths are more, मान लीजिए ऑलरेडी क्लास में भी हम डिस्कस करते हैं, जितने पैरेलल पाथ्स होंगे तो करंट रेटिंग विल इंक्रीज, राइट? बिकॉज पैरेलल पाथ बढ़ने से करंट रेटिंग विल इंक्रीज, तो करंट बढ़ जाएगा, हाँ जी. एंड इफ करंट रेटिंग विल इंक्रीज, सो नंबर ऑफ कंडक्टर्स इन सीरीज विल बी लेस, यस, क्योंकि आपने अलग अलग पाथ में डिस्ट्रीब्यूट किया उसको, राइट? तो वोल्टेज रेटिंग क्या हो जाएगा? कम हो जाएगा. तो क्या हो जाएगा आंसर? 106 है ना ये, हाँ. चलिए सेट बी, राइट? तो इसका ए, लो वोल्टेज एंड हाई करंट जनरेटर, करेक्ट? लो वोल्टेज एंड हाई करंट, सिंपल है. चलिए नेक्स्ट आते हैं. विच वन ऑफ द फॉलोइंग स्टेटमेंट इज नॉट करेक्ट रिगार्डिंग इंटरपोल ऑपरेशन. इंटरपोल वाइंडिंग कहाँ पे लगाते हैं? बिटवीन टू मेन पोल्स. थोड़ा टेपर्ड होता है, राइट? साइज मतलब उसका जो ज्योमेट्रिकल कन्फिग्रेशन इज डिफरेंट देन द मेन पोल्स, राइट? ये सब बातें तो क्लियर हैं. अच्छा, जो कम्यूटेशन प्रॉब्लम है उसको हम ठीक करने के लिए, और जो मिडिल इन बिटवीन जो मिडिल वाला रेंज है उधर आर्मेचर रिएक्शन को भी कैंसिल करने के लिए थोड़ा सा हम उसमें टर्न्स बढ़ा देते हैं, बट मेनली कम्यूटेशन प्रॉब्लम को शॉर्ट आउट करता है वो। तो ये जितने भी, ये एक चीज़ याद रखने, मतलब क्लास में तो पढ़ते हैं हम लोग, जो इंटरपोल वाइंडिंग है एंड कंपनसेटिंग वाइंडिंग बोथ आर कनेक्टेड इन सीरीज विद द आर्मेचर वाइंडिंग, सेम करंट फ्लो होता है, तभी तो जितना वो जनरेट कर रहा है उतना ही ये कैंसिल भी कर पाएगा, राइट। तो कौन सा आंसर हो जाएगा 107 का, दे आर कनेक्टेड इन पैरेलल विथ द, है ना, नॉट करेक्ट बोला है ना, हाँ, तो यानी कि सी करेक्ट है, ठीक है, बिकॉज इट इज नॉट करेक्ट। सीरीज में कनेक्टेड होते हैं दोनों ही, कंपनसेटिंग वाइंडिंग, इंटरपोल वाइंडिंग, दोनों ही सीरीज में कनेक्टेड होते हैं, सो दैट द आर्मेचर करंट विल फ्लो। चलिए नेक्स्ट आ जाइए, एडीसी सीरीज मोटर। हाँ, इसके लिए एक इंटरेस्टिंग पॉइंट बता दूं, राइट। अभी मुझे पता चला, एक हमारा जो फेवरेट स्टूडेंट है उन्हीं ने बताया कि जो डीसी सीरीज मोटर है ना, करेक्ट, ये जो क्वेश्चन है ये बेसिकली पीएस भीमरा का सॉल्व्ड क्वेश्चन है। कई लोग, आप लोगों में से अगर छोड़ दिया होगा पेपर में, बिकॉज काफ़ी लेंदी है, कैलकुलेशन है, ठीक है, इतना टाइम नहीं होता है, तो पीएस भीमरा का सॉल्व्ड क्वेश्चन है, बट तरीका वही है जो आप सब लोग जानते हैं। क्या? तो ई बी प्रोपोर्शनल टू फाई इंटू एन, एंड एज फाई प्रोपोर्शनल टू एन, तो यहां से इक्वेशन बनेगा ई बी प्रोपोर्शनल टू आई ए इंटू एन, राइट। तो जो फर्स्ट कंडीशन है 1000 आरपीएम टेक्स 50 एम्पियर, तो 250 माइनस दैट 50 इंटू व्हाट इज आर 0.6, तो ये दिस ई बी, ये वाला ई बी जो है दैट इज प्रोपोर्शनल टू दैट 50 इंटू स्पीड कितना है 1000, हाँ जी। तो एक इक्वेशन यहां से बनेगा। दूसरा इक्वेशन जब हम बनाएंगे दैट इज 250 माइनस करंट, अब क्या होगा वो तो हमें पता नहीं, तो आई ए इंटू व्हाट इज द टोटल रेसिस्टेंस नाउ 0.6 प्लस 4.4, एंड दिस इज प्रोपोर्शनल टू नया वाला स्पीड वट एवर करंट जो भी है एंड नया वाला स्पीड जो भी है। तो हाउ मेनी, एक ज्यादा अननोन है ना, वन मोर अननोन इज देयर, दैट इज आई ए, करेक्ट ना। अगर सिंपल एन होता तो 1/2 करते सॉल्व हो जाता। टू कैलकुलेट दिस करंट व्हाट बेसिकली वी डू, टॉर्क प्रोपोर्शनल टू फाई इंटू आई ए रिलेशन, राइट। तो टॉर्क प्रोपोर्शनल टू फाई इंटू आई ए, एंड एज वी नो फाई प्रोपोर्शनल टू एन, तो टॉर्क प्रोपोर्शनल टू फाई प्रोपोर्शनल टू आई ए इट इज गिवन। तो टॉर्क प्रोपोर्शनल टू कितना हो जाएगा, फाई प्रोपोर्शनल टू आई ए स्क्वायर, सीरीज मशीन है, ठीक है। बट हियर द पॉइंट इज इट इज नॉट गिवन वेदर द टॉर्क इज प्रोपोर्शनल टू स्पीड और टॉर्क इज प्रोपोर्शनल टू स्पीड का स्क्वायर। तो जनरली जो फैन लोड होता है उसका नेचर कैसा होता है, टॉर्क प्रोपोर्शनल टू स्पीड का स्क्वायर, ये हमें एज्यूम करना पड़ेगा इधर, ठीक है। तो क्योंकि अब भीमरा से लिया है क्वेश्चन, और भीमरा में ये लाइन नहीं लिखा था कि टॉर्क प्रोपोर्शनल टू एन स्क्वायर, सीधे फैन लोड लिखा हुआ है, तो उन्होंने भी नहीं लिखा। वो जो मैं क्लास में भी बताता हूं आपको हमेशा कि वो सीधे क्वेश्चन से बुक से उठा के डाल देते हैं, जो भी बुक में कमियां हैं या कुछ गलतियां है दैट विल बी देयर, राइट। चलो ओके फाइन। तो टॉर्क प्रोपोर्शनल टू एन स्क्वायर, तो टॉर्क प्रोपोर्शनल टू एन स्क्वायर जब हम लेंगे देन आई स्क्वायर और एन स्क्वायर को रिलेट करेंगे तो आई ए प्रोपोर्शनल टू एन। यहां से एक और रिलेशन बनाना पड़ेगा आपको, आई ए 1 बाई आई ए 2 इक्वल टू एन 1 बाई एन 2, और फिर इन तीनों इक्वेशन को सॉल्व कर दोगे। तो क्या आंसर आ रहा है इसका, आई थिंक 641 आ रहा है, ठीक है। भीमरा में सॉल्व में है, वहां से भी देख सकते हो अगर नहीं होता है आपसे तो, बट अभी मैं आपका ज्यादा टाइम खराब नहीं करना चाहता, ये इक्वेशन को तीनों को सॉल्व कर दोगे तो ये आंसर आ जाता है, राइट। चलिए नेक्स्ट आ जाते हैं, what is the value of percentage voltage regulation of an alternator। अब in this question 0.75 लीडिंग दे रखा है, दैट्स फाइन, बट इन नो लोड ईएमएफ दे रखा है, टर्मिनल वोल्टेज दे रखा है, करेक्ट। तो अब इसमें तो कुछ है ही नहीं, हमें पता है EF माइनस वी बाई वी इंटू 100, करेक्ट। तो ये माइनस में आंसर आएगा, और कितना आ रहा है -20%। तो ये अगेन वन वेरी सिंपल क्वेश्चन, करेक्ट। नो लोड माइनस फुल लोड वोल्टेज बाय फुल लोड वोल्टेज, करेक्ट। चलो अब आ जाओ, टू आइडेंटिकल अल्टरनेटर्स आर रनिंग इन पैरेलल एंड कैरी इक्वल लोड्स, यही है, हाँ जी। व्हाट विल हैपन इफ द एक्साइटेशन ऑफ वन अल्टरनेटर इज इंक्रीज्ड। देखो अब इस क्वेश्चन में सबसे पहले जब एक्साइटेशन बढ़ गया, सिस्टम में आपने पंप किया ज्यादा मैग्नेटिक एनर्जी, राइट, तो केवीआर सप्लाइड इट डिक्रीज, ये तो हो नहीं सकता ना, करेक्ट, क्योंकि आपने एक्साइटेशन बढ़ाया है। केवीए सप्लाइड बाय 82 है ना, टोटल केवीए डिक्रीज होगा, ये भी नहीं बोल सकते, राइट तो ये दोनों तो नहीं होगा। अब पावर फैक्टर, तो जनरली जो अल्टरनेटर है जब ऑपरेट कर रहा होता है, इन जनरल हम बात करते हैं, तो लैगिंग पावर फैक्टर पे ऑपरेट कर रहा होता है, क्योंकि लोड इधर है इसीलिए मैं बात बोल रहा हूं। तो अगर वो लैगिंग पावर फैक्टर पे ऑपरेट कर रहा है, मान लो IA और IF, और लैगिंग पावर फैक्टर पे काम कर रहा है, तो अब अगर हम मान लीजिए एक्साइटेशन बढ़ाते हैं, करेक्ट, तो क्या होगा, पावर फैक्टर तो कम ही होगा ना, डिक्रीज होगा, राइट। समझ में आ गया, वीकर मीटर वीकर, या फेजर से भी देख सकते हो जो क्लास में बताया था, राइट। तो वो तो डिक्रीज ही होगा, करेक्ट। तो यहां लिखा है पावर फैक्टर विल इंक्रीज। अब यहां पे अगर हम एज्यूम करें कि ये ऑलरेडी लीडिंग पावर फैक्टर पे था और फिर हम पावर फैक्टर एक्साइटेशन को बढ़ा रहे हैं, तब तो पावर फैक्टर इंक्रीज होगा, बट इट इज नॉट मेंशन्ड हियर। क्लियर है। तो ये चीज अप्रोक्सीमेट अगर आंसर देना हो, कंफ्यूजन है इसमें ए और डी में, बट अप्रोक्सीमेट आंसर देना हो तो ए थोड़ा ज्यादा ठीक लग रहा है, वैसे तो सारे ही गलत हैं। अच्छा, इट विल कीप सप्लाइंग ऑलमोस्ट द सेम लोड। अब लोड, क्योंकि एक्टिव पावर विल नॉट चेंज एज एक्साइटेशन इज चेंजिंग, राइट, एक्टिव पावर रिमेन सेम, तो हम लोग बोल देंगे ऑलमोस्ट सेम लोड ही रहेगा, क्योंकि थोड़ा सा रिएक्टिव पावर का चेंज आएगा। तो ठीक है, इन चारों में जो कम गलती है वो इसमें है, तो इसीलिए चलो ठीक है ना, चारों में हम ए को टिक करके आगे बढ़ेंगे। चलिए अब आ जाते हैं, ए सिंक्रोनस मोटर कनेक्टेड टू इनफाइनाइट बस बार has at constant full load 100% excitation and unity power factor when there is a change in excitation। अब देखो in this question अगर मान लीजिए सपोज change in excitation का मतलब यहाँ पे सिंपल ये है, सबसे पहले किसके बारे में पूछ रहा है, IA वर्सेस IF। मान लीजिए जो भी हमारा, ठीक है, ये वी कर्व लगाओगे तो ऑलरेडी किस पे चल रहा है, दैट इज यूनिटी पावर फैक्टर। हाँ जी सर, अब इसको पढ़ो, तो इसमें जनरेटर है ना, ये मोटर है ना, हाँ जी, तो मोटर में इधर कौन सा होता है, बताया था जनरेटर में राइट साइड में लैगिंग, अगर सब कुछ भूल जाओ तो इतना याद रखना, ये ट्रिक बताया था ना। तो मोटर में राइट साइड में क्या हो जाएगा, लीडिंग, यानी कि ओवर एक्साइटेड अगर मोटर होगा, बताया था आपको, ओवर एक्साइटेड लीडिंग पावर फैक्टर पे होता है, मोटर है, राइट। और अगर इधर देखें तो क्या हो जाएगा, लैगिंग, दैट इज अंडर एक्साइटेड, मोटर अगर है तो लैगिंग होगा, ये भी बताया, ठीक। तो अब बताओ, अगर हम क्या करते हैं, ऑप्शन में देखते हैं, लीडिंग पावर फैक्टर विथ अंडर एक्साइटेशन, एक चीज समझना, हियर इट इज मेंशन दैट द चेंज इन एक्साइटेशन ओनली, तो चेंज लिखा है, ये तो नहीं दिया कि बढ़ा रहे हैं कि घटा रहे हैं, चेंज दिया हुआ है, चेंज मींस बढ़ भी सकता है एंड घट भी सकता है, तो दैट इज मेंशन्ड इन द ऑप्शन। तो लीडिंग पावर फैक्टर विथ अंडर एक्साइटेशन। अब बताओ, ऑलरेडी आप यहां हो, अंडर एक्साइटेशन मतलब पीछे आ रहे हैं, तो जब पीछे आ रहे हैं, राइट, तो लैगिंग होगा ना, क्लियर है। तो ये तो गलत हो गया जी, चलो जी, लैगिंग पावर फैक्टर विथ ओवर एक्साइटेशन, ओवर एक्साइटेशन करोगे मोटर में तो वो तो लीडिंग की तरफ जाएगा, राइट, तो ये भी नहीं होगा। लीडिंग पावर फैक्टर विथ ओवर एक्साइटेशन, यस, ओवर एक्साइटेशन में लीडिंग होगा, तो यानी कि आपका सी क्या होगा, करेक्ट हो जाएगा। कितना सिंपल है, राइट। और फेजर से जो समझाया था वहां से भी समझ सकते हो, बट सिंपल वी कर्व, इन्वर्टेड वी कर्व को यूज कर लो, कम टाइम लगता है। ओके, आई थिंक कंप्लीटेड, ठीक है, चलो, थैंक यू, ऑल द बेस्ट। और क्वेश्चन का जो डिफिकल्टी लेवल है, मुझे तो थोड़ा इजी के डायरेक्शन लग रहा है, मशीन की बात कर रहा हूँ, इजी टू मॉडरेट के बीच में कह सकते हैं, राइट। बस एक क्वेश्चन वो था जिसमें थोड़ा कैलकुलेशन था, क्वाड्रेटिक को सॉल्व करना था, फिर करंट आना था, तो अगर टाइम नहीं है तो छोड़ दो वैसे क्वेश्चन को, बाकी क्वेश्चंस तो थोड़े आसानी है, ठीक है, ऑल द बेस्ट, थैंक यू।
Yeah, greetings of the day. I think that one there are 13 questions in the power system, and the thing is that one is in that what is happening is moderate levels are being there. As far as the numericals are the simple, very simple. But in the theoretical conceptions, what is happening is some mixed type and mixed. मतलब बात है कि multiple options जैसा लग रही हैं, थोड़ा थोड़ा मिक्स हो गया था, थोड़ा कंफ्यूज करके. So जैसा कि आप लोग को मालूम है, बात है कि available answers in the regular classes I used to say one thing is that one is there are multiple options are being the right will be there, out of one which one is the best one that you have to select. This is the one question, it is being that one is the first question, that is okay, what is the kinetic energy? We know one thing is that one is the kinetic energy is equals to what it is being the G into H. So what is the G is MVA rating. MVA rating has been given as a 30, okay, into what is the other thing is that one is H. H is the inertia constant. Inertia constant is being given that 10, okay, kWs means it is the, okay, this one is a joules, kilowatt joules it is being, okay, kWs is this, okay, and actually MWs to be there, and kWs by kVA. So therefore what is happening is kWs by kVA has been given. Here is a small thing that you have to raise. It to be given as MWs by MVA to be given. kWs by kVA has been given, therefore unit are being cancelled, therefore it is finally that you can take it as a 10 megajoules per MVA, right. So into 10, that is equals to how much it is being, it is equals to 300 megajoules. So this is the option that what you can have is, the first option is, this one is the first option that what you can have is, okay. Next is next is, okay, next question. To take this one is, you have to take an eraser and there are your next question is which of the following is correct regarding the advantage of DC transmission over AC transmission. Okay, so we know one thing is that what is happening is here we have to go for the all the advantages that what you can have is here the toggle between the options B and C. Okay, thing is that one is power per country is more corona loss should not be taken as the right option. These are wrong. Okay, this is the wrong thing, okay, right? So therefore you should not take it. Power per country is more, there is a charging current, okay, charging current is not at all been possible with the DC transmission, therefore what is happening, this is also been wrong. I ever tell you, letting you one thing is that one is in the multiple option, multiple choice questions, what is the thing is going to be happening here is, here sometimes what is happening is you have to delete the wrong options. You have to delete the wrong options. By deleting the wrong options, you have to take care of the right options. So in that sense what is happening is, okay, power per country is more, less corona loss and possibility of higher operating voltages is the one option is there. Power per conductor is more, no skin effect and possibility of lower operating voltages. Actually thing is that one is okay, DC, high voltage DC, HVDC system that you are adapting for the high voltages. That is the reason what is happening is, this is the option to be taken correct. Okay, anyhow the advantage is there is the skin effect, but low operating voltages. So you have to see that one is all the options to be in a correct manner. Okay, in such a way that one is, one drawback is being there, but that is being corrected here. Therefore what is happening is answer B is correct here itself. Go for the next question. You can see that one is, which one of the following statements is correct regarding the, okay, shunt series capacitor. Okay, you have to see one thing is that one is shunt and series capacitor. See in classes very simple thing I am saying that one is shunt capacitor is always improves the voltage profile and series capacitor will always the what it is in the stability limit. How it is been? By keeping the series capacitor, we know one thing is that one is power P is equals to what it is been, EV by X sin delta. So that means what is happening is, if you install the capacitor, what is happening is a minus series capacitor, Xc is the reactance will come. The overall reactance is getting decreased, therefore the power transfer level getting increased. As the power transfer level is getting increased, I can say one thing is that the system is maintaining its stability. Okay. So therefore what is happening is, the shunt capacitor improves the power factor, whereas the series capacitor improves the stability of a transmission line. So it is being the absolute answer. Okay. So voltage profile increases means what is happening is the power factor is also getting increased. Okay. See, in classes we expressed one thing is that in fact shunt capacitor is causing the more power factor correction rather than the voltage correction. So therefore what is happening is the option A is right. Going to next question. What is this is? In a smart grid, the model load, fact devices and control production platform as compared to conventional grid are respectively. Okay. So this is the thing that what you can have is right. So in smart grid, the model load, facts, devices and control production platform as compared to conventional grid are respectively. Okay. See, it is the comparison that what is a normal smart grid and as well as the normal grid. So the smart grid what you are calling is with the inclusion of the facts. Facts is always having some kind of a, this one is advantages. So facts means what is happening is, you have to see that one is by making use of the thyristor controllers, regulating of the parameters of the capacitor and as well as the inductor, so that the voltage profile can be improved and as well as the power transfer can be improved. So by making use of the thyristor controller, the adaptive control is always dynamic. So one you take it the dynamic, and one more thing is that one is by nature itself we are calling is the adaptive, and one thing is specified. Okay. So it is not that one is unspecified, it is the specified one, because they have in the limitation, therefore it is a specified. Therefore I can select the answer A for this one. Okay. Right. Next question is, in a large hydropower station has a head of 324 meters and an average flow of 130 meter cube per second. The reservoir of water behind the dams and dikes is composed of series of lakes. So in this question what is happening is, he is asking that one is what is the average power generation. So we can know that one is P average, okay, is equals to 9.81 into 10 to the power of minus 3 eta WQH. Okay. So what is the eta? Is the efficiency. Here nothing has been given, therefore taking that one eta is equals to 100%. That means that one is 100% means you have to put the numerical value of 1.0. Remaining all the things has been given, that is equals to 9.81 into 10 power minus 3 into what it is 1.0 into W is given. Okay. What is the W is that one is a water head. Okay. So that you have to take as a 1000, okay, into what is the other thing is that Q. Q stands for the discharge. Discharge is equal to 1370 and into what is the H? H is a head that equals to 324. So this numerically comes the value of 43554 0.6 something like this. This can be approximately taken as 4350 megawatts. Okay, 4350 megawatts. Okay, this is the thing is, therefore answer B is correct. And here I want to tell you one interesting thing is also that one is, without doing all this calculation also, by the supervision, okay, by superimposition you could be able to get the solution, how it is been. Okay, many times I am telling that in the MCQ question one advantage is being there, you can remove the odd things. Okay, see, this head is a high head. High head power plant generation will never be in the kilowatts. So this is wrong, this is wrong. Therefore there is a tussle between the 4350 and 435 megawatts. Okay, high head power plants, okay, always causing the generation more than 1000 megawatts. Okay, so that is the reason what is happening is it is not the lower value. Okay, it is a medium head power plants can generate this level. So high head can generate this level. So that is the reason what is happening is, without doing any numerical calculation, you can directly tick this one is. Okay, so that is the advantage. That is the thing that you have to observe. Right. Next, see, many times in the classes I used to say one thing is that one is, okay, sometimes what is happening is you have to go through the solution by guess also. Next, which one of the following statements is correct regarding the superheaters in the steam power plants? Okay, you have seen all the 4 options, that is what is happening is in this, okay, you have to see one thing is that in the steam of the boiler is, okay, coming from this level to this level, it is going like this, then the superheating has been starting from here itself and it is going from there itself to come to this one is. So, if you consider this difference of height, okay, so this is the additional cushion that is to be made with the superheater. So, that is what the thing is, okay, so that in modern days what is happening is it is up to 55% it is there, up to 55 in the modern days. So, therefore, what is happening is up to 55% means what is happening is you have to choose the selectivity of more than 40% because less than 20, less than 30, less than 40 are not the right options. Okay, it is being the 55% means it is a more than 40%. Okay, of course, what is happening is it is a pure mechanical question, power plant engineering question, but what is happening, we electrical people will not go that much depth of the this one is a mechanical engineering, but still to find. That is why in the classes I used to say one thing is that one is you have to go a little bit depth for attempting the ESE and GATE. Okay, fine. Next question is that one is what are the advantages of a bundle conductors? Okay, so what are the advantages of the bundle conductors? Okay, we know one thing is that one is bundle conductors we are using for the purpose of what it is being reduction in the corona. So, the first option that you have to consider is the reduction in the corona. Okay, you have seen one thing is that one is, so in the bundle conductor, you know formula of inductance L is equals to what it is been 2 into 10 to the power of minus 7 ln dm by ds. Okay. So, by making use of the bundle conductors, what is happening is the ds is getting increases. The moment when the ds is getting increased, then what is happening is inductance gets reduces. Reduction of inductance, okay, when the inductance is reduced, this causes reactance is also to reduce, because we know that one is x is equals to what it is 2 pi f l. The reduction of the L will cause the reduction of the x also. So, therefore, what is happening is, okay, you need to consider that what are the options are being there, reactance is reduced, that to be taken. Here reactance is increased, okay, therefore, this option not to be considered. And the surge impedance loading, okay, surge impedance loading is reduced, yes, because the thing is that what is happening, surge impedance is reduced, surge impedance loading is also reduces. And one more thing is that one is, as I told you one thing is that one ds increases means GMR is increased. So, here it is given that one GMR is decreased. So, therefore, this also to be taken as a wrong. Right, this one is. Next, what is the other thing is the current loss is reduced, GMR is increased and the voltage gradient is increased. See, if the voltage gradient is getting increased, the current loss will be more. Okay, right. So, voltage gradient increase means what is happening is the level of ionization is getting increased. The level of ionization increased means there is no usage of the bundle conductor. So, that is the reason what is happening is by this wording this also being wrong. So, only the right option is the reactance is reduced, GMR is increased and the voltage gradient is reduced. So, this is the observatory and observation that what you can have is clear. Next, if the loading of the line is less than the surge impedance loading, then which one of the following statement is correct? Yes. So, what you said that one is SIL at SIL, what is happening is power factor is what it is unity power factor. That means that what is happening is it is behaving the resistance, and what you can say one thing is that okay, the reactive power absorbed equal to reactive power generated. Okay, the line capacitance will generate the reactive power, line inductance will absorb the reactive power. Okay, so therefore what is happening is if the loading is less than the surge impedance loading, I told you in the class, if the loading is less than surge impedance loading, means that what is happening is if the loading is less means the current is less, through the line the current is less means inductance is less. So, in this case what is happening is capacitance is a normal, it is a constant value, and inductance is lesser than its specified value, full load value. When the inductance is being less, then what is happening is what I can say that one is reactive power absorbed is less. Okay, the absorbed reactive power is greater than the generated reactive power. Okay, so then what is happening is in this case I am saying that reactive power absorbed is less because the inductance is less. The absorbed reactive power is greater than the generated. So, this is the wrong option that you can have is. Next, the absorbed reactive power is less than the generated reactive power and the receiving end voltage is greater than the sending end voltage. The absorbed reactive power is greater than the generated reactive. So, absorb more बोल रहा था ना, So therefore this also been wrong. So therefore there is a tussle between the B and C. The absorbed reactive power is less, okay, in both the ways it will be same. So and here the receiving end voltage is less than the sending end दिया था, यहाँ तो receiving end voltage is more than the sending end दिया था. So point is that one is when the inductance is being there, so capacitance is of the full value it is being there, then capacitive interference is being more. When the capacitive interference is being more, definitely what I can say that reactive power is at the receiving end sorry, is more than the sending end, okay. So what I can say that one is the absorbed reactive power is less than the generated reactive power and the receiving end voltage is greater than the sending end voltage. Option B is the correct, okay, option B is the right one. Reason is that what is happening is I am saying that one no. So inductance surge impedance loading is less means what is happening is inductance is less, inductance is less means reactive power absorption is less, okay. Then what is happening here is capacitive interference is being more. The capacitive interference is being more, definitely receiving end voltage, because all the capacitance is assumed to be lumped at the receiving end. Okay? So that is the thing is, that is the reason what is happening, we have selected the answer B. Here I am not only giving the answer, okay, I am letting you one thing is that one is why the other options are also wrong. Next, here it is been, what are the overall diameter and metal sheath of the single core cable respectively for working voltage of 80 kV and the dielectric strength of the insulating metal being 60 kV per cm. Okay, this is the thing that what you can have is, you can say one thing is that this is the radius of the, this one is this is the radius of the conductor, and we know one thing is that this is the radius, this is the radius of the cable, and here the some thickness of the sheath will be there. Okay, so I will take this one is, this length is being taken as the what it is being, this is being taken as the 2r, and this can be taken as a what it is being the 2 into r. Okay, this is the thing that what you can have is, right. So in this way you can say that one is for most economical size, most size of R is equals to what it is been what it is been V by E, that is equals to 80 by 60, that equal to 1.33. Okay, now this is the one is. Then what are the question that is being asked that in the dielectrics and the, okay, metal sheath and the, okay, then what is happening is dia. So therefore what is happening is dia of core is 2 into R, that equal to 2.66. Okay, so then what I can think of is, okay, dia of sheath equal to exponential of dia of core. So that is equals to what is happening is exponential of E into what is it? 1 point, sorry, it is wrong, okay, that is E into what is 2.22, okay, therefore that is equal to 2.66 E. This is the option, this is the one option and this is the other option, is 6.66, okay. So therefore what is happening is it is the right answer. Okay, so a letter wise a simple calculation, because we know one thing is that one is calculator is not been admissible. So that is the reason what is happening is you have to give, it is a simple question. This is the answer. So option A is the answer. For that one the solution is this one. Next is which one of the following is correct regarding the reduction in the corona loss. Okay, we know one thing is that what is happening there is corona loss PL is equals to 242.5 F plus 25 delta root over what it is R by D V minus Vc square into 10 power minus 5 kilowatt per kilometer per phase. This is the thing is, okay, this is honest. Now if you see one thing is that one is many times when you say that one is, here you have to relate between the two things. See here the relation that he has given with corona loss with the cross section of the conductor. So therefore what is happening is that proportion that you have to see. As per that what is happening is you can say one thing is that one is PL is proportional to root over R. root over r means what is happening is it is the diameter of the conductor. So therefore what is happening is coronal loss increases with the radius. So coronal loss can be reduced by using the large dia conductor. So reduction, okay, coronal loss is proportional to the dia, therefore loss reduction cannot be possible with increasing the conductor dia. So this is the wrong answer. So where are the large dia, coronal loss can be reduced by the large conductor, okay, therefore this is also wrong option that you can have is by using the large dia of conductors, these also been wrong. So here you can see that one is when the radius means what is happening is the diameter of the conductor is going to be more, okay. Then what is the thing I can say that one is wherever these options are being there, the large dia that you reduce, okay, right. So therefore what is happening is the coronal loss can be reduced by using the small dia conductors, hollow conductors and bundle conductors. Bundle conductors is okay. Hollow conductors, how it is been? What is the reason for the hollow conductors? When you use the hollow conductors, what is happening is you can improve the GMR value. Okay, when the GMR value gets increased, automatically what is happening is voltage gradient decreases, and the voltage gradient decreases means what is happening is the VC is decreases. VC decreases means what is happening is you can see the loss also decreases. So all the three are matching here, therefore I will tick the option B is the right one. See, I am saying one thing is that one is here you have to make the clear cut postmortem and clear cut analysis for each and everything, okay. Accordingly here I am again saying the same thing is that one here I am not letting one thing is why it is correct, okay. I am letting you one thing is that one is why the other options are wrong, found to be wrong. Next. Which one of the following types of relays used to give the directional features of a reactance relay? Right, what is happening is a directional feature, underline this word, directional feature. So directional feature can be given by only one kind of relay, that what it is being, that one is more relay. So impedance relay, okay, is not the thing is that one is it is a non-directional relay, and non-directional reactance relay, okay, definitely what is happening is a reactant by the name itself is indicated the non-directional. So therefore this is the option is wrong, this is the option is wrong, and IDMT relay means what is happening is, what is the thing I can say, IDMT relay is not related, IDMT relay is the time based one, it is not the directional based one. So that is the reason what is happening is momentarily this also not to be considered, that is the reason what is happening is more relay is the right option, okay. Whenever, mind one thing I am saying that one is whenever the property of the direction will come, definitely you have to take care of the more relay. More relay is only the more relay or admittance relay, only the one that is having the directional property. Next one is yes, it is the one is, okay. See here every circuit breaker is having the two capacities, one is the breaking capacity, another is the making capacity, okay. So the two to be given, okay, in the classes I told that when the two are not been given, one only is being given, by default you take, okay, the given capacity as a breaking capacity. So we have to write that one is a breaking capacity is equals to how much it is, 2000 root 3, okay. Now the breaking current IB is equals to 2000 root 3, okay, divided by what it is been, how much it is root 3 into what it is being 20. So this is equals to how much it is, okay, 100, okay, this is equals to 100, okay. Actually thing is that what is happening is here mega, so therefore what is happening is here you have to write the 10 power 3. Reason is that it is the MEA and KV, therefore the what is happening is equal to 100 kiloamperes, alright. So we know one thing is that by the fundamental relations, making current is equals to 2.55 into breaking current. So that how it comes is 2.55 into what is this one is 100. So this becomes as 255 kiloamperes. This is the answer. Simple calculation, as the calculator is not been allowed to you. So therefore what is happening, simple calculation, that is the reason what is happening is the data has been given at 200 root 3. Otherwise generally what is happening is ऐसा नहीं होता है, okay, ऐसा होता है कि 2000 MVA होता है, root 3 is being given because for the cancellation of here and here, okay, that is the thing is. It is a simple calculation, I think you can understand. Next the final thing is that in the nodal admittance formulation in the node voltage matrix has been independent variable is the most economic. Actually thing is that what is happening is in the modeling that you are taking as a I is equals to what it is being the YV matrix that you are taking, okay, this is the matrix and this is the current matrix. So this kind of perception that you have taken, V is the constant, because we know that one is equal to this side is being there, that is the constant, it is the current is the variable, that is the dependent variable that you have taken. Okay. So, in the thing is that what is happening is in view of the computation time, in view of the computer memory only, in view of the both the computation time and memory, in view of the stability, right. So, I select these the right answer. I told you many times one thing is that what is happening is many times I am telling you the same thing is that one is multiple options in that multiple objectives, multiple considerations are being there. In that one answer is 60% correct, one answer is 80% correct. Okay, the answer which is 80% correct to be taken as the take it granted. So, in that sense what is happening is here it is any computation, any modification, any computation that you have taken, there you have to consider for that one is okay to occupy the less memory. Reason is that what is happening is okay here it is y element anywhere comes as 0, okay, y element comes as mere non-connectivity. Suppose if I transform it into the fashion of this equals to V equal to Zi, where I have taken the voltage the dependent variable, then what is the problem? What is the problem? I need to consider the Z parameter when the two components have been within two buses, if the line is not been there, instead of writing the y, okay, Z to be taken as the infinity. So, in your matrix entries of the infinities are being there. So, therefore, that is not been possible. Entries of the infinities are being there means what you have to accommodate there itself. Suppose if it is being the 0, okay, you can adapt a sparse matrix. You can adapt a sparse matrix. With the sparse matrix what is happening is memory requirement is less. As the memory requirement is less, the number of entries are being the less, therefore the computation speed is more. That is the reason what is happening is in respect of computation definitely we have to give this answer. Stability is the general criterion. Okay. I think this is the live. Okay. Thank you very much, okay, for watching this series. Okay. Have a nice time and all the best in future.
Dear students, good evening. Today you given the ESE Prelims examination. I hope you done well, and I'm going to take up the questions given from communication systems, and only 5 questions given from communication systems, and these questions I can say are not direct. Okay. These are some kind of theory questions are given, and even the problems which are given are not direct kind of. Okay. Fine, let's take up these questions. So, I can say being electrical engineer, doing these questions is not easy definitely. Okay. And the questions are given in that way here, okay, from communication systems. Yeah, let's take up the, if you see this question, it is related to AM, and it is the frequency band of AM is given 535 to 1605 kilohertz, it is given, and with an input filter factor of 54. This is the quality factor. Okay, if you take AM receiver in the very much of initial stage, you can use a band pass filter. Okay, and the quality factor of that filter is given as 54. This is Q, I can say. And what are the bandwidths at the low and high ends of RF spectrum respectively. So, generally in even in standard textbooks also you do not see this model of question. So, this is given from one of the I mean to say one of the papers, one of the research papers, this they pick this and they given here. Okay. So, it is definitely not easy to solve this question, and how it goes is, and here the bandwidth at low frequency end. Okay. So, it is the low frequency end and this is the high frequency end, I can say. Okay. And yes, this is and it is related to tune amplifier, I can say. Even you can see like in the very much of initial stage of receiver, in the very much of initial stage of the AM receiver, you can see tune amplifier, okay, and to suppress the image station, the tune amplifier will be used. Before mixer, the tune amplifier will be used to suppress the image station, and for this question is related to tune amplifier, I can say, and yes, if you are good with tune amplifiers, you can solve this. The bandwidth is equals to FR by Q, I can say, okay, for the tune amplifier, and yes, for the low frequency end के लिए this is low frequency end के लिए what is the bandwidth will be equals to. For the low frequency end, what is the resonant frequency? Okay, the tuned frequency, okay, this is I mean to say the resonant frequency of the tune amplifier is made equals to this tuned frequency only. Okay, so in suppressing the image station, if you recall, to suppress the image station, okay, the resonant frequency of the tune amplifier will be made equals to the tuned frequency itself. Okay, so FR is equals to 535 kilohertz. Okay, and the quality factor, actually he missed it in the question itself, because he should mention this as the Q factor. He should mention as Q factor. This is the mistake from the examiner. Okay, he given just the filter factor, he should mention this as the quality factor. Then then you might have get the idea like how to find the bandwidth from the quality factor, but he missed it in the question itself. It is the mistake from the examiner, I can say. And the quality factor is how much? This is 54, and it comes to be this is 9.9 kilohertz, and based on the given options, I can say this is approximating to 10 kilohertz. And if you see the what is the bandwidth at high frequency end, this is bandwidth at high frequency end will be equals to, this is FR is equals to that is 1605 kilohertz, and the quality factor is 54, and it comes to be 29.7 kilohertz. It is coming. So based on the given options, I will go with 10 kilohertz and 29 point. Yeah, this is, I will go with option C here. Okay, yeah, yep. And if you go to this second one, so this is a general question, I can say. Here, which of the above statements will be correct? So here some statements are given. The first statement is digital signals can be coded to yield extremely low error rates and low fidelity. Yes, that's true. Okay. So for transmission of digital data means ones and zeros. Okay, for transmission of digital data, first coding will be done. Okay, the digital data is represented with electrical pulses and transmitted. Okay, and depending upon with which pulses you are representing, okay, you can decrease the probability of error. Of course, you can decrease the probability of error, the chances of error. Yes, you can decrease. And digital signals are easier to encrypt for security and privacy. Yes, that's true. Okay, digital signal storage is expensive. Yes, I can say in the past, in the very much flashback, I can say almost 20 years back, I can say yes, the storing of digital data is expensive. But nowadays, so many techniques we have. Okay, different of devices we got now to store the digital data with very less expensive in very much. Okay, it's not costly now. Okay, with very less money only. I mean to say storing digital data nowadays is not too expensive now. Okay, it's a kind of cheaper thing only nowadays. Okay, in the past, I can say if you go to 20-30 years back, yes, I might go with option statement 3 will be correct. But as of now, I can say I don't accept that digital signal storage is expensive. It's cheaper only nowadays, storing of digital data. So I don't go with statement 3. Okay, so it looks to be as of now, I can say okay, the statements 1 and 2 looks to be correct for me. So I will go with option A. Okay, and if you see this, okay, TDM, it is related to time division multiplexing. TDM is readily implemented with high density VLSI circuitry. Yes, that's true. Okay, so nowadays we are technologically so much of advanced. Okay, so by using high density VLSI technology, so the TDM circuits, ready-made TDM circuits are available to us. Okay, so no need to go for each component separately and constructing TDM, it's not required nowadays. So by using this high end VLSI technology, so where you have the TDM circuits which are ready-madely available to us. Okay, and TDM synchronization is less demanding than that of suppressed carrier FDM. Okay, no, I don't accept it. Okay, synchronization is okay very much of essential, I can say in TDM. Okay, so that is the main problem in TDM is the maintaining the synchronization between transmitter and receiver. Compared to the FDM systems, synchronization is very much of crucial and very much of essential in TDM, I can say. So I won't accept this statement too. Okay, and TDM crosstalk immunity does not depends on the transmission bandwidth. Okay, actually it depends on actually. Okay, the crosstalk. Okay, just interference of one user to the another. Okay, means when multiple users are getting multiplexed. Okay, so one user will get interference with the another. Okay, that leads to some kind of problem that is called as crosstalk. Okay, that crosstalk of course depends on the bandwidth, of course, what is the bandwidth of each user, okay, and what is the channel bandwidth available, and so all this, the sampling rate what you are maintaining, all these factors of course will affect the crosstalk. Okay, so this bandwidth of course will affect the crosstalk. Okay, so the crosstalk immunity, I can say of course it depends on the transmission bandwidth. It is saying it is not depends on the transmission bandwidth, it is what statement 3 is saying. So I won't accept this statement 3. So it looks to be statement 1 is only correct. So I will go with option C. And if you see this the baseband bandwidth in FDM, okay, the net baseband bandwidth in frequency division multiplexing FDM. So I will go with so this is definitely not going to be the product. Okay, so B and D are not correct. And if you see option C also, I don't go for it, because option C is saying you have to subtract the modulated message bandwidth from the guard bands. So if you subtract that modulated the modulated message bandwidths from guard bands, how it will give you the net baseband bandwidth. So because you are subtracting net message, you are subtracting the modulated message bandwidth from guard bands, then how it will give you that net baseband bandwidth? It won't. So I don't go with option C. Okay, so option A looks to be most opted one here. It is the sum of the modulated message bandwidths plus the guard band and the guard band. Okay, so option B, C, D of course are not going to be correct. So the most opted answer is A. So I will go with option A. So and if you see this question, okay, this is a general question, I can say. So during the serial transmission, a group of 526 sequential 12-bit data words is transmitted. So there are two 512 okay data lines are there. You can say this is total 512 data lines are there. Okay, and on each data line 12 bit words are transmitted, 12 bits transmitted, I can say, on each data line. Okay, this is, and altogether I can say is transmitted in 0.016. This total data I can say is transmitted in 0.016 seconds. Okay, then what is the speed of transmission? All the options are given in bits per second. So in 0.016 seconds, this much data is transmitted. Then how many bits transmitted in 1 second we have to find out. So altogether how many bits transmitted in 0.016 seconds here? So this is 512 into 12 bits. Okay, so it comes to be how much? This is 6144 bits transmitted in how much time here? 0.016 seconds. Then in 1 second, okay, in 1 second, so how many bits transmitted? This is how many bits transmitted you have to see. So it will be equals to 1, this is 1 upon, this is, yeah, in 1 upon 0.016 into 6144. Okay, So in 0.016 seconds, if 6144 bits transmitted, then in 1 second how many bits transmitted? Okay, so I will go like 1 upon 0.016 into 6144. Yes, it comes to be 384,000 bits, I can say. So this is 384 kilobits in 1 second, I can say. It is 1000 bits means I can say, so kilobits per second, kbps I can say, 384 kbps. So option A looks to be correct here. Okay. Yes, these are the questions given from communication systems. Okay, I hope you done well in the examination. All the best, guys. Yeah, thank you.
So, hi dear students. So, ESE exam for electrical engineering, the questions are looking very easy. Every time I think in electrical engineering, most of the times they will ask you only theoretical questions. This time also same, the questions are very fundamentally theoretical questions. So, we can answer directly, and myself Adada Rajkumar and my colleague and my friend Iftikhar sir, we both are going to deal today the questions. Okay. First 3-4 questions I will deal, remaining questions Iftikhar sir will take. Yes. Okay. Thank you sir. So, if you see the first question, in op amp in active filters, what are the main points we have to observe here in the options? You can see op amp operating as an active filters. Before seeing the options, I want to tell you, when an op amp is working as an active filter, 3 important points you have to remember. One is high input impedance is very important, because whenever you are connecting a passive filter, loading effect should not be there. For that purpose only we generally use active filters. And the output side, when you are connecting any filter or you are connecting a load, there must be some maximum power transfer, that is called impedance matching. So, they are all the properties attractive for the active filters. And one more thing, in the options I observed, signal amplification. Signal amplification should be there for active filters, because the word itself is telling active filter to the desired level. How much desired we require, that much level we want. According to the option, you can see high input impedance, which is looking correct, low output impedance, and the possibility of the having the signal amplification to the desired level. So, myself option B I am giving as an option for this, which is a accurate answer for this question. Okay. Option B will be good, high input impedance, low output impedance, and the amplification should be to a desired level. Okay. The next question. So, this is a basic question related to diodes, special diodes, Schottky diode, LED, this type of question, and is asking a very simple thing, is cut in voltage positions. If you see the silicon diode, we know that it will have a range of 0.5 to 0.7, but in the option I am seeing 0.6 to 0.7. Okay, that is one answer is correct, silicon diode, and here Schottky diode is there, and one more is light emitting diode. These are called special diodes. Light emitting diodes, please remember, the cut-in voltage will be more than the silicon diode, and Schottky diodes will have a cut-in voltage below the concept of p-n junction diodes. So, according to the options, if you see Schottky diode 0.2 will take, because less than 0.6 to 0.7, and 1.4 volts, which is more than the general silicon diode cut-in voltage. So, option A is looking correct compared to remaining options which I am seeing here. So, option A will be the good answer for this question. Okay. One more question we will deal. So, this is one more question I am seeing here. It is a basic purely on semiconductor physics basic questions. As we in the classroom also, when I teach analog electronics, we deal some semiconductor fundamentals that will help you to solve this type of questions. It is related to two terminologies, one is extrinsic, one is a degenerate. These two words you must learn here. One is extrinsic, one is a degenerate. Extrinsic semiconductor can be two types, it can be N type or P type. Lightly doped we can do it, moderately doped also we can do it, but the same thing if you done heavily doped, suppose the same p-n diode, p type or n type, you done heavily doped, we call in terminology in devices we call it as degenerate semiconductors. This word normally we use in tunnel diode concepts, where we use a very heavily doping for the concept of tunneling effect. So, I am expecting the first option itself looking good for me. Lightly, moderately doped semiconductors are referred to be an extrinsic, good option. When it is doped to such high levels that will act as more like a conductor than semiconductor, it is referred to a degenerate, perfect option. Option A will be the correct answer for this. Okay. Some more questions are there. I am giving to Hiftikar sir, he will deal some more questions. Okay. Thank you.
Yes, thank you Rajkumar sir.
Yeah, thank you.
Every year we observe electrical branch ESE paper will have good number of questions from analog. It is a constant thing in all the years. If you observe, around 15 questions come from analog in prelims electrical ESE paper, which is a very big weightage. I hope dear students, you all have done really well in these questions. Okay, I will be discussing here some more questions. This question is based on oscillator. Okay, it's about a Wien bridge oscillator, which is a standard oscillator, audio frequency oscillator, and here we just have to apply F0 formula. In Wien bridge oscillator, frequency of oscillation is 1 by 2 pi R into C. Okay, they have given F0 how much, 10 kilohertz, and resistor is 10k, and we have to calculate capacitor value. So, we can write here capacitor equal to 1 by 2 pi F0 into resistor. If you substitute the given data, you will get it as 1.59 nanofarad, 1.59 nanofarad, or you can say 1590 picofarad. But if you look at the options, no option matches with this. I think there is a problem with options here. They should have given this as nanofarad, 1.59 nanofarad, then we can take option D as answer. If it is 1.59 nanofarad, then we can say option D will be correct. However, all the options are in pico and no option is matching here. So, it is a controversial question where all options are wrong. If it was 1.59 nano, then we can take option D as the answer. Okay. Then moving to the next question, this one is about frequency stability in an oscillator. I mean, it is about why F0 unstable in an oscillator, why frequency of oscillation F0 is unstable. Okay. First statement says, due to change in temperature, the values of frequency determining components, resistor, inductor, capacitor change. That is a natural thing. Temperature has effect on resistor, inductor, capacitor. We use the word tolerance, right? Resistors have tolerance, they vary maybe because of temperature. Temperature has some effect on RLC, and that will create a change in F0. In all these oscillators, F0 depends on RLC, right? For example, Wien bridge 1 by 2 pi RC. If there is a change in R, if there is a change in capacitance because of temperature, then F0 will definitely change. So, statement 1 is correct here. Then frequency can affect due to variation in biasing conditions and loading conditions. Now, this is also possible.
okay, transistor having some effect of temperature, that may also reflect on frequency of oscillation, okay. Loading also creates some problem on frequency of oscillation. So statement 2 is also correct, and statement 3 says effective resistance of tank circuit is unchanged when the load is connected. When load is connected, effective resistance will change, okay. So statement 3 is wrong. When we connect any load to a tank circuit, then effective resistance of the tank circuit will definitely change. So statement 3 is wrong, and here question is which statements are correct. So what are the correct statements here? 1 and 2. So we can take answer as option A. Then moving to the next question, it is about a PN junction diode, okay, and we have to tell which of these statements are correct. If you read first statement, it says in non-conducting region when PN junction is reverse biased, diode current is exactly 0. Now this is not correct, okay, it will be approximately 0. We know very well when a PN junction diode is in reverse bias, some small reverse saturation current can flow, which can be nanoampere for silicon diode and microampere for germanium diode. So we cannot say current will be exactly 0, it should be like approximately 0. So in that way statement 1 will be wrong here. Then statement 2, diode requires small positive voltage to be applied before it enters conducting region, that is correct, we call it cut-in voltage, right. Applied forward voltage should be greater than cut-in voltage, then only diode will start conducting. So statement 2 is correct. Then statement 3 says for large input voltage or current, diode enters breakdown region in forward direction. Now they should not use the word breakdown here, breakdown normally happens in reverse bias, they should use the word damage. If they use the word damage, then we can take 3 as correct, but they have used the word breakdown. Breakdown we normally use in reverse bias, if you apply large reverse bias, breakdown happens, okay. Forward bias we do not use the word breakdown, in forward bias you may say diode may get damaged if you allow a heavy current. So damage is appropriate word for forward bias, and breakdown word is related to reverse bias. So in that way statement 3 will be wrong. So what are the correct statements here? We have to tell correct statement, right. So only statement 2 is correct, we can take answer as option B. Then we have some more questions which let me see next question. Next one is about conductivity, let me quickly solve it. You have to tell conductivity of a pure semiconductor. There is a direct formula, conductivity is equal to Ni into mu n plus mu p into q. That Ni is given 1.5 into 10 per 10, that electron mobility 1300, hole mobility also given 500, and q we can take 1.6 into 10 to the power minus 19 coulombs. If you substitute those values, you will get it as
option B,
4.32 into 10 to the power minus 6 Simon per centimeter. So in this question the correct answer will be option B. Then there are some questions which Rajkumar sir will take up. Sir, please.
Thank you, sir. Thank you very much. So remaining questions I am completing. Yeah, remaining questions I will complete. You can see this question: what happens to the depletion region and the depletion region capacitance on the PN junction diode with the increased reverse bias voltage? I will not see the options. First we will try to analyze this. When reverse bias voltage is increasing, everybody knows that the depletion width will increase. One point you have to keep in mind. At the same time, as the width increases, depletion width, the capacitance will get decreased, because depletion capacitance can also be called transition capacitance, which is inversely proportional to the reverse bias voltage. So according to this you can take the option. The depletion region widens is correct, and the depletion region capacitance decreases, okay. Option C will be the correct answer for this, okay. Next question, it is related to voltage divided biasing, okay. The first option he has given about voltage divided biasing is voltage divided bias configuration uses two DC bias sources to provide forward reverse bias of the transistor. Generally here in this statement, two batteries for voltage divided bias also we have in the circuits. with one battery also we have. Most of the times in general we do with single battery VCC, because whenever VBB is there at the input, by taking R1 R2 resistors with the help of VCC only, another VBB battery is not required. But in some books we will see VCC minus VE also, but in general we need one DC is enough to make input junction forward bias, output junction reverse bias. So, I am not taking this as a proper statement, because one battery is enough for the DC biasing, and the voltage divided bias provides a very small base current to the transistor compared to the bias current. That is a very normal statement. Bias current is your IC, IB current will take very small in the voltage divided biasing, good statement. Two resistors R1 and R2 we will use to provide the base bias voltage, perfect, because in voltage divided bias the main purpose of taking R1 R2 is to bias the base emitter voltage to be forward bias. So, these two statements are looking good, and this statement in general I can say it is wrong, because only one battery is enough to biasing, two batteries also they take, but one battery is enough for it. So, 2 and 3 I will take the option for it, 2 and 3 will be the most appropriate answers. The next we have a Fermi level question. Generally this question should not be asked for electrical students, because it is completely in depth of EDC question. By chance if anybody do not know, you can leave this question, it is not an issue for electrical students. In N-type semiconductor it is not a problem actually, it is a basic concept of Fermi level. Generally you have energy band, if you take this is EV level and you have some EC level. Most of the students knows, electrical students also, about energy band theory, valence band, conduction band. We have some N type is telling, so the Fermi level will be EFN, will be very close to the conduction band. Fermi levels generally 3 types, for intrinsic it will be in the center of the band theory. If you take close to the conduction band we say N type, if you take this Fermi level close to the valence band we say P type. Here there is a logical question is asking, what is the formula for this? If you see the gap here, EC minus EFN, in your EDC we have formula KT ln of NC by ND, we have a formula like this, KT ln of NC by ND, but here no information, nothing he has given, just he said that as temperature increases from 300 Kelvin to 360 Kelvin, what will happen here, how the energy gap value will change he is asking. From conduction band the Fermi level will move up or down. Generally as temperature increases, whenever temperature increases this gap will increase, because this Fermi level will concentrate towards the intrinsic semiconductor. The intrinsic semiconductor Fermi level will be in the center position. So, it is going down, so that the gap level will increase. So, according to the options if you see 0.26, but he has given 0.3, it is below this, this is a wrong answer, remains unchanged is wrong, 0.26 is wrong, 0.36 above the conduction band, this is above the conduction band is wrong, below the conduction band is correct, because the Fermi level cannot go into the conduction, we are talking below the conduction band. So, option D will be the correct answer. But in general this is a EDC question which is in depth, they ask, no problem, 1 or 2 questions, no issues. Next question. So, it is talking about common base amplifier. Okay. Next question is about common base amplifier, quickly we will finish off. In the active region the collector base junction is forward bias and base emitter junction is reverse bias, a wrong answer, because in amplifier which is in active region the input junction which is base emitter junction should be forward bias, collector base junction should be reverse bias we want. I think in which option we are seeing that in active region, that is wrong. In the cutoff region the collector base and base emitter junctions of the transistor both are reverse bias, perfect, both are reverse bias. Okay. In saturation region collector base and base emitter both are forward bias, this is also correct. And which of the following statements are correct? In this 2 and 3 are correct. So, You can take option B as a correct answer for this. Okay. Yeah. Which of the what are the biasing states of collector base junction, base emitter junction, common emitter transistor? Side by side they are asking two questions, common base and common emitter questions. These are also related to same story. It may be a common base or common emitter. If it to be an active region, the input junction should be forward bias, the output junction should be reverse bias. For this question, I think which option will be suitable here is D, no? The collector base junction is reverse bias and the base emitter junction is forward bias. Perfect answer. Option D will be the correct answer. Okay. I think some more questions are there. Remaining questions my colleague Iftikhar sir will complete it. Sorry, complete kar dijiye. 3-4 questions are there.
Yes.
Yeah.
Yes, Rajkumar. Thank you, Rajkumar sir.
Yeah.
This question is about cutoff region, saturation region, forward active region, and we have to match them with list 2. Normally, cutoff region means all currents will become 0. So, cutoff region will match with IC, IB, IE0. You can do it in this way. P matches with 2. Okay, P matches with 2. Then saturation region. In saturation region, collector current will be less than beta IB. In saturation region, collector current will be less than beta IB. So, we can say Q will match with 3. Okay. Then of course, that forward active region you can say IC equal to beta IB. So, R will match with 1. So, what is the correct option here? P matches with 2, Q matches with 3 and R matches with 1. You can take answer as B option. These are very good questions based on basics, and that is what electrical students are tested in ESE. Your basics should be very good. Okay. Then next question is consider following statements regarding negative feedback in amplifier. It is about what are the effects of negative feedback, right. Negative feedback reduces gain, that is correct. It enhances frequency response, I mean bandwidth will increase, right. When we use negative feedback, bandwidth will expand, so frequency response will improve. So, statement 2 is correct. And then it has higher output impedance. Now, this statement it will depend on the type of feedback. If it is a current series feedback or current shunt feedback, then output impedance will increase, but voltage series and voltage shunt output impedance will decrease. So, statement 3 is not always correct. So, I will take it as wrong. It is not a general statement, it depends on the type of feedback. Okay. So, what are the correct statements here? 1 and 2. So, in this question we have to tell correct statements only. 1 and 2 are correct, we can take answer as A option. Then we have got another question, it is about Hartley oscillator, right. You just have to apply formula. We know F0 in Hartley oscillator, it will be 1 by 2 pi into under root L1 plus L2 into C. This is the formula for F0 in Hartley oscillator, frequency of oscillation. They have given frequency of oscillation 120 kilohertz, capacitance value also given 0.004 microfarad and L2 given 0.4 millihenry. If you substitute all this, you can easily calculate L1. If you do calculation, you will get L1 as 0.04 millihenry, 0.04 millihenry. So, in this question we can take answer as B, option B will be correct. This was a question based on Hartley oscillator.
Completed, I think.
Okay, all questions are done?
Yeah, completed.
Yeah.
So, anyway, for electrical students, I think the questions are very nominal questions, they are not very tough. I think who has attended the classes, they have done well. So, all the best dear students, thank you.
Yeah, best wishes from my side.
Thank you very much.
चलिए आइए अब हम सभी लोग डिस्कस करते हैं पावर इलेक्ट्रॉनिक सब्जेक्ट से रिलेटेड क्वेश्चंस। तो सबसे जो पहला क्वेश्चन है हमारा, द फर्स्ट क्वेश्चन इज द reverse current reduces and the voltage across the power diode grows more negative during the turn off process. So we all have seen the reverse recovery process, and in that current voltage curve we have observed this period, and in the time range we have observed that that particular period is known as reverse recovery time. So the answer of this particular question is C, theoretical question, direct question. चलिए अगले क्वेश्चन की तरफ चलते हैं। अगले क्वेश्चन में इन अ गेट टर्न ऑफ थारिस्टर, गेट टर्न ऑफ थारिस्टर की बात चल रही है, GTO की बात चल रही है। द टर्निंग ऑफ इज अचीव्ड by giving the positive gate signal we can turn on, by giving the negative gate signal we can turn off. The basic question, the basic knowledge we all have, means if we are going to observe the options, the negative current at the gate will continue the turning off process. So the answer of this particular question is D. It is also very simple and direct question. Come to the next question. A separately excited DC motor is to be operated in the first quadrant only. जब हमें DC मोटर को सिर्फ फर्स्ट क्वाड्रेंट पे ऑपरेट करना है तो बेटर है कि हम फर्स्ट क्वाड्रेंट चॉपर का ही यूज करें। और आगे देख लेते हैं क्या बोल रहा है। The converter is used is, obviously we can observe the semi controlled, means half controlled rectifier, fully controlled rectifier. Dual converter is not at all, dual controlled rectifier is not at all required. Obviously 4 quadrant chopper is not at all required, only 1 quadrant operation we want. So the better option, best option is nothing but single phase half controlled rectifier, the best choose. A is the answer of this particular question. Okay, now the next question. If a single phase full bridge voltage source inverter, VSI, single phase full bridge voltage source inverter operated with R load, obviously you know if this is the R load, on the first switching we are going to get the voltage, source voltage across the load. In the next again the source voltage negative cycle we are going to receive as it is, and with respect to the current, if you are going to observe, that current is divided by R of the output voltage. Like that we are getting a square waveform of voltage, a square waveform of current as well. So the answer of this particular question is A only. It is also very simple theoretical question. चलिए अगले क्वेश्चन की तरफ आते हैं। कंसिडर द फॉलोइंग स्टेटमेंट रिगार्डिंग IGBT। चलिए IGBT की बातें हमें पता ही है। It has low input impedance, wrong. C is not, third point is not right. So definitely हमारा B और D तो गलत हो गया, उसमें कोई बात नहीं रही। It combines into advantages of both MOSFET और BJT का एडवांटेज कंबाइंड हमें मिलता है। बहुत सारे एडवांटेज हैं जो MOSFET के हैं, बहुत सारे एडवांटेज हैं जो BJT के हैं, वो हमें कमांडली रिसीव होते हैं IGBT में। वी हैव ऑलरेडी स्टडीड इन आवर क्लास। ओके, फ्री फ्रॉम सेकेंड ब्रेकडाउन इज ऑल्सो ट्रू, लाइक दैट अगर हम देखें सो यस ऑप्शन सी इज अवेलेबल। द आंसर ऑफ दिस पर्टिकुलर क्वेश्चन इज सी। सिंपल थ्योरेटिकल क्वेश्चंस। लेट्स डिस्कस द नेक्स्ट। सो rest question is going to be discussed by respected Jagdish sir. Sir, please sir. Thank you.
Yeah, hello my dear students. As far as power electronics is concerned, all questions are only theoretical questions. Most of the questions are easy questions, almost 13 questions are asked in power electronics. Only 1 or 2 critical questions are asked in power electronics. You should have little bit exposure with even with practical applications. Definitely you can easily answer the remaining questions, right. Now let us go through this question. A power diode can be used as a switch because its resistance can be controlled. So very simple here. See, if I make anode positive with respect to cathode, so diode is forward biased and it will turn on, and if I make anode negative with respect to cathode, diode is reverse biased. So that means forward biased means resistance is very less, reverse biased means resistance is very high, So, you can control the resistance by based on the applied voltage. So, here in this case the option to this question is option D is the right answer. Okay. So, next, yeah, what are the significant advantages of MOS power transistor over BJT? That means, what are the advantages of MOSFET over BJT in the case of pulse power supplies? Yeah, you know that in the case of MOSFET, it is having high input impedance. So, MOSFET is having high input impedance, high input impedance. So, because of high input impedance, the input current drawn by the MOSFET is very low. So, if you go through the options, option A, it is having very high input resistance and the input current is very low, it is of the order of nano amperes. I hope you understood. So, the answer to this question is option A. So, input impedance is very high, high input resistance, and the input current in the sense it is the gate current. So, because of high input impedance, the magnitude of gate current is very low, it is of the order of nano amperes. Okay. So, answer to this is option A, right. I hope it is clear to you. Then next, the function of a capacitor filter in the case of a grids diode bridge rectifier. So, here in a diode bridge rectifier, what for we are using a filter capacitance? So, remove the small load current ripples from the rectified output signal. Yeah, this is the right answer. So, the basic function of a capacitor filter is to remove the small load current ripples. It will remove the ripples in the current waveform from the rectified output signal, that is the right answer. And minimize the voltage, option B, minimize the voltage variations in AC input signal. So, you know, so that is not going to affect that much in the case of an AC input signal. So, that is wrong option. Then reduce the harmonics in the rectified output signal. Of course, this is also right answer, and introduce more ripples in the rectified, that is wrong answer. So, actually if you go through this question, option A and C both are more appropriate here. Okay. So, that is why actually it has to be asked for MSQ actually. Okay. So, here we have two appropriate answers in this case, A as well as C. Okay. Right. Go through the next question, dear students. Yeah. The use of an inductive filter in a rectifier circuit provides satisfactory performance only when, yeah, actually what is the main purpose of inductive filter? For smoothing the shape of the current waveform. So, inductive filter is mainly related with the load current, right. It is mainly related with the load current, right. If the load current is very high, the inductive filter may saturate and act as a short circuit. So, that is why for higher load currents, this is not satisfactorily giving good performance. So, the load current should be as low as possible, so that the inductor will not be saturated. So, answer to this question is option C. I hope it is clear to you, right. So, the next one, the static Scherbius drive can be able to provide variable speed control. Yeah, we have discussed in the regular course also, right. Just go through the notes in power electronics. Most of the questions are theoretical questions and from the notes only, right. So, that is variable speed control we are using. Yeah, next question. Which one of the following statements is correct regarding the series resonant inverter? Yeah. So, regarding in the case of a series resonant inverter, the load current is a square waveform. Actually, the shape of the load current is decided by the circuit parameters of the load. So, definitely that is wrong. The output voltage waveform depends on the damping factor of load impedance. Actually, output current waveform may depend on the damping factor of the load impedance, not voltage waveform. So, that is also the wrong answer. The triggering frequency is higher than the damped resonant frequency. Yeah, this is the right answer, dear students. You know the resonant frequency of RLC network, the switching frequency should be always higher than the resonant frequency. we have already discussed in the regular course also. Next, the input voltage waveform depends on the damping factor of the load impedance. Yeah, that is wrong answer. So, answer to this question is option C is the right answer. Okay. Yeah. Next, which one of the following course used in large mains transformer to reduce the eddy current loss of high frequency? This is important here, high frequency transformers used in power electronics. So, for high frequency transformers used in power electronics, normally we use ferrite core or it is ferromagnetic alloy core, and it is compressed. It is compressed ferromagnetic alloy core. So, by using this compressed ferromagnetic alloy core or ferrite core, we can reduce the core losses. Okay. So, answer to this question is option C. Okay. So, the next, yeah, the next question belongs to the other subject, I hope. Yeah. So, with this we have completed the questions of power electronics. Yeah, with this we have completed the questions of power electronics. Thank you, students. Thank you. Yeah, question number 89 in power electronics. Go through the question number 89. I will read out the question, my dear students. I will read the question. When an induction motor and heater, so we are having induction motor and heater. So, we are having two types of load, induction motor and heater. So, we are using this one by using phase controlled single phase AC voltage controller. So, here this is our single phase AC voltage controller, okay? Single phase AC supply. So, let me use a track or anti parallel thyristors. This is the phase controlled regulator, okay, and this is the load. This is the load. Okay. So, here if the load is induction motor, only the fundamental component of input voltage and current is responsible to deliver useful power, whereas heater, for heating loads, even harmonics are useful for heating loads, right. I think we have discussed this in regular course. In the case of heating loads, along with the fundamental component, even harmonic components are useful to deliver the useful power, whereas in the case of induction motor, only fundamental component of voltage and current is responsible to deliver the useful power. Okay. So, 4 options are given based on this. So, if you go through the options in this, answer to this question is option A. In option A, they have given only fundamental component of output voltage and current is useful in the case of induction motor, but fundamental and harmonics are useful in heater. Yes, of course, for heater fundamental and harmonics are useful to deliver, for heater fundamental and harmonics are useful, for induction motor only fundamental components are useful. So, answer is option A. Okay. Then next question, question number Yeah, that's all I hope. So with this we have completed all the power electronics questions, students. Yeah, thank you.
Hello dear students, so let us do the engineering mathematics solutions. Yes, here you see this question. It's a very simple question beta comparatively from the morning. So this paper is a little bit comfortable mathematics, but those who have trained, okay, especially they have practiced a lot, okay, as per the syllabus. So only those students can get the correct answer within the time, okay. And here that x is a uniform distribution, right? X follows uniform distribution over the interval minus 1 by 2 comma plus 1 by 2, right or not? So therefore, what is our f of x? What is the probability density function is that 1 by b minus a, you know that, right? So this will be 1 by 1, so f of x is 1 here. So then we have to see if y is equal to x square, he is asking e of y. So that means he is asking e of x square, right or not? So we know the ortho moment formula or not? So that is of integral a to b. So minus half to half, okay, minus half to half x square into f of x dx. But f of x is 1 only. So this f of x is 1 here. So therefore this will be of x cube by 3 from minus 1 by 2 to plus 1 by 2. And this answer you are going to get, it is of 1 by 12. Right, 1 by 12 is the answer for this question, okay, right. So I hope it's a very comfortable question, so everybody have done it. But now let us see another question. What is the value of this x of t for t greater than 0 for the given Laplace transform is given. Now he is asking the x of t. So x of t means, so we need to find out the inverse Laplace transform of this. So x of t is given by the Laplace, inverse Laplace transform of s square plus 3s plus 3 divided by here s plus 1 into s minus 2 into s plus 5 here, right or not? So this way. So to do this one, as there are multiple factors in the denominator, we have to go for partial fractions. So if you take this function into the partial fractions as a by, okay, s plus 1 plus b by s minus 2 plus c by s plus 5 here. So then if you do the we do this partial fractions, so then you will be getting here it as s plus 5 into s minus 2, right. So this x of s, if I take it here, x of s if I take it, so this is s minus 2 plus b into s plus 1 into s plus 5 then plus c into s plus 1 into s minus 2, okay. So this is what we have. But you know that this side it is s square plus 3s plus 3 and the denominators gets cancels here. So if you are equating this, you know, quotient of s square we if we equate, so 1 is equal to a plus b plus C beta. So this is the equation we are getting for A, B, C here. Now what is this? A is the coefficient of S plus 1, right, and B is the quotient of S minus 2, and C is the quotient of S plus 5. But now what we do is little bit, I told you ना, मैंने क्या आपको क्या बताया, जब ESE एग्जामिनेशन करते समय ऑप्शन से आंसर निकालने की कोशिश करना, अगर पूरा प्रोसीजर करने लगे ना तो आपका टाइम वेस्ट हो जाएगा। तो इसीलिए हम लोग आप ये ऑप्शंस देख लेते हैं। तो ऑप्शंस में किसका सम 1 हो रहा है, देखिए किसका सम 1 हो रहा है, दिस एंड दिस, सी दिस A, B or C, something like that. Anyway you take A, B, C, you add them, you don't get this 1 here. But if you do this, so you are going to get 1 here. But if you do this, you won't get 1. If you do this, you won't get 1. So this is suppose A and this is B here. So A plus B is not 1 for C is equal to 0, and this is A plus B is not 0. So for C is equal to 0, it is not 1. So only the option D is satisfying, right? So only the option D is satisfying here. So which is satisfying A plus B plus C is equal to 1. So therefore the answer is D here. So ऐसे थोड़ा सा जुगाड़ करना है. So next question.
हाँ, इसी डिस्कशन से काम हो जाता है, ऑप्शंस के बेसिस पर क्वेश्चन बन जाते हैं। अगला क्वेश्चन है, हाँ, दिस इज द क्वेश्चन ऑफ कॉम्प्लेक्स एनालिसिस। बेटा ये सिंपल एक इंटीग्रेशन कह रहे हैं, लेकिन इंटीग्रेशन में z बार का स्क्वायर दिया हुआ, अगर z स्क्वायर होता तो हम लिख देते z³/3, लेकिन z बार का स्क्वायर है तो आपको इसमें कार्टेशियन सिस्टम पे जाना होगा। z बार को लिख सकते हैं x माइनस आयोटा y। तो बेटा ये इंटीग्रेशन अगर देखा जाए तो 0 से 2 प्लस आयोटा, यहाँ तक तो ठीक है, ये है x माइनस आयोटा y होल स्क्वायर। तो dz क्या हो जाएगा फिर, dx प्लस आयोटा टाइम्स dy, बिकॉज z इक्वल्स टू x प्लस आयोटा y, सो dz विल बी इक्वल्स टू dx प्लस आयोटा टाइम dy. But by using the concept of line integral, we have to convert it into a single variable form, either in the form of x or in the form of y, है ना सर, x और y में कन्वर्ट करके। तो क्या करेंगे हम, ये y इक्वल्स टू x/2 के अलोंग सिंगल वेरिएबल निकालते हैं। तो यहाँ से dy की वैल्यू आ गई dx/2, तो dy की वैल्यू dx/2 है, dz इक्वल्स टू यहाँ पे अगर रख देंगे तो ये आ जाएगा 1 प्लस आयोटा बाई 2 टाइम्स dx, इस तरह से लिख सकते हैं। लेकिन x में क्वेश्चन जा रहा है तो x की लिमिट देख लेते हैं। तो x की लिमिट आपको देखो 0 से लेकर 2 तक दी हुई है, तो 0 से 2 x की लिमिट है। अब जब आप इस लिमिट्स में इसको इंटीग्रेशन करेंगे, इंटीग्रेशन 0 to 2, अब इसका होल स्क्वायर आपको बेटा खोलना पड़ेगा और ये वैल्यू आ जाएगी 1 प्लस आयोटा बाई 2 टाइम्स और dx, x माइनस आयोटा बाई का होल स्क्वायर आप ओपन कर दीजिए, वैसे हम कर ही देते हैं, x स्क्वायर और प्लस वाई स्क्वायर माइनस वाई स्क्वायर और माइनस 2 आयोटा एक्स वाई, ये है वैल्यू। यहाँ पर भी आपको y को x/2 रख करके सिंगल वेरिएबल फॉर्म में इंटीग्रेट करोगे और इंटीग्रेट करने के बाद थोड़ा कैलकुलेशन करोगे बेटा, तो इसमें ऑप्शन नंबर ए आपका आंसर आता हुआ दिखाई देगा, 5/3 इंटू 2 माइनस आयोटा। ऑप्शन है, हाँ ऑप्शन ए आएगा, 5/3 2 माइनस आयोटा। यहाँ पर हम पूरा सॉल्व नहीं कर रहे, सिंगल वेरिएबल में जा करके जब y को x/2 रखोगे तो क्वेश्चन क्रैक हो जाएगा। तो ये एक तरीका था क्वेश्चन को करने का।
सर ये क्वेश्चन हमारा वर्कबुक
का क्वेश्चन है, हाँ लगभग ऐसा ही क्वेश्चन वर्कबुक का, लिमिट्स थोड़ी सी अलग थी उसमें, हाँ ऐसा आता है हमारे यहाँ, हमारी वर्कबुक से काफी बार आ जाते हैं सर क्वेश्चन। नेक्स्ट, अच्छा ये क्वेश्चन है, इसमें बेटा हमें लगता है कि ये चैलेंज किया जा सकता है कि इसमें कोई भी ऑप्शन मैच नहीं कर रहा। वैसे तो देखो बहुत ही सिंपल क्वेश्चन है, वीकली अर्निंग दी हुई है फ्रीक्वेंसी के साथ, तो अगर इनकी वीकली अर्निंग देखें तो 10 इंटू 3 इक्वल्स टू 30, 12 इंटू 6 इक्वल्स टू 72 एंड सो ऑन। जब आप ये x है, मतलब जब इसमें कंपैरिजन करेंगे तो जब आप इसमें समेसन x निकाल रहे हो, तो हमने इसको कैलकुलेट करके देखा था, ये समेसन x आ रहा था, इसका समेसन x था, हाँ फ्रीक्वेंसी मीन 12806 और n की वैल्यू आपको दी हुई है 509, तो x बार की वैल्यू सिंपल समेसन x बाई n से अगर कर रहे हैं 12806 डिवाइडेड बाई 509, तो इसकी वैल्यू कैलकुलेट करके 25.15 आ रही है। लेकिन ये वाली चीज़ कहीं मैच नहीं करती ऑप्शंस में। यहाँ देखें ऑप्शंस क्या दिए हुए हैं, ऑप्शंस अच्छा ये रहे, देखो इनमें से कोई भी ऑप्शन मैच नहीं कर रहा है, इसलिए लिख दिया नो ऑप्शन मैचिंग। अब या तो ये कोई टाइपो एरर है या फिर फाइनल आंसर में कुछ प्रॉब्लम रही होगी। खैर वैसे क्वेश्चन इजी है, लेकिन ये है कि ऑप्शन मैच नहीं कर रहा। मूविंग ऑन टू द नेक्स्ट वन। सर एक क्वेश्चन आप डिस्कस करो, फिर मैं अगला करता हूँ।
या सो दिस वन इज कंबाइंड स्टैंडर्ड डिविएशन हियर। कंबाइंड स्टैंडर्ड डिविएशन का फॉर्मूला होता है बेटा, तो कंबाइंड स्टैंडर्ड डिविएशन का फॉर्मूला होता है कि अंडर रूट ऑफ, ठीक है, अंडर रूट ऑफ, यहाँ पर 3 सैंपल दिया हुआ है, यहाँ पर 3 सैंपल दिया हुआ है, ठीक है, 1 2 3 हियर। सो नाउ विल टेक इट हियर n1 सिग्मा 1 स्क्वायर प्लस n2 सिग्मा 2 स्क्वायर, ओके देन
सर ये वाली ले लो, वो पेंसिल मिसिंग है थोड़ी।
सिग्मा 2 स्क्वायर है और ये n3 सिग्मा 3 स्क्वायर है, ठीक है, और प्लस n1 d1 स्क्वायर है, ठीक है, और प्लस n2 d2 स्क्वायर है और प्लस n3 d3 स्क्वायर है, डिवाइडेड बाय ऑफ here n1 plus n2 plus n3 here. So this is the combined mean formula. So if you use this combined mean formula, you will get it. But what is d here? So d1 is understood as x1 minus combined mean of x, combined mean of x. And what is combined mean of x? So combined mean of x कैसे आएगा? देखिए x ही बार ना, तो x ही बार तो so this into this. So 50 into 113, okay, plus combined mean, na? So now this one. So 60 into here 120 plus and 90 into 115 divided by here you will have this 200 here. So this 200. So if you calculate this, so this combined mean you are getting as 116. So 116 you are getting it here. So x1 कितना है? तो x1 कितना है यहाँ पर 113, राइट, तो x1 बार माइनस दिस वन, x1 बार कितना है 113, सो 113 माइनस 116 इज -3 एंड d2 इज x2 बार माइनस combined mean is here 11, sorry, second one is how much 120, so 120 minus 116 is 4 and d3 is here x3 bar minus x combined mean and here it is of 115 minus here it is of 116, so it is going to be -1. So substituting all these values beta, तो n1 कितना था, ये हमारा n1 है, ये हमारा n2 है, ये हमारा n3 है और ये सिग्मा 1 है और ये सिग्मा 2 है और ये सिग्मा 3, ये सारे वैल्यूज अगर आप इसमें ये फार्मूला में लगा देते हैं ना तो आपको कंबाइंड स्टैंडर्ड डिविएशन आएगा 7 पॉइंट हियर दिस वन, सो 7.746 आएगा, 7.746 आएगा बेटा. सो दोज हु नो द फार्मूला दे कैन सॉल्व दिस क्वेश्चन. ओके, राइट, नेक्स्ट क्वेश्चन सर.
लाओ सर. ये देखो, ये उसका क्वेश्चन है, द सोल्यूशन ऑफ दिस डिफरेंशियल इक्वेशन. CFPI मेथड जो होता है ना, इसमें खाली CF पर बेस्ड क्वेश्चन है बिकॉज राइट हैंड साइड इज इक्वल टू 0. इट इज अ लीनियर डिफरेंशियल इक्वेशन ऑफ ऑर्डर 4 विद कांस्टेंट कोफिशिएंट इन x एंड t. तो CFPI से कॉन्सेप्ट कर लेंगे, मतलब हमें CF निकालना है बेटा. CF के लिए ऑक्सिलरी इक्वेशन बनती है, ऑक्सिलरी इक्वेशन इज m⁴ प्लस 4 इक्वल टू 0. अब हाउ टू फैक्टराइज इट, इसको फैक्टर करने के लिए एक तरीका चला सकते हैं आप, m² का स्क्वायर माइनस 2 आयोटा का होल स्क्वायर इक्वल्स टू 0. अगर ऐसा लिख लें तो इसको देखो a² माइनस b² के फॉर्मूले से ये होगा 4 आयोटा स्क्वायर प्लस 4 हो जाएगा, मतलब m² माइनस 2 आयोटा एंड m² प्लस 2 आयोटा इक्वल्स टू 0. अब जब हम फैक्टर करेंगे तो यहाँ से ये प्लस माइनस स्क्वायर रूट ऑफ 2 आयोटा और दूसरी वैल्यू आ जाएगी यहाँ से दूसरे फैक्टर से प्लस माइनस स्क्वायर रूट ऑफ माइनस 2 आयोटा. अब यहाँ पे अगर देखा जाए तो ये प्लस माइनस स्क्वायर रूट ऑफ 2 है और ये क्या है, आयोटा की पावर हाफ, मतलब स्क्वायर रूट ऑफ आयोटा. स्क्वायर रूट ऑफ आयोटा को आप लिख सकते हैं e⁻π/2 आयोटा इंटू 1/2. ऐसे ही दूसरे वाले में देखिएगा, प्लस माइनस स्क्वायर रूट ऑफ 2, ये है स्क्वायर रूट ऑफ माइनस आयोटा. स्क्वायर रूट ऑफ माइनस आयोटा में पहले आप आयोटा के लिखोगे e⁻π/2 आयोटा इंटू 1/2. अब यहाँ से वैल्यू निकालनी है, मतलब मेनली इसमें रूट्स निकालने में टाइट था सिचुएशन, अगर रूट निकल आया तो काम हो जाएगा. अब ये e⁻π/4 हो गया बेटा. अगर आपको याद हो वो आइलर नोटेशन, एक आयोटा थीटा इक्वल टू कॉस थीटा प्लस आयोटा साइन थीटा होता है, तो यहाँ पे ये π/4 है तो कॉस π/4 आएगा 1/√2 और प्लस आयोटा साइन π/4 1/√2. तो अगर इसको देखा जाए तो ये प्लस माइनस 1 प्लस आयोटा आ गया. इसी तरीके से अगर हम दूसरा वाला देखें तो प्लस माइनस यहाँ पे आ जाएगा 1 माइनस आयोटा, ये इसके रूट्स आ रहे हैं, प्लस माइनस 1 माइनस आयोटा 1 प्लस आयोटा. अब आपको 4 रूट्स आने जा रहे हैं ना, तो देखो पहला रूट अगर हम इसमें से 1 प्लस आयोटा ले ले प्लस वाला और यहाँ से ले ले 1 माइनस आयोटा, तो 1 प्लस माइनस आयोटा, और ऐसे ही 2 रूट यहाँ पे से इस जगह से आ रहे हैं, ये है -1 प्लस आयोटा, -1 प्लस आयोटा और इधर से -1 प्लस आयोटा, यहाँ पर भी -1 प्लस आयोटा आ गया. तो प्लस माइनस दोनों जगह से आना चाहिए था, तो ये भी प्लस माइनस आयोटा आपको आता हुआ दिखाई देगा. अच्छा अब देखिए इसको कंपेयर कर लो अल्फा प्लस माइनस आयोटा बीटा और ये है गामा प्लस माइनस आयोटा डेल्टा. तो अगर आप इसमें देखें CF ही इसका आंसर है, तो x इक्वल्स टू CF प्लस PI. तो पी तो आपका 0 है बिकॉज ये होमोजीनियस इक्वेशन है। सी एफ में ई टू द पावर अल्फा, अल्फा की जगह 1 है तो 1 इंटू टी, और C1 cos t, C1 cos बीटा टी प्लस C2 sin बीटा टी, तो ये C2 sin t ऐसा आ गया, प्लस ई टू द पावर ये है -1 तो -1 इंटू टी, और फिर आ गया C3 cos बीटा, आपके पास फिर से 1 है बेटा, ये 1 इंटू आयोटा लिखा है तो डेल्टा की जगह 1, जैसे यहाँ बीटा की जगह 1 इंटू आयोटा था तो cos t और प्लस C4 sin t। अब अगर हम मैच कर लें तो इसमें से कौन सा ऑप्शन मैच कर रहा है? देखो e की पावर -2t वाले तो होंगे नहीं, देखो e की पावर -t, C1 cos t, C2 sin t, e की पावर t, C3 cos t, C4 sin t, ये ऑप्शन सी इज द राइट आंसर ऑफ दिस क्वेश्चन। सिंपल CF में अगर आप फैक्टर करना जानते हैं, इसमें थोड़ा सा कॉम्प्लेक्स एनालिसिस आपको आनी चाहिए, कॉम्प्लेक्स एनालिसिस में आइलर नोटेशन जानते हो तो काम हो जाएगा। खैर ये इसका
एक बार रूट्स आने के बाद भी हम ऑप्शंस को देखे तो भी समझ में
तो
आ
जाता
जाएगा
है, हाँ,
कौन सा सॉल्यूशन आने वाला है।
हाँ, बच्चे कई बार नहीं कर पाते तो ये डिटेल में आ जाती है।
रूट्स आने के बाद ई पावर ये इसका क्वेश्चन रियल पार्ट क्या है उसके हिसाब से ई पावर टी का क्वेश्चन पता है, उसके बाद जो बीटा वैल्यू क्या आ रहा है वो दोनों में देख ले, तो अगर वो 1 आ गया ना तो ऑप्शन क्या होगा? सी।
देखो ये 4 कट जाएगा,
यहाँ पर 4 है, ये 2 है और
ये यहाँ पे गलत हो गया, -2 है तो ये कट गया, इसीलिए ये
ऑप्शन से निकाल सकते हैं,
ऑप्शन से आ सकते हैं।
ठीक है,
मूविंग ऑन टू द नेक्स्ट वन। अच्छा ये तो देखो ये भी ऑप्शन से है, जैसे सर कह रहे थे कि ऑप्शन से, ये भी क्वेश्चन आप ऑप्शन से कर सकते हैं। कह रहे हैं ये जो है ना डिफ्लेक्शन है, ये आपका वेव इक्वेशन 2 डायमेंशनल वेव इक्वेशन होती है, del u by del t इक्वल्स टू del 2u ओवर del x2 प्लस del 2u ओवर del y2, तो u इज अ फंक्शन ऑफ x y z, उसका सोल्यूशन आता है। लेकिन अगर उसका सोल्यूशन आप निकालेंगे सेपरेशन ऑफ वेरिएबल मेथड से, इट विल टेक टाइम। तो सिंपल सी बात है, यही तो आपका कहीं ना कहीं इक्वेशन लिखी है जिसमें कंडीशन आपको दी है कि इनिशियल डिफ्लेक्शन होता है t इक्वल्स टू 0 पर, इसका सोल्यूशन आप कह रहे हैं u इज अ फंक्शन ऑफ x y एंड t, एक्स वाई टी सोल्यूशन है, और इनिशियल में टी की वैल्यू 0 पे देखें, इन किस ऑप्शन से टी की वैल्यू 0 रख करके आपको ये डिफ्लेक्शन मिल जा रहा है? तो बेटा देखो ऑप्शन डी में देखो, यहाँ पे कॉस लिखा है, टी की वैल्यू 0 डालोगे, कॉस 0 1 है, ए साइन पाई एक्स साइन 2 पाई वाई, देखो वो सामने लिखा हुआ है। बाकी किसी भी ऑप्शन में ऐसा नहीं हो रहा है। अच्छा आपको सर इसमें तो हो रहा है लेकिन इसमें टी नहीं है, टी पे डिपेंडेंट होना चाहिए, डिफ्लेक्शन टाइम पे डिपेंडेंट होता है और यहाँ टाइम ही इन्वॉल्व नहीं है इसमें, तो इसका मतलब ये तो कैंसिल हो गया, ऑप्शन डी ही राइट आंसर। देखो फिर से ऑप्शन, आप कई बार देखोगे कि ऑप्शन एलिमिनेशन टेक्निक बहुत काम की होती है, अभी सर ने बोला था, हमको भी ऐसे ही दिख रहा है। मूविंग ऑन टू द नेक्स्ट वन। ये तो सर वर्कबुक का डायरेक्ट क्वेश्शन है, हम सब लोग क्लास में हमेशा कराते रहते हैं,
करते हैं ये बेसिक।
देखो ये वाला तो आपको डायरेक्ट मालूम है, इसका जो है डेरिवेटिव dy बाई dx क्लास 12th का बच्चा भी जानता है, इसे ये हो जाता है एक्स स्क्वायर प्लस वाई अपॉन वाई स्क्वायर प्लस एक्स। इसमें पार्शियल डेरिवेटिव का कॉन्सेप्ट लगा के भी कर सकते थे, माइनस एफ एक्स अपॉन एफ वाई, तो ये तो dy बाई dx आ गया। सामने लिखा है u इक्वल्स टू एक्स लॉग एक्स वाई, तो u इक्वल्स टू एक्स लॉग एक्स वाई की बात करें तो यहाँ पे बेटा ux डेल यू बाई डेल एक्स और डेल यू बाई डेल वाई क्या है? सबसे पहले डेल यू बाई डेल वाई देख लेते हैं, 1 अपॉन एक्स वाई, x विल बी ट्रीटेड एज कांस्टेंट व्हेन वी डिफरेंशिएट पार्शियली विद रिस्पेक्ट टू y, तो 1 अपॉन एक्स वाई और फिर एक्स वाई का x हो जाता है, तो ये सब कैंसिल होके x अपॉन y बचेगा। इसी तरह से जब आप ux y निकालते हैं तो उसमें आ जाता है 1 प्लस लॉग एक्स वाई, ये इसका पार्शियल डेरिवेटिव है जो आप लोग निकाल भी लोगे, मुझे ऐसी पूरी उम्मीद है, 1 प्लस लॉग एक्स वाई। अब देखिए टोटल डेरिवेटिव का क्वेश्चन है, कैसे u इज अ फंक्शन ऑफ एक्स वाई एंड एक्स वाई इज अ फंक्शन ऑफ एक्स अलोन। कैसे एक्स अलोन? ये y इज अ फंक्शन ऑफ x है, although it is in implicit form but still it is a function of x, so we can take y is a function of x. It means if y is a function of x, so u will be a function of x alone. In such type of situation we will apply the concept of total derivative, and the total derivative of this one equals to del u by del x into dx और प्लस डेल यू बाई डेल वाई इंटू डी वाई। ये फॉर्मूला हम लोग क्लास में प्रूफ कराते हैं, तो डी यू में आ गया। अब पूछ क्या रहे हैं ये लोग, आपसे कह रहे हैं बेटा डी यू बाई डी एक्स चाहिए। बच्चे सोचते हैं ये ऑर्डिनरी डेरिवेटिव है, पर जब इस तरह का डायग्राम होता है तो ये टोटल डेरिवेटिव में जाना चाहिए। तो डी यू बाई डी एक्स, सर जरा वैल्यू बोलो तो वहाँ पे ऊपर से क्या, डी यू बाई डी एक्स की वैल्यू हमको लगता है 1 प्लस लॉग एक्स वाई,
लॉग एक्स वाई, और
डी एक्स में डी एक्स कट गया, प्लस
एक्स बाई वाई इंटू
एक्स वाई वाई, और ये नेगेटिव के साथ आ जाएगा, माइनस एक्स स्क्वायर प्लस वाई अपॉन वाई स्क्वायर प्लस एक्स। चेक करते हैं, हाँ वाई स्क्वायर प्लस एक्स। अब अगर इसको चेक करें, देखो इन्होंने सर चालाकी क्या करी, ये माइनस एक्स ऐसे लिख दिया, वाई ऐसे लिख दिया, बच्चों को दिख नहीं रहा था कायदे से, ये माइनस एक्स अपॉन वाई है ना, कंफ्यूज होते हैं, एक्स अपॉन वाई कॉमन है, इन्होंने मल्टीप्लाई करके लिखा है, तो ऑप्शन डी इज द राइट आंसर ऑफ दिस क्वेश्चन। वर्कबुक का क्वेश्चन है इसलिए इसको बहुत डिटेल में
क्लासरूम में इस तरह का क्वेश्चन तो करते ही,
सेम क्वेश्चन सर, सेम क्वेश्चन। मूविंग ऑन टू द नेक्स्ट वन। अच्छा देखो फिर से पर्टिकुलर इंटीग्रल का क्वेश्चन, अब केवल पीआई निकालना है, तो पीआई के लिए आपको क्या करना होगा 1/fd इंटू क्यू, 1/fd केस 2 का क्वेश्चन पीआई में डी क्यू प्लस 1 और cos 2x माइनस 1 केस 2 में करते थे, डी स्क्वायर विल बी रिप्लेस बाई माइनस ए स्क्वायर, बेटा ए की जगह 2 है, ए स्क्वायर इक्वल टू 4 हो गया तो -4 तो यहाँ d हो गया, डी स्क्वायर की जगह -4 रख दो, केस 2 क्वेश्चन है पर्टिकुलर इंटीग्रल का, cos 2x माइनस 1। अब कैसे करें, इस सिचुएशन में रैशनलाइजेशन करना होता है, तो 1 प्लस 4d से मल्टीप्लाई करें तो नीचे होगा 1 माइनस 4d, 1 प्लस 4d इट विल बी 1 माइनस 16 और डी स्क्वायर cos ऑफ 2x माइनस 1। अब बच्चे कुछ गलती क्या करते हैं, पहले डिफरेंशिएशन कर देते हैं, जबकि पहले डिनोमिनेटर को कैंसिल आउट करना चाहिए, फिर से डी स्क्वायर की जगह रख दें 1 प्लस 4d अपॉन 1 माइनस 16 और डी स्क्वायर इक्वल टू -4 तो ये देखो यहीं से पता चल रहा है 16 4 64 और 1 65 तो 65 वाला ही आंसर होगा, ये सब आंसर कट गए, कुछ मत करो 65 आंसर है, कुछ करो मत, बच्चे पूरा निकालने की कोशिश करते हैं, वैसे तो आ ही जाएगा आंसर, लेकिन ये 65 आ रहा है ना डिनोमिनेटर में, इसलिए ऑप्शन सी इसका आंसर है। ओके मूविंग ऑन टू द नेक्स्ट वन।
सो दीज आर रिमेनिंग ऑप्शंस में no one is multiple of
65 1 upon 65
so therefore it is the only answer,
मतलब ऑप्शन एलिमिनेट हो गए। देखो हर बार लगभग ऑप्शन एलिमिनेट हो रहे हैं, ईएस के क्वेश्चन तभी पॉसिबल है ज्यादा करना जब आप ऑप्शंस को एलिमिनेट करिए, और वो चाहते भी हैं। वैसे भी सर जब कोई बच्चा ऑफिसर बनेगा तो कई बार वो चीजों को नेग्लेक्ट करेगा, तभी तो अपना पर्टिकुलर टाइम में काम को कर पाएगा, अगर वो सारी चीजें करने लगे तो क्वेश्चन कैसे होगा, सॉरी मतलब रियल सिचुएशन में काम होगा कैसे। ओके पॉइजन डिस्ट्रीब्यूशन, देखो x इक्वल टू पॉइजन में आपको मालूम है वेरिएंस ही होता है, लेमडा ही वेरिएंस होता है, मीन इक्वल टू वेरिएंस होता है। अब इसमें सीधे फॉर्मूला लगा देते हैं, e टू द पावर माइनस लेमडा पावर 2 अपॉन फैक्टोरियल 2 सक्सेस के लिए इक्वल टू 9 e टू द पावर माइनस लेमडा पावर 4 अपॉन फैक्टोरियल 4 प्लस 90 e टू द पावर माइनस लेमडा पावर 6 अपॉन फैक्टोरियल 6। सर जब इसमें से e की पावर तो सब कैंसिल हो जाएगा सब जगह से, तो लेमडा स्क्वायर बाई 2 इक्वल टू 9 लेमडा की पावर 4 अपॉन 24 प्लस 90 लेमडा पावर 6 अपॉन फैक्टोरियल 6। जब सर इसमें से हम लेमडा कैलकुलेट कर रहे थे तो आ रहा था 0 प्लस -1 और प्लस -2। अब ये एक इक्वेशन है, लेमडा आ गया, क्या सर वेरिएंस नेगेटिव हो सकता है?
नहीं,
क्लास में बताया जाता है हमेशा नेगेटिव वैल्यू कट गई,
लेमडा तो यहाँ पर वेरिएंस होगा,
वेरिएंस है, तो वेरिएंस पॉइजन डिस्ट्रीब्यूशन में वेरिएंस ही लेमडा, यही मीन है, मीन इक्वल टू वेरिएंस, जबकि बाइनोमियल में उल्टा होता है। तो यहाँ लेमडा 0 1 और 2, अब 0 1 2 में से ऑप्शन मैच कौन सा कर रहा है?
0 नहीं ले सकते हैं,
0 ले
सकते, इट इज नॉट अ कांस्टेंट,
कांस्टेंट नहीं है, सही है।
1 2 में दोनों लेने हैं, 1 2 में तो आपको ऑप्शन ए दिख रहा है,
ऑप्शन ए दिख रहा है, बाकी ऑप्शन ही नहीं है, तो 2 भी आया लेकिन वो हमको लेना नहीं है। इस तरह से ये भी क्वेश्चन कंप्लीट। अच्छा सर अब एक आप करो, थकान लग गई।
प्लीज टेक दिस।
ओके
नाउ हियर दिस क्वेश्चन बेटा, दिस इज एक्चुअली दोज हु हैव सॉल्व्ड द वर्कबुक वेरी क्लियरली, सो इसमें से एक ये क्वेश्चन कर सकते हैं। सो हियर द प्रोबेबिलिटी फंक्शन इज प्रोपोर्शनल टू, सी द प्रोबेबिलिटी ऑफ x इज इक्वल टू स्मॉल x इज प्रोपोर्शनल टू x plus 1 into 1/5 to the power of x here, right? So when you remove this proportionality, so it will be k times of x plus 1 into 1/5 to the power of x here, 1/5 to the power of x here. So अगर तभी अब क्या करेंगे ना, so let's take the x values as random variable 1 2 3 and so on here. Now we'll take the probability values here. So probability for x is equal to 0. So what is this you are going to get? See, I have already calculated the values here. So here you are going to get k. So this you are going to get k by putting k x equal to 0, right? X equal to 0. फिर next k x equal to 1, then x equal to 2, then x equal to 3. Like that, if you go on putting the x values here, so you will be getting here 2k by 5, and here you get here 3k by 5 square, and then here it is 4k by 5 cube. So this way it is going on. See here what's happening here, we all know that actually there is an unknown constant in the probability function, that is a here k. So you have to find out this arbitrary constant to be find. So therefore how to find out this unknown constant here? So by knowing we all know that the summation of the probability is equal to 1 or not. So we add up this, so 2k plus 5, right, and here 3k by 5 square and so on is equal to 1. Now if I take k common, it will be 1 plus 2 into 1/5 plus 3 into 1/5 square, okay, plus and so on is equal to 1 here, is equal to 1 here. So this is clearly AGP beta. So that is 1 minus 1 by 5 whole power minus 2, right, is equal to 1. So if you equate this and calculate, you are going to get 16 by 25 beta. तो 16 by 25 आ जाएगा. तो अगर ये वैल्यूज आपको 16 by 25 यहाँ पर लेते हैं ना, so this is 16 by 25 and these values, substitute this k is equal to here. Now he is asking the e of x. So sorry, probability of x less than or equal to 2. So what is that? Less than or equal to 2 means it is probability of x equal to 0 and x equal to 1, and then probability of x is equal to 2 here, right? So this is what x equal to 0 का probability क्या है? k, right or not? So k, then plus here it is of 2k by 5, right, and then it is 3k square, right? Sorry, k upon 5 square only. So now you take k common. So and what is the value of k? It is 16 by 25 of 1 plus 2 by 5 plus 3 by 25. So if you do this minimum calculations, so you will be getting 608 by 625 beta. तो ये आंसर आएगा. So option C is the right answer for this. Okay, only have the patience and do the questions.
ये क्वेश्चन मैं डिस्कस कर दूं सर? हाँ,
yes.
ये वाला मैं कर देता हूँ.
Please take this question.
देखो ये थोड़ा सा घुमा हुआ क्वेश्चन है सर, और हम भी डिस्कस कर रहे थे, तो एक बहुत अच्छा पॉइंट इसमें निकल के आया था, आप लोग भी देखिएगा. अ डाइस इज थ्रोन एज लॉन्ग एज अ नेसेसरी फॉर 6 टू टर्न अप. जब तक 6 नहीं आ जाता तब तक कर रहे हैं. गिवन दैट 6 डज नॉट टर्न अप एट द फर्स्ट थ्रो. फर्स्ट थ्रो में 6 नहीं आया है. अच्छा, कह रहे हैं व्हाट इज द प्रोबेबिलिटी दैट मोर देन 4 थ्रोज आर रिक्वायर्ड. जो पूछा जाता है उसी को ए ले लेते हैं, फेवरेबल इवेंट ए. कह रहे हैं 6 इज कमिंग, more than 4 throws are required. More than 4 throws are required to get 6. ये तो हमने लिख लिया ए को, यही आपसे लगभग पूछा था, लेकिन कंडीशन के साथ पूछा है. देखो गिवन दैट जब भी होता है वो कंडीशन है. इट इज अ क्वेश्चन बेस्ड ऑन कंडीशनल प्रोबेबिलिटी. तो इसको अगर हम कंडीशन को बी मान लें, 6 डज नॉट टर्न अप इन द फर्स्ट थ्रो. 6 is not coming in first throw. इन फर्स्ट थ्रो. ठीक है. अच्छा, अब जरा फॉर्मूला देखते हैं. ए अपॉन बी का फॉर्मूला अगर कहा जाए तो प्रोबेबिलिटी ऑफ ए इंटरसेक्शन बी डिवाइडेड बाय प्रोबेबिलिटी ऑफ बी. अच्छा सर, यहीं पर अगर हम प्रोबेबिलिटी ऑफ बी अपॉन ए का फॉर्मूला लिख ले, बी अपॉन ए का, तो प्रोबेबिलिटी ऑफ बी इंटरसेक्शन ए और डिवाइडेड बाय प्रोबेबिलिटी ऑफ ए. अब देखा जाए इनमें से पूछा क्या गया है. कह रहे हैं 6 more than 4 throws are required to get 6, but the condition is 6 is not coming in the first throw. It means they are asking probability of A upon B, but we have no idea about the probability of A intersection B. We can find, we can replace the value of P of A intersection B from this expression. So writing this one, we will get probability of B upon A into probability of A divided by probability of B. ऐसा लिख सकते थे. अब यहाँ पर खास बात आती है. देखो, अभी हम इसको सर नहीं लिखेंगे, पहले probability of A लिखते हैं. probability of A is more than 4 throws are required to get 6. It means first, second, third और fourth throw में 6 नहीं आया. 6 ना आने की probability होती है 5/6 और 4 times नहीं आया into power 4. ऐसे ही B क्या है, 6 is not coming in the first throw, तो ये सिंपल 5/6. अब प्रॉब्लम है यहाँ क्या लिखा जाए, यही हमने और सर ने आपस में डिस्कस किया था, तो जिस वजह से ये क्वेश्चन में कुछ चालाकी निकल के आई. गौर से कर देखे सर, आप आ जाओ ना सर, आप जरा बोलो. तो
so here the probability of B by A na, so that means he is asking the probability of not getting 6 in the first throw under the condition that more than 4 throws are required to get 6. So that means चार थ्रो तक का भी 6 नहीं आना चाहिए. Under this condition कैसे भी हमको फर्स्ट थ्रो में 6 नहीं आता है ना, कैसे भी. So it is a certain event. So if it is a certain event, then it is. So
हाँ,
the
इसकी
probability is
probability
100%. 100% means
इसकी
it is
probability
1.
1. एक्चुअल में देखिए कंडीशन इन्होंने डाल दी कि 6 आ रहा है 4 थ्रोज के बाद. 6 आ रहा है 4 थ्रोज के बाद. फिर कह रहे हैं पहले थ्रो में 6 नहीं आएगा, तो पहली कह रहे हो नहीं 6 4 के बाद आ रहा है, मतलब आपने पहले डिसाइड कर दिया कि 6 फर्स्ट में नहीं आएगा, तो वो तो ऑब्वियस है. ऑब्वियस मतलब श्योर इवेंट की प्रोबेबिलिटी 1. तो ये बात अगर क्लिक होगी तो क्वेश्चन हो पाएगा, और इसका आंसर आ जाएगा 5/6 का क्यूब, मतलब 125/216. आई थिंक इसमें से ऑप्शन ए था. तो ये सबसे अच्छा पॉइंट था कि यहाँ पे इसकी प्रोबेबिलिटी आपको 1 लेके चलनी है.
1 लेना पड़ेगा. This is the crucial point in
क्रूशियल पॉइंट है. अच्छा क्वेश्चन है, इसको क्लास में कराया करेंगे आगे से, है ना सर. अब आप देख लो आखिरी क्वेश्चन.
Yeah. So this one is a very simple question बेटा, probability का. So यहाँ पर देखा, ये see the kind of language they use to confuse the people here. Okay. So what is the language is that he said that they are independent events, but he said it is B by A. ये क्या होता है ना
What
बेटा,
is
ये
the need of
conditional.
condition?
See, there is no dependency, there is no condition. So that means, so this is simply to be understood as P of B itself. So even though, just to make you to confuse, okay, so that's why he has given that. So probability of A union B beta, so आपको formula पता है by using addition theorem, it is probability of A plus probability of B minus probability of A
intersection B.
intersection B. But आपको तो पता है ना, ये independent event है. So that means this can be written as P of A into P of B here, right? So what is probability of A is, that is 1 by 2. And B is 1 by 2 minus A into, this is 1 by 2 into 1 by 2. So it is 1 minus 1 by 4, that is 3 by 4. So 3 by 4 is the answer. Option D is the right answer.
हम लोग सर क्लास में नहीं बोलते in case of independency condition has no significance.
No significance.
बस उसी
There is
वजह
no
से.
condition, there is no dependency. Absolutely.
अभी बचा है?
Yes, still questions are there.
16 questions are there.
Now,
Okay.
it's a simple question बेटा. इसमें तो देखिए, it's a homogeneous one. D square plus D minus 6 into y is equal to 0. अगर इसका roots लेते हैं ना, so it is 3D, right? 3D minus 2D. So 3D minus 2D होगा ना, so therefore it is 2 comma minus 3 आ जाएगा. So that means e to the power of 2tx solution होगा, e power minus 3tx solution होगा. So e power 2t and e power minus 3t. तो किस में है?
X में, option C.
ये किसी में भी नहीं है, only option C में.
Option C में.
बस हो गया. So no need of these things, nothing. Just put the answer as C here. You, this is the way you can get the answer as simple as that here. Okay.
सर आपने एक बार नोटिस करी, इलेक्ट्रिकल के टेक्निकल के पेपर में 16 क्वेश्चंस हैं, जबकि जीएस के पेपर में 15 क्वेश्चंस आए थे. एक क्वेश्चन ज्यादा आया यहाँ पे, है ना. लेकिन ये है कि इनका लेवल थोड़ा हल्का है और जीएस वालों का क्वेश्चन का लेवल बहुत टाइट था, जबकि इलेक्ट्रिकल के बच्चों को माना जाता है कि उनकी मैथ्स अच्छी होती है. तो जीएस में उन्होंने टफ कर दिया.
They will be writing the mathematics in mains paper also, so they have to study at next level.
इनको सर रिवर्स करना चाहिए था, ये क्वेश्चन जनरल में होने चाहिए थे और
जनरल वाले क्वेश्चंस यहाँ होना चाहिए.
हाँ, तो
actually to be frank, in general studies paper also you have seen, in general papers also there is a more of electronics and electrical questions are there, like Fourier transform, jet transform. So paper उल्टा होना था.
उल्टा होना है.
ये ऐसा दिया है. But anyway, this one is the initial and final values of these y of t beta. So y of t, I think everyone knows that initial value theorem. So what is initial value theorem beta? Limit t tends to 0, f of t is equal to, here limit s tends to infinity s into f of s, right or not? So this, if you apply s tends to infinity s into f of s क्या है बेटा? So 10 into 2s plus 3 divided by, and here s into s square plus 2s plus 5 here. So s gets cancelled. Now if you take even s is if you take common. See, generally what happens, as according to, you know, tends to infinity. When x tends to infinity, as if the numerator and denominator are polynomial, what you have to do? You have to take the maximum degrees. What is the maximum degree का जो कोएफिशिएंट कितना है? ये 20 है. मतलब ये s है ना, तो इसमें से s आएगा. Just let me see. Let me do like this. S tends to infinity. S is common, तो ये 20 plus 3 by 10s something like this. You can write it, right? But this one is s square common and something. But s and s gets cancelled, na? But as s tends to infinity, this will be something by infinite here. So you are going to get, it is 0.
It should be 30 upon s.
Whatever. So it is 3 by 10s लिखा ना. So now, so it is of infinite. So 0. So कहाँ 0 है बेटा? इनिशियल वैल्यू. पहले क्या पूछा है? इनिशियल वैल्यू पूछा है. तो इनिशियल वैल्यू, पहला वैल्यू क्या है? 0 आया हमको. आंसर क्या है बेटा? D है.
ऑप्शन
तो फिर फाइनल वैल्यू का चेक करने की जरूरत ही नहीं है, राइट और नॉट? सो मैंने always we used to tell in the class that, you know, in ESC कुछ ना कुछ जुगाड़ करना पड़ेगा with the options. तो तभी तो आपको जल्दी से जल्दी आंसर मिल जाएगा here. So ये क्वेश्चन दिया बेटा. एक और एक क्वेश्चन है, ये भी सिंपल क्वेश्चन है. So this one is x of t something is given. Okay, so now this one is given and he is asking what is the total area under the function. See, total area under the function के लिए हम ऐसा कर सकते हैं. एरिया तो इंटीग्रेशन है, तो integration of x of t dt here, right? But he has not given any limits. So therefore what we understand is, if you do this integration of this 10 integration sine, okay, t plus 4 by 7, okay, into c also if you want to take this one, and it is integration this one, so it is at 70, you get it right, 70 of minus cos t plus 4 by 7, something like this, you get it, so into c, so whatever it is. But here what is happening here, यहाँ पर क्या होता है कि सबसे ज्यादा अगर मैक्सिमम एरिया पूछ लेता है, क्योंकि लिमिट्स आर नॉट गिवन, अगर आप मैक्सिमम एरिया लेते हैं ना तो दिस वैल्यू इज गोइंग टू बी 1, right, maximum value of cos is going to be 1, so this answer can be 70 here. So therefore 70 can be the answer because there is no limits or nothing is given. So if he is asking the total area means, so maximum we can understand in a single loop, you can recognize in a single loop, that is the maximum value when general idea से निकाल सकते हैं ऐसा, ठीक है,
खत्म.
So that's it beta from mathematics side. So these are the questions. So I hope everyone have written have done the mathematics questions very comfortably, right? So but that the only one thing I can say, that if you want to solve these questions within the time and with some technique and all these things, so you must know the process, you must know the techniques. Unless if you don't know the techniques, you can't give the answers for the for these questions.
सर ऑप्शन एलिमिनेशन भी,
ऑप्शन एलिमिनेशन ये सब करना पड़ेगा, कोई तो जुगाड़ करना पड़ेगा, तभी तो ESE क्वेश्चंस का बन सकता है, ठीक है. एंड दिस इज every time will happen, not only this paper, every year every time it will happen. Okay, that's it for guys.
Okay, thank you so much dear, thank you.
So am I audible? Okay, I know I am audible. So we, me myself, Rohit Tripathi and Naveen sir, we are going to explain questions, solution for the questions of signaling system. ठीक है, तो फर्स्ट क्वेश्चन को देखते हैं. दिस क्वेश्चन इज रिलेटेड टू DFT और इस क्वेश्चन में अगर आप एक चीज़ देखें तो इस क्वेश्चन में एक करेक्शन भी है जो मैं बता रहा हूँ. व्हाट इज़ द रिलेशनशिप बिटवीन H1 एंड H2. H ऑफ के इज़ द DFT, उसका वैल्यू बताना है n k इक्वल टू 1 पर, k इक्वल टू 2 पर, और n पॉइंट DFT है जहाँ n की वैल्यू कितनी है 3. तो जब अगर n की वैल्यू 3 है तो रेंज कहाँ से कहाँ तक होना चाहिए, 0 से n-1, तो 0 से n-1. सो दिस इज़ द करेक्शन पार्ट इन दैट क्वेश्चन. ठीक है, अभी हमने क्वेश्चन को करेक्ट कर लिया है, इसके बाद सॉल्व करते हैं और H1 और H2 का रिलेशनशिप बताना है. ओके, तो इसे दोस्तों इस तरह सॉल्व करना है. What is the formula for DFT calculation? Summation h of n e की पावर माइनस j 2 पाई अपॉन n kn. ठीक है, अच्छा n का रेंज 0 से कहाँ तक, n-1 तक. ठीक है, इसको अब इस तरह लिखता हूँ, समेशन 0 से कहाँ तक मैं लिखूँगा, 2 तक, फिर लिखूँगा h ऑफ n ई की पावर माइनस जे 2 पाई अपॉन एन, एन की वैल्यू कितनी है 3 इंटू के एन। ठीक है, अब अगर देखें तो यहाँ पर ओके एच ऑफ एन गिवन है और रेंज है 0 टू n माइनस वन। n माइनस वन का मतलब 0 से कहाँ तक है, ये 2 तक है। तो यहाँ से 3 सैम्पल्स लिखने हैं एच ऑफ एन के। n को 0 पुट करो तो 1 आएगा, n को 1 पुट करो ई की पावर माइनस 1/5, n को 2 पुट करो ई की पावर माइनस 2/5। ठीक है, तो दोस्तों मैं ज़्यादा टाइम नहीं लेने वाला हूँ आपका, मैं बस कल रिज़ल्ट डायरेक्टली लिख रहा हूँ। एच ऑफ के यहाँ पर फॉर्मूला मैंने लिख दिया है, इसमें के को 1 पुट करेंगे, फिर के को 2 पुट करेंगे, फिर जो 2 सैम्पल्स आ रहे हैं उनका जो रिज़ल्ट आ रहा है वो मैं डायरेक्टली लिख रहा हूँ। इसका सॉल्यूशन मैंने ऑलरेडी कर रखा है। तो एच ऑफ के इक्वल टू 1 पर आंसर आएगा 1 प्लस ई की पावर माइनस 1/5 इंटू ई की पावर माइनस जे 2π/3 प्लस ई की पावर माइनस 2/5 इंटू ई की पावर जे 2π/3। मतलब थोड़ा रीअरेंजमेंट करना पड़ेगा, थोड़ा कन्वर्जन करना पड़ेगा, उसके बाद ये रिज़ल्ट आता है। इसी तरह एच ऑफ के इक्वल टू 2 पर कैलकुलेट करें तो आंसर आएगा 1 प्लस ई की पावर माइनस 1/5, फिर आएगा ई की पावर जे 2π/3, फिर आएगा प्लस ई की पावर माइनस 2/5 ई की पावर माइनस जे 2π/3। यहाँ भी पहले जब आप के की वैल्यू इसमें 2 पुट करेंगे, फिर थोड़ा रीअरेंज करेंगे, एक्सपोनेंशियल का कॉम्प्लेक्स एक्सपोनेंशियल का टर्म आएगा, उसको थोड़ा कन्वर्ट करेंगे तो इस फॉर्म में आएगा। अब अगर ध्यान से आप देखो तो H1 और H2 एक दूसरे के क्या है, कंजुगेट, क्योंकि यहाँ पर माइनस जे को आप जे से रिप्लेस करें तो ये वाला टर्म मिल रहा है, यहाँ जे को माइनस जे से रिप्लेस करें तो ये वाला टर्म मिल रहा है। तो H1 और H2 एक दूसरे के क्या है, कंजुगेट। अब आप सारे ऑप्शंस को देखो तो यहाँ पर कौन सा ऑप्शन मैच हो रहा है, ऑप्शन बी। अभी नेक्स्ट क्वेश्चन की ओर चलते हैं। ठीक है, नेक्स्ट क्वेश्चन है व्हाट इज द ऑटो कोरिलेशन ऑफ द एनर्जी सिग्नल एक्स टी इक्वल टू ई की पावर माइनस टी इंटू यू टी। तो अभी क्या कैलकुलेट करना है, ऑटो कोरिलेशन। ओके, सो आर एक्स, इसको इस फॉर्म में लिख देता हूँ, आर एक्स एल, ये कैलकुलेट करना है। और ऑटो कोरिलेशन कैलकुलेट करना है तो अगर कन्वोल्यूशन के हेल्प से कैलकुलेट करें तो मैं इस फॉर्म में लिखूँगा एक्स ऑफ टाउ, एक मिनट, एक्स ऑफ टाउ कन्वोल्यूशन विथ एक्स ऑफ माइनस टाउ। सिग्नल को सिग्नल के साथ, सिग्नल को सिग्नल के फोल्डेड वर्जन के साथ आप कन्वॉल्व कर दे तो ऑटो कोरिलेशन मिल जाता है। अब इस पर क्या अप्लाई करो, फूरियर ट्रांसफॉर्म। सो आर एक्स ओमेगा इज इक्वल टू एक्स ऑफ ओमेगा इंटू एक्स ऑफ माइनस ओमेगा, टाइम रिवर्सल प्रॉपर्टी एक्स ऑफ माइनस टाउ का फूरियर एक्स ऑफ माइनस ओमेगा। ठीक है, अब अगर यहाँ से आप एक्स ऑफ ओमेगा लिखें तो कितना आएगा, 1/1 प्लस जे ओमेगा। ओके, 1/1 प्लस जे ओमेगा, एक्स ऑफ माइनस ओमेगा कितना, 1/1 माइनस जे ओमेगा। आप दोनों को मल्टीप्लाई करो तो 1/1 प्लस ओमेगा स्क्वायर। ठीक है, अच्छा, अब जब इसका इन्वर्स कैलकुलेट करना है तो आप इस वाले फॉर्मूले को यूज़ कर लेना, ए की पावर माइनस ए मॉडुलस ऑफ टी फॉर ए ग्रेटर देन 0। फूरियर आप लिखते हैं 2a/a स्क्वायर प्लस ओमेगा स्क्वायर। आप इसी में ए को पुट कर दो 1, तो ए की पावर माइनस मॉड टी, फूरियर विल बी 2/1 प्लस ओमेगा स्क्वायर। अब क्या करो, इसे दोनों साइड 2 से डिवाइड कर दो। ठीक है, तो 2 से 2 का टर्म क्या होगा, कैंसल आउट। ओके, तो LHS में क्या लिखूँगा, 1/2 ई की पावर माइनस मॉड टी। RHS में क्या, 1/1 प्लस ओमेगा स्क्वायर। तो 1/1 प्लस ओमेगा स्क्वायर का अगर आप इन्वर्स फूरियर ट्रांसफॉर्म लिखें तो अगर टी के टर्म्स में लिखे तो 1/2 ई की पावर माइनस मॉड टी, और टाउ के टर्म्स में लिखे तो 1/2 ई की पावर माइनस मॉड टाउ। हमें किसके टर्म्स में लिखना है, टाउ के टर्म्स में। ओके, अब इसका अगर इन्वर्स लिखोगे तो आर एक्स एल मिल जाएगा। तो अभी हम लोग क्या लिखने वाले हैं, आर एक्स ओमेगा का इन्वर्स फूरियर ट्रांसफॉर्म, इन्वर्स फूरियर ट्रांसफॉर्म। तो हमें क्या मिलेगा, आर एक्स एल या फिर आर एक्स टाउ मिलेगा। यहाँ पर एक चीज़ आप देख लो, जैसे टाउ के टर्म्स में लिखा है तो यहाँ टाउ के टर्म्स में हमें लिख देना चाहिए। तो एक करेक्शन यहाँ पर कर देता हूँ, यहाँ पर इसे मुझे टाउ के टर्म्स में लिखना है। ठीक है, आर एक्स टाउ इज इक्वल टू दिस, फिर फूरियर अप्लाई किया, आर एक्स ओमेगा कैलकुलेट किया, फिर इन्वर्स अप्लाई किया, तो हमें वापस से क्या मिलेगा, आर एक्स टाउ। तो यहाँ जो आंसर आया है इसमें टी की जगह क्या लिख दो, टाउ, 1/2 ई की पावर माइनस मॉड टाउ। अब अगर आप चेक करो तो कौन सा ऑप्शन मैच हुआ, ऑप्शन डी। ओके, नेक्स्ट क्वेश्चन की ओर चलते हैं। सो लेट्स सी व्हाट इज द नेक्स्ट क्वेश्चन। अच्छा, नेक्स्ट क्वेश्चन में एक एलटीआई सिस्टम है जिसमें फर्स्ट डाटा कुछ ऐसा है, फॉर इनपुट यूटी। ओके, आउटपुट ऑफ एलटीआई सिस्टम इज जी ऑफ टी। पहला काम, सबसे पहले क्या कैलकुलेट करना चाहिए, ट्रांसफ़र फंक्शन। ओके, ट्रांसफ़र फंक्शन कैसे मिलता है, लैप्लास ऑफ आउटपुट डिवाइडेड बाय लैप्लास ऑफ इनपुट। नोटेशन मैं डैश के टर्म्स में लिख देता हूँ। ओके, व्हाट इज द लैप्लास आउटपुट, आउटपुट ये वाला टर्म है, मतलब वाई डैश टी की जगह यहाँ पर जी ऑफ टी है। ओके, तो वाई डैश टी, मैंने वाई डैश टी किसको अज्यूम कर लिया है, जी ऑफ टी को, और एक्स डैश टी मैंने किसको अज्यूम किया है, यू ऑफ टी को। ठीक है, तो अभी दोनों का क्या लिखेंगे, लैप्लास। ठीक है, तो वाई डैश एस मतलब जी टी का लैप्लास लिखो, तो आप लिखते 2 अपॉन एस प्लस 1 माइनस 1 अपॉन एस प्लस 5। ठीक है, डिवाइडेड बाय ये जो इनपुट है इसका लैप्लास 1 बाई एस। तो एच ऑफ एस आप लिखते एस इन ब्रैकेट 2 अपॉन एस प्लस 1 माइनस 1 अपॉन एस प्लस 5। थोड़ा क्रॉस मल्टीप्लिकेशन करो, एस इंटू 2s प्लस 10, पहले 2 से इसको मल्टीप्लाई किया, अब इधर लिखो माइनस एस माइनस 1 अपॉन एस प्लस 1 इंटू एस प्लस 5। ठीक है, थोड़ा रीअरेंज कर लो तो एच ऑफ एस मिल गया। तो एच ऑफ एस कितना आया, एस इंटू 2s माइनस एस कितना, एस, 10 माइनस 1 कितना, 9 अपॉन एस प्लस 1 इंटू एस प्लस 5। हम लोग यहाँ तक पहुँच गए। अच्छा, अब इसके बाद इसमें सेकेंड डाटा क्या है, सेकेंड पार्ट क्या है, व्हाट इज़ द रेस्पॉन्स व्हेन इनपुट इज डीसी सिग्नल 1। तो दोस्तों यहाँ पर इनपुट क्या है, डीसी सिग्नल 1। अब इसके लिए एक रिजल्ट लिख देता हूँ, फॉर डीसी सिग्नल ए नॉट आउटपुट ऑफ एलटीआई सिस्टम is given by this formula h of s at s equal to 0 into input dc a naught। आप इसी फॉर्मूले में बस केवल a naught को क्या पुट कर दो, 1। तो जब इनपुट dc सिग्नल 1 है तो फिर LTI सिस्टम का आउटपुट आप लिखते h of s at s equal to 0 into इनपुट dc 1। अच्छा, अब h ऑफ s में s को 0 पुट करो, तो यहाँ पर देखो न्यूमरेटर में ही एक टर्म है s का, एक फैक्टर है s का, s को 0 पुट करते ही ये टर्म कितना हो जाएगा, 0। तो सिस्टम का आउटपुट डीसी सिग्नल 1 के लिए कितना आया, 0। तो कौन सा ऑप्शन आंसर आया, ऑप्शन ए। बढ़ते हैं नेक्स्ट सवाल की ओर। नेक्स्ट सवाल कुछ ऐसा है जिसमें लैप्लास ट्रांसफॉर्म गिवन है और हमें क्या करना है, हमें इन्वर्स कैलकुलेट करना है। ओके, तो लैप्लास ट्रांसफॉर्म गिवन है, हमें इन्वर्स कैलकुलेट करना है, तो पार्शियल फ्रैक्शन परफॉर्म करो, सम कांस्टेंट a अपॉन s प्लस 1 प्लस सम कांस्टेंट b अपॉन s माइनस 2 प्लस सम कांस्टेंट c अपॉन s प्लस 5। ठीक है, तो अगर 3 टर्म्स हैं तो इन्वर्स में 3 टर्म्स तो आएंगे ही, मतलब अगर आप देखें तो a और b तो आंसर है नहीं, मतलब आंसर c या d में से कोई एक पॉसिबल आंसर है। अभी हमें चेक करना है कि इन दोनों में से कौन सा पॉसिबल आंसर है। अब अगर देखें तो अगर आप e की पावर माइनस टी का, आप यहीं से पता चल जा रहा है s प्लस 1 यहाँ पर है, तो इसके इन्वर्स में e की पावर माइनस टी का टर्म आएगा। तो अब आप देखिए 3 टर्म्स आएंगे और 3 टर्म्स में इसमें कहीं भी e की पावर माइनस टी का टर्म है ही नहीं, मतलब ऑप्शन सी आंसर है ही नहीं। आंसर कौन सा ऑप्शन है, ऑप्शन डी। ये यहीं से पता चल जा रहा है, इसलिए फर्दर रेसिड्यू ए बी सी कैलकुलेट करने की कोई रिक्वायरमेंट नहीं है। ठीक है, अभी आगे बढ़ते हैं। अच्छा, अब यहाँ से जो आंसर है नवीन सर बताने वाले हैं, तो नवीन सर प्लीज़ आप रिमेनिंग क्वेश्चंस का आंसर बताएं। ओके, ठीक है, चलो मैं इसका आंसर बता देता हूँ, इसके बाद आगे बढ़ता हूँ। ओके, तो यहाँ पर एक सिग्नल है कुछ इस फॉर्म में। ओके, तो x ऑफ n इज इक्वल टू सिंक ऑफ ओमेगा सी एन अपॉन पाई। ठीक है, सिंक ऑफ ओमेगा सी एन अपॉन पाई। इस सिग्नल के लिए क्या कैलकुलेट करना है, एनर्जी। ओके, पहला काम सिंक को किस में कन्वर्ट करो, सैम्पलिंग में। तो आप इसे इस फॉर्म में लिख सकते हैं, या सिंक में ही लिखना है तो जैसे सिंक ऑफ थीटा है तो आप क्या लिखोगे, साइन पाई थीटा अपॉन पाई थीटा। तो पहले उस फॉर्म में लिख देता हूँ। आप अगर सिंक ऑफ थीटा को देखें तो सिंक ऑफ थीटा आप क्या लिखते हैं, साइन पाई थीटा अपॉन पाई थीटा। ओके, तो इसी रिजल्ट को मैं यूज़ करता हूँ, तो लिखूँगा साइन पाई इंटू ओमेगा सी एन अपॉन पाई ओमेगा सी एन अपॉन पाई। अभी क्या होगा, पाई से पाई का टर्म कैंसिल आउट होगा, तो ये टर्म कैंसिल आउट हो गया। तो हमने क्या लिखा, ध्यान से देखना आप लोग, साइन ओमेगा सी एन अपॉन ओमेगा सी एन। थोड़ा और रीअरेंज करते हैं, इसको ऐसे लिखते हैं, साइन ओमेगा सी एन अपॉन पाई एन ओमेगा सी न्यूमरेटर में पाई। आप अगर इसको रीअरेंज करेंगे तो ये टर्म और वो टर्म दोनों सेम है। ओके, अब अगर यहाँ पर देखो तो एक स्टैंडर्ड रिजल्ट यूज़ करने वाला हूँ। ये जो टर्म आप देख रहे हैं, दिस टर्म, इसका अगर आप DTFT आप ड्रॉ करें, ठीक है, इसका अगर आप DTFT ड्रॉ करें तो मिलेगा एक रेक्टेंगल। ओके, एक्सटेंशन होगा माइनस ओमेगा सी से ओमेगा सी तक, एम्पलीट्यूड कितना होगा 1, बट यहाँ पर ये मल्टीप्लाई किससे हो रहा है, पाई बाई ओमेगा सी से, तो इधर एम्पलीट्यूड को किससे मल्टीप्लाई करोगे, पाई बाई ओमेगा सी से, तो रिजल्टेंट एम्पलीट्यूड पाई बाई ओमेगा सी। और याद रखिएगा DTFT 2 पाई के साथ रिपीट होता है, तो मैंने जो भी ड्रॉ किया है वो माइनस पाई से पाई वाले फ्रीक्वेंसी रेंज में ड्रॉ किया है। अभी हमने क्या किया, अभी हमने DTFT ड्रॉ कर लिया, मतलब दिस इज़ दी DTFT एक्स ऑफ ई की पावर जे ओमेगा। अब हमें क्या कैलकुलेट करना है, एनर्जी ऑफ एक्स ऑफ एन। एक बार देख लेता हूँ क्वेश्चन में, ठीक है, एनर्जी ऑफ एक्स ऑफ एन, ठीक है। तो अभी क्या यूज़ करेंगे, पार्सेवल्स एनर्जी थ्योरम। तो आप लिखते हैं 1/2 पाई इंटीग्रेशन ओवर 2 पाई मॉडुलस ऑफ एक्स ऑफ ई की पावर जे ओमेगा होल स्क्वायर डी ओमेगा। फिर आप लिखते हैं 1/2 पाई, ठीक है। रेंज में लिखूँगा अभी माइनस ओमेगा सी से ओमेगा सी, ओके, माइनस ओमेगा सी से ओमेगा सी। इस रेंज में एम्पलीट्यूड कितना है, पाई बाई ओमेगा सी, स्क्वायर करो तो पाई स्क्वायर अपॉन ओमेगा सी स्क्वायर डी ओमेगा। तो आप लिखते हैं 1/2 पाई इंटू पाई स्क्वायर अपॉन ओमेगा सी स्क्वायर इंटू 2 ओमेगा सी। अभी क्या होगा, ओमेगा सी से स्क्वायर कैंसिल आउट, 2 से 2 कैंसिल आउट, पाई से स्क्वायर कैंसिल आउट। तो दोस्तों आंसर कितना आया, पाई अपॉन ओमेगा सी। तो एनर्जी कितनी आई, पाई अपॉन ओमेगा सी। तो अभी कौन सा ऑप्शन करेक्ट हुआ, ऑप्शन बी। ओके, नेक्स्ट क्वेश्चन देखिए क्या है। तो नेक्स्ट क्वेश्चन, ओके, नेक्स्ट क्वेश्चन कुछ इस फॉर्म में है। इसमें देखिए कि क्या कैलकुलेट करना है। एक सिग्नल है एक्स ऑफ एन, इसके सैंपल्स गिवन है, इसका DTFT एक्स ऑफ ई की पावर जे ओमेगा। हमें क्या करना है कि इंटीग्रेशन माइनस पाई टू पाई मॉडुलस ऑफ डेरिवेटिव ऑफ एक्स ऑफ ई की पावर जे ओमेगा होल स्क्वायर डी ओमेगा, इसका वैल्यू कैलकुलेट करना है। ओके, तो इस तरह बढ़ेंगे। सबसे पहले आप प्रॉपर्टी यूज़ करो, डिफरेंशिएशन इन फ्रीक्वेंसी डोमेन। फॉर n इंटू एक्स ऑफ एन DTFT विल बी j इंटू डेरीवेटिव ऑफ एक्स ऑफ ई की पावर j ओमेगा। ओके, अब इसके बाद दोनों साइड किससे डिवाइड कर दो, j से। सो n इंटू एक्स ऑफ एन डिवाइड बाई j, तो आप लिखते डेरीवेटिव ऑफ एक्स ऑफ ई की पावर j ओमेगा, ठीक है। नाउ अज्यूम दैट दिस टर्म इज f ऑफ ई की पावर j ओमेगा। तो जो इन्वर्स है ये f ऑफ n है। ओके, अब ये जो इंटीग्रेशन है इसे अगर आप ध्यान से देखें, देन दिस इंटीग्रेशन, सपोज दिस इज i, देन i विल बी इक्वल टू इंटीग्रेशन ओवर 2 पाई दिस टर्म स्क्वायर डी ओमेगा। और ये वाला जो टर्म है ये मैंने किसके अज्यूम किया है, f ऑफ ई की पावर j ओमेगा के। तो आप लिख सकते हैं कुछ इस फॉर्म में, मॉडुलस ऑफ f ऑफ ई की पावर j ओमेगा होल स्क्वायर डी ओमेगा। अभी दोस्तों हमें क्या यूज़ करना पड़ेगा, पार्सेवल्स एनर्जी थ्योरम, जिससे आप रिजल्ट लिखते 2 pi into एनर्जी ऑफ एफ ऑफ एन, ठीक है। मतलब गिवन इंटीग्रेशन मतलब आई कैलकुलेट करना है, तो कैसे कैलकुलेट करोगे, 2 पाई इंटू एनर्जी ऑफ एफ ऑफ एन, फंक्शन एफ एन का एनर्जी कैलकुलेट करना है, तो फॉर्मूला क्या, समेशन मॉड एफ एन स्क्वायर रेंज माइनस इन्फानाइट टू इन्फानाइट, फिर आप लिखते हैं 2 पाई समेशन, अच्छा एफ ऑफ एन को रिप्लेस किससे करोगे, एन बाई जे एक्स ऑफ एन से, तो आप रिप्लेस करते हैं एन बाई जे इंटू एक्स ऑफ एन से, फिर क्या करोगे, स्क्वायर रेंज, अभी देख लेते हैं, एक्स ऑफ एन का रेंज देख लो भाई, एफ ऑफ एन का रेंज है, ओके, एक्स ऑफ एन का रेंज देख लो भाई, एफ ऑफ एन का रेंज है, तो यहाँ पर आई थिंक एरो मिसिंग है, क्वेश्चन में एक बार देख लेता हूँ और फटाफट एरो का लोकेशन में मार्क करता हूँ, ओके। तो ये जो क्वेश्चन है, ये क्वेश्चन है क्वेश्चन नंबर 69। तो दोस्तों मेरे पास हार्ड कॉपी भी अवेलेबल है, तो 69 नंबर क्वेश्चन, इसमें एरो जो है ये आई थिंक इसमें एरो का लोकेशन जो है, ओके, -3 से 7 तक है, चलो यहाँ से हो गया, यहाँ से पता चल रहा है -3 से स्टार्ट हो रहा है, मतलब -3 -2, ये कहाँ का है, -3 का एलिमेंट है, ये किधर का एलिमेंट है, n = 7 का एलिमेंट है। चलो तो अभी यहाँ से आंसर आएगा कुछ इस फॉर्म में, तो आप इसको थोड़ा आगे बढ़ो, 2 पाई समेशन n का रेंज -3 से कहाँ तक, 7 तक, तो n का रेंज -3 से कहाँ तक, 7 तक, ठीक है। मैग्नीट्यूड अप्लाई कर रहे हो तो j का मैग्नीट्यूड कितना, 1, तो आप लिखते हैं n स्क्वायर एक्स स्क्वायर n, बाकी अब n के वैल्यूज़ पुट करो इसमें, मैं एक दो टर्म लिख करके बता दे रहा हूँ, जैसे n को -3 पुट करो तो -3 का स्क्वायर इंटू एक्स स्क्वायर -3, फिर -2 पुट करो, -2 का स्क्वायर एक्स स्क्वायर -2 एंड सो ऑन, कहाँ तक पुट करना है, n = 7 तक, ओके। ठीक है -3 से चलेगा, ओके। लास्ट टर्म कहाँ 7 पुट करोगे तो 7 स्क्वायर इंटू एक्स स्क्वायर 7, ठीक है, डन, यहाँ तक है, बाकी सैम्पल्स आप इसमें पुट कर दीजिए, तो जो फाइनल आंसर आएगा वो है 316 पाई, मैंने ये कैलकुलेट करके रखा है सो दैट कि थोड़ा टाइम आपके लिए भी मैं सेव कर सकूं, तो आंसर आता है 316 पाई। फटाफट हम लोग चेक करेंगे कि कौन सा ऑप्शन मैच होगा, तो बच्चों कौन सा ऑप्शन मैच होने वाला है, ऑप्शन सी। तरीका मैंने बता दिया है, आप इसमें बढ़िए, सैम्पल्स पुट करिए और आंसर कैलकुलेट करिए, ठीक है। इसके बाद नेक्स्ट क्वेश्चन अगर देखें तो नेक्स्ट क्वेश्चन जो है बहुत ही ट्रिकी सवाल है, आप अगर देखें तो ये DTFT का क्वेश्चन है, इसमें एक्स ऑफ ई की पावर जे ओमेगा गिवन है, हमें क्या करना है, बस के लिए इन्वर्स लिखना है। यहाँ पर ट्रिक क्या है कि ये जो एक्स ऑफ ई की पावर जे ओमेगा है, दिस फंक्शन इज इमेजनरी ऑड, तो बेटा ये बताओ फंक्शन का नेचर कैसा है, इमेजनरी ऑड, एंड इमेजनरी ऑड फंक्शन इज देयर, देन टाइम डोमेन सिग्नल विल बी रियल ऑड, तो टाइम डोमेन फंक्शन कैसा होगा, रियल ऑड फंक्शन होगा। अब आप देखें तो 4 के 4 ऑप्शंस रियल हैं, ओके, इसमें ऑड कौन सा है, ये तो है नहीं क्योंकि इवन प्लस इवन इवन, ये भी नहीं क्योंकि ये ऑड बाई ऑड इवन, ये भी नहीं ऑड बाई ऑड इवन, और अगर आप इसे देखें तो दिस टर्म इज इवन, दिस टर्म इज ऑड, सो इवन बाई ऑड ऑड, सो दिस टर्म इज आंसर बिकॉज दिस टर्म इज रियल एज वेल एज ऑड, तो कौन सा ऑप्शन आंसर आया, ऑप्शन डी। अच्छा अब इसके बाद नवीन सर की ओर चलते हैं और कुछ क्वेश्चन का आंसर ये भी करने वाले हैं।
Thank you, Rohit sir. So coming to the next question. So, see the value x of e power j omega, that is applying the DTFT, e power minus j omega into 1 plus e power j omega into 1 is the value we are having. So, if you write x of e power j omega, that is equal to e power minus j omega plus e to the power of j omega. So, divided by 2 and multiplied by 2, and that value is equal to 2 into cos of omega is the value we are having. So, if you see the options, the option matching is the option D, that is option D is equal to 2 into cos of omega is present. So, now coming to the next question. So, given that x of n is equal to cos omega naught of n into u of n, then what is the DTFT of the signal you are asking? So, if you see this question, that is your x of n is equal to cos of omega naught into n is multiplied with u of n. So, if you see this value asking DTFT of the signal, so we can write like this, that is x of n into, we are writing this as x1 of n into value is equal to cos omega naught of n. That means your x1 of n is equal to u of n, then x1 of e to the power of j omega, the discrete time Fourier transform of u of n is equal to 1 by 1 minus e to the power of minus j omega plus pi into delta of omega is the value we are having, and that is the value of x of e power j omega is present. Now, after that we can see that the value is equal to that of x of n. So, that x of n is equal to x1 of n into cos of omega naught of n is present, that is going to be present equal to that of x of n. So, we can write like this, that is equal to x1 of n into cos of omega naught of n, that is equal to e to the power of j omega naught of n plus e to the power of minus j omega naught of n. So, whole divided by 2, and this value is equal to that of 1 by 2 into x1 of n e to the power of j omega naught into n plus 1 by 2 into x1 of n into e to the power of minus j omega naught into n is present, and that value is equal to, apply the transform. So, apply DTFT, discrete time Fourier transform. If you apply discrete time Fourier transform, so we can get like this, x of e power j omega is equal to 1 by 2 into x1 of this exponential function is nothing but an x1 of omega minus omega naught plus 1 by 2 into x1 of omega plus omega naught. And now you are substituting this x1 of omega minus omega naught in this value, and that is going to be equal to 1 by 2. So, even you solve it, so 1 by 2 I am taking common. So, 1 minus e to the power of, so 1 minus e to the power of e to the power of minus j omega minus omega naught is the value we are having, plus 1 by 1 minus e to the power of minus j omega plus omega naught is the value we are having. This is what we called it as x of e to the power of j omega we are having. So, value is equal to that of plus plus pi into delta of omega is to be required. So, we need to write that plus pi into delta of omega also. So, that is equal to plus pi into delta of omega minus omega naught plus the value is equal to 1 by 1 minus e to the power of minus j omega plus omega naught plus value is equal to pi into delta of omega plus omega naught. If you see this term and in the options, we are having this exponential term was not getting cancelling out, it is left over as it is, and if it is that all options are not going to be satisfying. So, all are wrong. So, all are wrong options we are having. So, out of that no one is matching. So, this means marks to all to everyone in the ESE exam. Okay. So, we can go for the next question. If you see the next question, what are the initial and final values of y of t respectively if its Laplace transform is y of s is given, asking to find the initial value and final value. So, if you talk about the initial value, so writing about the initial value, that is nothing but an y of 0 is equal to limit s tends to infinite s into y of s, and that is equal to that of limit s tends to infinite s into y of s is equal to 10 into 2s plus 3 whole divided by s into s square plus 2s plus 5 is the value we are having. So, if you are substituting the value of s is equal to infinite, this s and s will get cancelled out, limit s tends to infinite. I am taking s common, that is 10 into s, that is 2 plus 3 by s whole divided by, I am taking s square common, 1 plus 2 by s plus 5 by s square we are having, and these values are get cancelled out. If you put s is equal to infinite, this value is equal to 0. And if you see the options, in the 4 options A, B, C and D, the D option is having initial value 0, remaining having 4, 1 and 3. The correct option what you are having is equal to, the value is equal to that of D. So, option D is the correct answer. So, I am not finding the final value. So, I can tell the value directly by seeing the options. Okay. Now, coming to the next question. If you see that the function x of t is equal to 10 sinc of t plus 4 by 7, then what is the total area under the function we are having? So, we can talk about the total area under the function. The first thing is you are writing x of t, the given x of t is equal to 10 into sinc of t plus 4 by 7. So, when you are writing about the value that is representing in terms of the function, we can writing your x of t like this also, that is 10 into value of sinc t by 7. The reason is the shifting does not affect the area to find out the area. So, therefore, what you are talking about the value is converting this into the sample function. So, whenever we are converting this into the sampling function, then what happened to the value is equal to that of 10 into this value is equal to SA of pi by 7 into t is the value. Now, I am applying the Fourier transform x of omega, and the x of omega value what you are having is nothing but n from minus pi by 7 to plus pi by 7 omega, and this value is equal to 70. So, asking about area under x of t, that is x of t into dt, just observe carefully. Observing area in time domain is nothing but an observing the other domain at origin. So, observing other domain at the origin means at omega is equal to 0, x of 0 at omega is equal to 0 we are having. So, like this at omega is equal to 0, x of omega at omega is equal to 0 is 70. So, the answer is equal to 70. If you check the options, option C is matching with that given option as 70. See the next question. For this question, x of t is equal to delta of 3t plus u into 3t, then what are the Laplace transform and the associated ROC for the function of time respectively was asking. The same model of question was solved in the class also, right. If you see about the x of t, the given x of t is nothing but an delta of 3t, that is equal to delta of 3t plus u of 3t we are having. So, we can write like this, your x of t can also written as apply the scaling property. So, 1 by 3 into delta of t, there is no scaling property present in the unit step function. So, u of t 3 into t can also written as u of t. So, apply Laplace directly. So, once we are applying the Laplace transform, x of t converts into x of s, where x of s is equal to 1 by 3 plus 1 u of t is equal to 1 by s. It is a finite duration signal, entire s plane is the ROC, and for u of t function ROC is sigma greater than 0, then the common ROC between these two is sigma is greater than 0. Now, what we are getting is x of s, I am simply solving the x of s value also, that is equal to s plus 3 divided by 3 into s we are having. Okay. So, s plus 3 divided by 3 into s, and the ROC sigma is also greater than 0. Now, if you check the option that we are having is equal to option D. Okay. That is option D is the correct answer, s plus 3 divided by 3s. So, real value of s is greater than 0. So, that is all the questions for the signals and system. You can follow for the next subject. Thank you.
Good evening dear students. From the electrical circuits the 10 questions have been asked. Okay. Now let us see the solutions of each one. I want response from your side. I will write the respective steps for each problem. Come to the first question. First question, what is the requirement is the potential difference between the A and the B. Potential difference between the A and B. For this particular example, now if you observe here 10 and 20 both are connected series. This series combination is connected parallel to the 10 volts, parallel to the 10 volts. First can you find out the voltage across this 20 ohm resistor. First can you find out the voltage 20 ohm resistor. जो 10 volts है ना distributed between the first element and the second element. To conclude this one, simply let us apply the voltage division technique. Total voltage into similar resistance. In this example, what is similar resistance is the 20 by total resistance. Now by simplifying this one, V20 is obtained. Come to next part. Again for this one here, this 30 and 40 both are connected in series. The series combination है ना, series combination is connected parallel to the source voltage. Either be, let us find out the voltage across this, voltage across the 40 ohms, V40. देखो जी इधर V40 निकालने के लिए again let us apply the voltage division technique. Now ये पूरा ब्रांच के लिए total voltage कितना है इधर 10. Now similar resistance कितना है इधर 40 by total resistance 40 plus 30 ohms. देखो जी इधर सिंप्लीफाई करने से आपको V20 आ गया, V40 भी आ गया. Now what is our requirement potential difference A and B. देखिए first letter के लिए give the positive sign, second one is the negative sign. Give the name for this one is VAB. Now for this one can you write the respect to KVL equation. इधर KVL equation लिख सकते ना. If you write the respect to KVL equation, now by KVL in this example this lower potential to higher potential voltage rise. Again here higher potential to lower potential voltage drop. Again here higher potential to lower potential voltage drop. Now this entire equation equated to 0. देखिए this V40 V20 already concluded here. By substituting respective values sir we can find out the VAB. Anybody answers for this one VAB? बोलिए जी anybody answers VAB? This VAB is a 0.96. Come to the next one. Now this is a standard question. By observing figure itself directly you can say we can read out this one as a bridge network. We can read out this one as a bridge network. होना बोल तो we can develop the figure. What is our requirement? Equivalent resistance with respect to A and the B. Equivalent resistance with respect to A and the B. Given figure होना बोल तो we can read out like this. Now क्या चाहिए आपको equivalent resistance with respect to A and B. Now from this given data we can conclude this one as a it is a balancer bridge. We can conclude this one as a this balancer bridge. Now corresponding balancer bridge, now what is the current flow in the diagonal points element equal to 0. Then here for making calculation simple, we can remove this 10 ohm resistance. We can remove the 10 ohm resistance. It can be open circuited. It is the open circuited. If it is open circuited, now we can easily conclude. Then corresponds example here how this 10 and 10 both are connected in the series. Again here also this 10 and 10 both are connected in the series. देखिए एग्जाम्पल में दिस ब्रांच 1 एंड ब्रांच 2 बोथ आर कनेक्टेड पैरेलल, इधर सिंप्लीफाई करने से दिस इक्विवेलेंट रेजिस्टेंस इज इक्वल टू 10 ohms. This equivalent resistance is equal to 10 ohms. Come to the next one. इधर क्या चाहिए जी आपको? We need the Thevenin's resistance as well as the Thevenin's voltage, Thevenin's resistance and the voltage. चलिए चेक करेंगे. First let us consider on the Thevenin's resistance. First let us find out Thevenin's resistance. Here Thevenin's resistance find out करने के लिए what is the procedure for this? Deactivate all the independent sources. Deactivate all the independent sources. Case 1. The case 1 let us find out the R Thevenin's. इधर RThevenin find out करने के लिए the procedure is a deactivate all the independent sources. That voltage source is replaced by short circuit. Voltage source replaced by short circuit. And what about this current source is a open circuited. The current source is a open circuit. Current source is a open circuit. Then with respect to this load terminals, we have to find out the okay, with respect to load terminals, now we have to find out the respect to RThevenins. Now for this example, for this particular example here, now how this 10 and 10 both are connected to the series 20. This 20 and 5 both are connected to the parallel, both are connected to parallel. This entire combination, जो entire combination is connected in series to 16 ohms, in series to 16 ohms. Can you find out the RThevenin's value? We can conclude that RThevenin is equal to 16 plus. How the 20 and 5 both are connected to the parallel. Now either simplify करने से we get this way, the RThevenin is equal to 20 ohms. RThevenin is equal to 20 ohms. From this one, two options are eliminated. No, second option, first options are the incorrect. Two options are eliminated. Now come to the this VThevenins. Now correspond this VThevenins. Now corresponds example here. The case 2, I am focusing on the VThevenins. Can you write the node equations here? Give the name for this node A. Give the name for this node B. Now take this point as a ground. देखिए क्या चाहिए आपको VThevenins. What is your requirement is the VThevenins. Now what is your requirement is the VThevenins. To get the VThevenins, now let us write the node equations here. Let us write the node equations. For this example, with respect to ground potential, what is the polarity of this one is a plus. What is the polarity of this one also plus. Now for this example, if you observe carefully, देखिए it is a open circuited. Open circuit means in this one no current is a present. मगर 16 ohms में देखिए जितना करंट इधर 16 ohms है, सेम करंट प्रेजेंट here also. कितना करंट जा रहा है इधर 3 amperes. देखिए इधर वेयर ओवर द करंट इज एंटरिंग दैट इज अ पॉजिटिव एंड अदर वन इज अ नेगेटिव, अदर वन इज नेगेटिव. देखिए करंट इज 3 amperes और रेजिस्टेंस इज 16. कैन यू सिंप्लीफाई दिस वन? इफ यू सिंप्लीफाई दिस वन हियर, व्हाट इज द वोल्टेज ऑफ दिस वन इज 48. वोल्टेज इज 48. मगर आपको क्या चाहिए VThevenins. फर्स्ट लेटर के लिए गिव द पॉजिटिव साइन, अदर वन इज अ नेगेटिव साइन. VThevenins के लिए व्हाट इज और वन मोर रिक्वायरमेंट इज VB, वन मोर रिक्वायरमेंट VB. देखो जी VB निकालने के लिए कैन यू राइट द नोड इक्वेशंस हियर. If you write the KCL equation at node A, if you write the KCL equation node A, correspond node A had a plus similar polarity subtraction. But the respect to resistance of this one is a 10 plus like either we can write this in the VA minus VB, but corresponding resistance of this one is a 10. What about this example? 3 amperes is incoming current. देखिए example में this 3 amperes is the incoming current. Equation 1 is completed. Can you repeat the same procedure at node 2 also? That means node 2 means hit the node B. Now correspond node B, if you observe here, देखिए इधर 3 amperes is the outgoing current. 3 amperes outgoing current. We can write this with this VB minus VA. This V minus VA by respect to resistance is 10. What about this other one is this VB, VB by 5. This entire equation is equal to 0. देखो जी we got the two equations. Now by solving these two equations, now what is our main focus on the VB value? Main focus on VB value. Check करो, simplify करने से try to find out the VB value. Directly I am writing answer here. Check कर लो जी, we get this VB is equal to minus 1.2. Your equation solve करने से we get the VB equal to minus 1.2. Now can you write the respect to KVL equation? आप KVL equation लिख सकते ना. देखिए voltage across this element, voltage this element is a VB. Now देखिए इधर KVL equation लिखेंगे. Now if you write the KVL equation for this one by KVL, आप इधर KVL equation लिखे तो if you write the respect to KVL equation for this one, now lower potential to higher potential, this voltage rise minus VB. Now higher potential to lower potential voltage drop. Again this higher potential to lower potential voltage drop. This entire equation is equated to 0. Now regarding VB we already calculated, VB already calculated. Can you substitute the VB value here? Substitute the VB, simplify करो, simplify करने से we can find out the VThevenins. Check कर लो, we get the VThevenins of this one is a minus 49.2. VB substitute करो, simplify करने से we can find out the VThevenins. I hope all of you got the same answers now. Okay. Come to the next one. Again in this example what is our requirement is the maximum power. देखो जी इधर भी maximum power निकालने के लिए we have to simplify this one as single equivalent circuit. Single equivalent circuit के लिए होना बोल तो we can go for Thevenin's theorem, नहीं तो we can go for the Norton's theorem. You can apply any one of the theorems. In this example if I go for Thevenin's theorem, if I go for the Thevenin's theorem for this one, if I go for Thevenin's theorem here, first let us find out the respective VThevenins. First let us find out the respective VThevenins. Case 1, in the case 1 let us focus on the VThevenins value. What is the voltage? This means how much here? 60. Voltage is 60. Now what is our requirement is the open circuit voltage, open circuit voltage with respect to load, open circuit voltage with respect to load terminals. For this example again can you find out the V20 here, similar to the previous problem only. देखिए ए ब्रांच के लिए टोटल वोल्टेज कितने है 60, total voltage 60, similar resistance by total resistance. By simplifying this one, can you find out the voltage this one here 40 volts. Next let us find out the V5. देखो जी V5 also same concept, voltage across this part, voltage resistance both are same, similar resistance by total resistance. Simplify करने से what is the voltage this one is 10 volts. Can you write the respective KVL equation? KVL equation लिखो. KVL equation लिखने से by simplifying this one, directly I am writing here. देखिए आपको V20 पता है, V पता है, Vy पता है, आप यार KVL लिखे तो we get the VThevenin is equal to 30 volts, VThevenin is equal to 30 volts. Can you find out the respective RThevenin for this one? Come to the case 2. Case 2 let us find out the RThevenin. While finding RThevenin what is the procedure? Deactivate all the independent sources. That voltage source is replaced by short circuit. Voltage source is replaced by short circuit. Voltage source replaced by short circuit. Now simplified form we can indicate like this. Now this voltage source replaced by short circuit, I shifted this part in the inside. Now this is a open circuited. With respect to load terminals, now we have to find out the RTH. Then for this example here 10, 20. If you observe the connections for this one, 20 and this 10, how these two are connected in the parallel. Similarly here also how this 5 and 25 both are connected in the parallel. Now this entire parallel combination connected in series. Here simplify करने से we can conclude this as a now simplify करने से we can find out respect to RThevenin value. Now RThevenin is obtained, VThevenin is obtained. Finally what is our requirement is the maximum power. Can you develop the respect to Thevenin's equivalent circuit? what is the condition for the maximum power? What the condition for maximum power is this R equal to R Thevenins, R equal to R Thevenins. What is finally our requirement of the maximum power? Okay, maximum power के लिए what general formula is V square by 4RL. इधर RL बोल तो as per the given question here the name of the load resistance is R. चेक करो इधर simplify करने से now we get answer for this as per given options we get the D is the correct option. As per the given options here D is the correct option. Come to the next question. In the next question statements are given. The statement answer पढ़ना इधर. Correspond to first example here. At t equal 0 minus no current was present. But the inductor nature it does not allow sudden change of current. At 0 minus if no current present, at 0 plus also no current present. Current equal 0. Current equal 0 is a property of the open circuit. It behaves as the open circuit. That means given first statement is the correct. First statement is the correct. Come to second statement. Second statement क्या है जी? At t equal 0 minus capacitor के लिए no voltage. But what is the statement can I say? Open circuit. It is incorrect. But capacitor what will happen at 0 plus also again voltage 0. It has to behave as a short circuit. Okay, but it was given as an open circuit. This is an incorrect statement. But the next one given as a the current I naught is flowing in the inductor at t equal 0 minus. Before operating switch the current was the I naught. Then at t equal 0 plus inductor does not allow sudden change of current. That means we can replace that one as a current source. That means the third statement is correct. That means the first statement, third statements are the correct. Okay. Remaining questions are explained by the Naresh sir.
Thank you, sir. Here the question is what is the value of voltage V naught shown in the circuit is given directly. You have to apply just nodal analysis KCL. Apply KCL here now. Here V naught is given. I am writing here now. This is outgoing current, this outgoing current, this incoming current. V naught upon J6 plus V naught upon minus J3 is incoming current is 4 angle 90. 4 angle 90 can be written as a J4 or not? J4. Okay. Now V naught is take a common 1 by J6. 1 by J6 is a minus J by 6. 1 by minus J plus J, J by 3 is equal to J4. Okay. Now V naught here 6 is LCM minus J plus 2J is equal to J4. 2J plus J 1 the 6 into 4 is 624 J get cancelled. So V naught is equal to you get a 24 volts. After simplification V naught is 24 volts. The C is the option for this question. Okay. Next move to next question. So here is a very direct question. The value of power consumed by the balanced star connected load in the terms of the balanced delta connected load is P star is equal to P delta by 3. Directly बोल सकते इसका. Next is here Z parameters are given. Z11 is 20 ohms and Z22 is 30 ohms. Z12 and Z21 are 10 ohms. The corresponding values of A, B, C, D parameters. Just you have to use a conversion method. Conversion is Z11 V1 is equal to Z11 I1 plus Z12 I2. V2 is equal to Z21 I1 plus Z22 I2. Now substitute here now simply V1 is equal to how much here now 20 I1 plus Z22 A Z12 is 10 I2 equation 1. V2 is equal to 10 I1 Z21 is 10 and Z22 is 30 I2. Now this is a Z parameters. Now you have to find out ABCD. ABCD equation लिख लो. V1 is equal to A V2 minus B I2 and I1 is equal to C V2 minus D I2. इसमें कंपेयर करो V1 V1 है यार I1 के प्लेस में V2 है I2 के प्लेस में I2 है. So which one would eliminate? So you I1 को eliminate करना है, you write I1 equation from second, I1 is equal to V2 by 10 minus 30 by 10 I2, ये इक्वेशन एक आ गया. सो नेक्स्ट I1 को सब्स्टिट्यूट करना है, किधर सब्स्टिट्यूट करना है, इसमें सब्स्टिट्यूट करो. सो V1 इज इक्वल टू here 20 into I1 is V2 by 10 minus 3 I2 plus 10 I2. After simplification आप देख सकते ना, V1 is equal to 20 by 10, that is the 2 V2, 20 minus 3, that is 60 I2 plus 10 I2. So V1 is equal to 2 V2 minus 50 I2. एक V1 इक्वेशन आ गया, एक I1 इक्वेशन आ गया. आप लिख सकते हैं 250 कंपेयर करो 1 by 10 0.1 and 3. So ऑप्शन क्या हो सकता है, ऑप्शन D is a correct answer. So D is the answer for this question. Next is magnetic. This is belongs to the magnetic coupled circuits. So first identify this, suppose this is coil number 1, coil 2 and coil 3. बीच में M12 is positive और negative कैसे बोल सकते हैं, you have to indicate the direction of current across the coil 1, here across the coil and across the coil. Both are leaving from the dot. So M12 is positive, M12 is positive. What about M23? 2 की 3 के बीच में a leaving है, a entering है. So M23 is negative. What about M13? Is leaving, here entering. M13 is negative. So directly use कर सकते हैं direct formula, L equivalent is equal to L1 plus L2 plus L3 self. Mutual between these two is plus or not. So we write a plus 2 M12. Between 2 and 3, that is a minus 2 M23. Again 1 and 3 के बीच में है minus 2 M13. Substitute now. L equivalent is equal to L1 is 10 plus 5 plus 6 minus 2 into M12. M12 is how much? 2. 2 to the 4 minus, and M23 is 1. 2 into 1 is 2. This is a plus. And next is 13 is 1 minus 2. So L equivalent is equal to, after simplification you get a 21 Henry. So which one is option is correct here now? 21 means here B option is correct. Now an initially uncharged 1 millifarad capacitor has the current shown in figure. What is the voltage across? What is the voltage across capacitor? Capacitor across क्या होता है? 50 millivolts, 100 millivolts, 200 millivolts. Okay, right. अभी देखेंगे डायरेक्ट राइट है. VC is equal to what now? Here is VC is equal to 1 by C integral 0 to 2 milliseconds I of t dt. Our intention is only 2 milliseconds. 2 milliseconds के बीच, 2 milliseconds means up to this. Up to this outright this equation for the I of t is, this is slope. So I of t equation is y2 minus y1 by x2 minus x1. y2 minus y1 is 100 minus 0. Slope के लिए 10 to the power of minus 3 milli divided by 2 minus 0, 2 milli into t or not into t. This is the equation. So 100 by 2 is 50 ampere, 50 t is the I of t from 0 to 2. Our intention is only 0 to 2. Substitute here now. Vc is equal to 1 by C, C is equal to 1 millifarad. Yes or not? 1 millifarad, 1 into 10 to the power of minus 3 integration 0 to 2 I of t is 50t into dt. Now Vc is equal to integration is 50 by 10 to the power of minus 3 t square by 2 and substitute 0 to 2 2 into 10 to the power of minus 3. So after substitution you get a Vc is equal to 100 millivolts. This is the answer for this question. Okay, thank you.
नमस्कार. सो मीटिंग लास्ट टाइम टुडे इन दिस सब्जेक्ट. सुबह से कई बार मैं डिफरेंट सब्जेक्ट में डिफरेंट ब्रांच में आपके सामने आ चुका हूँ. सो लेट अस डिस्कस मटेरियल साइंस. द वेरी फर्स्ट क्वेश्चन इज व्हाट इज द प्रॉपर्टी ऑफ आइसोट्रॉपिक मटेरियल दैट मस्ट बी सेटिस्फाइड. मैंने आपको बताया कि आइसोट्रॉपिक मटेरियल्स आर दोज मटेरियल्स इन व्हिच मटेरियल प्रॉपर्टीज आर इंडिपेंडेंट ऑफ द डायरेक्शन ऑफ मेजरमेंट. सो यहाँ इलेक्ट्रिक फील्ड के पॉइंट ऑफ व्यू है. किसी भी डायरेक्शन में आप इलेक्ट्रिक फील्ड लगाएं, प्रॉपर्टी शुड बी सेम इन ऑल द डायरेक्शन. सो ऑप्शन ढूंढिए. इट हैज द सेम इलेक्ट्रिक प्रॉपर्टीज फॉर द वेरियस डायरेक्शंस ऑफ अप्लाइड इलेक्ट्रिक फील्ड. ये अप्लाइड होना चाहिए, अप्लायंस लिखा है इन्होंने. सो आंसर इज ए. ठीक, मैं आप याद करो, ऐसे फिगर बना करके आपको समझाता हूं कि किसी भी डायरेक्शन से आप प्रॉपर्टी मेजर करें, फ्रॉम ऑल द डायरेक्शन प्रॉपर्टी शुड बी सेम. सो आंसर शुड बी ए. राइट, नेक्स्ट क्वेश्चन पर आते हैं. नेक्स्ट क्वेश्चन में कह रहा है व्हाट इज द ऑर्डर ऑफ रेजिस्टिविटी ऑफ कंडक्टिव मटेरियल. इसका ना मैं पूरा इंसुलेटर, कंडक्टर सभी के लिए डिटेल्ड आंसर में दे दूंगा. अभी इतना ज़्यादा डिटेल नहीं बना रहे हैं. जो कंडक्टर यानी मेटल्स के लिए ऑर्डर होता है वो ओम सेंटीमीटर में, मैंने कुछ बैचेस में ये ग्राफ कहीं कहीं बनवाया था, कहीं कहीं नहीं बनवाता हूँ. एक्चुअली मेंस में कहीं बनवाया था. और ये लगभग 10⁻⁻⁴ से ज़्यादा है, यानी -4 या -5 तक आप जा सकते हो, लाइक दैट. सो यहाँ तक ये मेटल्स होता है. बट ये जो ग्राफ दिया रहता है ये ओम सेंटीमीटर में है. तो अगर मैं इसे ओम मीटर में कन्वर्ट करूं तो ये लगभग 10⁻⁻10 पे चला जाएगा और ये लगभग 10⁻⁻6 है. अब इससे मिलता जुलता ऑप्शन ढूंढने की कोशिश करिए. तो 10⁻⁻6 से 10⁻⁸ दैट इज ए. ए ऑप्शन इज द बेस्ट फॉर दिस क्वेश्चन, क्योंकि बाकी के और नहीं सेटिस्फाई कर रहे हैं. ये बहुत ज़्यादा हो जाएगा, ये भी बहुत ज़्यादा है, ये भी बहुत ज़्यादा है. सो बेस्ट ऑप्शन मेटल के लिए, कंडक्टिव मटीरियल कह रहा, कंडक्टिव मतलब मेटल, मेटल की रेजिस्टिविटी इस रेंज में लाई करेगी. सो सिंपल क्वेश्चन था. इवन आपको ये रेंज ना भी पता हो तो आउट ऑफ द ऑप्शंस एलिमिनेशन आप बहुत हाई रेजिस्टिविटी नहीं हो सकती मेटल्स की, ये पॉइंट लगा करके भी कर सकते थे इस क्वेश्चन को. नेक्स्ट, व्हाट आर द प्रॉपर्टीज ऑफ गुड इंसुलेटिंग मटेरियल. अब डाइलेक्ट्रिक स्ट्रेंथ तो हमेशा हाई होनी चाहिए ताकि आप ज़्यादा वोल्टेज लगा सकें. रेजिस्टिविटी हाई होनी चाहिए, एज वेल एज वेरी लो डेसिपेशन फैक्टर. अब ये प्रॉपर्टीज ढूंढिए. सो दीज ऑल प्रॉपर्टीज आर अवेलेबल इन ऑप्शन डी. हाई डाइलेक्ट्रिक स्ट्रेंथ, वॉल्यूम रेजिस्टिविटी ऑफ हाई वैल्यू एंड वेरी लो डेसिपेशन फैक्टर. सो आंसर फॉर दिस क्वेश्चन इज गिवन बाय ऑप्शन डी. Let us move on to the next question. What is the value of Curie temperature of iron? मैंने आपको लिखाया हुआ है. फेरस, निकिल, कोबाल्ट तीनों के लिए लिखाता हूँ. याद हो तो आयरन के लिए हम लोग लिखते हैं 1043 केल्विन एंड कोबाल्ट के लिए मैं आपको लिखाता हूँ 1404 केल्विन एंड निकिल के लिए मैं आपको लिखाता हूँ 631 केल्विन. ये तीनों आपके नोट्स में, आप वहाँ से वेरीफाई कर सकते हैं. सो यहाँ किसके लिए पूछा हुआ है? क्यूरी टेम्परेचर ऑफ आयरन. सो Fe के लिए पूछा है. सो आंसर इज ए. फॉर दिस क्वेश्चन वी विल बी गोइंग विद द ऑप्शन ए. नेक्स्ट आते हैं. नेक्स्ट क्वेश्चन ये अच्छा क्वेश्चन है। कुछ साल पहले तक मैं इसको पढ़ाता था, इस साल तो ये नहीं ग्राफ बनवाया। पुराने नोट्स अगर किसी के पास होंगे तो उसमें होगा। जब ईसी इलेक्ट्रिकल को सेपरेटली मटेरियल साइंस पढ़ाते थे, अभी तो काफ़ी कुछ मिक्स होने की वजह से कुछ टॉपिक कई बार कंप्रोमाइज कर लेता हूँ। ये एक्सचेंज एनर्जी का ग्राफ होता है D/D रेशियो से। सो जब हम इस ग्राफ को बनाते हैं तो ये ग्राफ कुछ, मैं डिटेल्ड ग्राफ आपको PDF सॉल्यूशन में दे दूंगा। अभी मैं रफ आइडिया बना रहा हूँ, क्योंकि आप लोग भी थक गए होंगे और काफ़ी रात हो गई है। मैं भी सुबह से कई सब्जेक्ट और कई बार डिफरेंट ब्रांचेस में तो थक सा गया हूँ। सो ये D/D रेशियो होता है। ये लाइन 1.4 होती है, लाइन 1.7 होती है। और मैं यहाँ पर अगर फेरस और देन कोबाल्ट एंड देन ये निकिल होता है, अब इस हिसाब से कोई ऑप्शन मैच ही नहीं कर रहा है, ठीक है। तो एक्चुअली कोबाल्ट और निकिल में लगभग आसपास होते हैं दोनों, तो उसने शायद ऑप्शन में एक्सचेंज कर लिया है, थोड़ा बहुत डिफरेंस आ जाएगा। बट फेरस का बहुत कम होता है D/D रेशियो। सो फेरस का मिनिमम जो है वो D ऑप्शन में है। यू शुड गो विद ऑप्शन D। हालांकि वैसे इनमें से कोई भी ऑप्शन सही नहीं है, क्योंकि जो एक्चुअल सीक्वेंस होगा वो फेरस देन कोबाल्ट एंड देन निकिल, बट यहाँ निकिल और कोबाल्ट में इंटरचेंज कर दिया है। सो वैसे तो कोई भी आंसर सही नहीं है, बट UPSC में आप जानते हो हर साल एक आध क्वेश्चन इस तरह से होते हैं। सो बेस्ट ऑप्शन जो जाना चाहिए वो आपको ऑप्शन D के साथ जाना चाहिए। नेक्स्ट आते हैं, what are the important characteristic that must be satisfied with the permanent magnet material? Straight forward है। permanent magnet means a hard magnetic material. so hard magnetic materials जो होते हैं उनका कर्व कुछ ऐसा होता है, तो स्लोप कम होगी, और अगर स्लोप कम होगी तो परमियाबिलिटी कम होगी। सो लो परमियाबिलिटी, ठीक है, ये हम लोग क्लास में डिस्कस कर चुके हैं इस चीज को। हाई कोएर्सिव फोर्स या कोएर्सिव फील्ड, सो कोएर्सिव फोर्स बहुत हाई चाहिए, दिस वैल्यू इज हाई बिकॉज कर्व इज वाइट एंड हाई क्यूरी टेम्परेचर आल्सो, राइट। सो ऑप्शन ए इज द राइट चॉइस फॉर दिस। बाकी आप वेरीफाई कर लेना, बाकी सही नहीं है। सो फॉर दिस क्वेश्चन, क्वेश्चन नंबर 61, ऑप्शन ए, right. Now next, which of the following is the related to type first superconductors? अब यूजुअली तो क्लास में मैं मरकरी के लिए ही बताता हूँ, ठीक है। तो ये क्वेश्चन अब डेटा बेस्ड है, अगर किसी ने लेड के लिए कभी पढ़ा होगा तब तो कर लेगा, अदरवाइज फिर मुश्किल हो जाएगा थोड़ा सा। तो इसमें जो लेड का टेम्परेचर होता है वो रफली अराउंड 72 केल्विन होता है। इसने 7.19 किया हुआ है, तो ठीक है, 7.2 हो गया। और मरकरी का तो आपको याद होगा, मरकरी का हम लोग बात करते हैं क्लास में भी, 4.15, मैं यूजुअली 4.2 इसे राउंड ऑफ करके लिखा देता हूं। और एल्युमिनियम का मैं कभी बात नहीं करता हूं, लेकिन अगर आपको ये दोनों पता हो तो भी आप आंसर निकाल सकते हैं। एल्युमिनियम का जो ट्रांजिशन टेम्परेचर होता है वो 1.17 केल्विन के आसपास होता है। सो इसके हिसाब से ऑप्शन बी वुड बी राइट आंसर। लेड 7.196, मरकरी 4.15 एंड एल्युमिनियम 1.17, राइट। सो आंसर फॉर दिस क्वेश्चन इज गिवन बाय ऑप्शन बी। नेक्स्ट आते हैं, ऑर्गेनिक सुपरकंडक्टर्स आर कंपोज्ड ऑफ, दिस इज डिफिकल्ट क्वेश्चन, राइट। अब इसमें देखो बेटा, होते तो दोनों हैं, इलेक्ट्रॉन डोनर और एक्सेप्टर दोनों होता है, बट अब उसमें भी ऑप्शन ए और डी दोनों हैं। लेकिन एक्चुअली एग्जैक्टली कंपाउंड मुझे भी अभी नहीं याद आ रहा है, बट इतना याद आ रहा है कि कॉपर बेस्ड कोई कंपाउंड होता है जो इलेक्ट्रॉन डोनेट करता है। सो कॉपर इज अ नॉन ऑर्गेनिक एनायन, राइट। सो बोथ एन इलेक्ट्रॉन डोनर व्हिच इज कॉपर बेस्ड कंपाउंड होता है इट्स एक्चुअली। सो आई विल गो विद ऑप्शन डी। एग्जैक्ट आंसर मैं इसका लेटर ऑन प्रोवाइड कराऊंगा, अभी वो एग्जैक्टली कंपाउंड याद नहीं आ रहा। ये थोड़ा अनकन्वेंशनल सा क्वेश्चन था, इस पर कभी पूछा नहीं गया, इसको मैंने क्लास में कवर भी नहीं किया है, तो ये शायद आपसे ना बना हो। बाकी सारे तो सिंपल थे, बन गए होंगे। तो मटेरियल साइंस एज यूजुअल प्रिडिक्टेड पैटर्न पर ही रही है। जैसा मैं क्लास में भी कहता हूं कि एक आध क्वेश्चन ऐसे होते हैं जो अलग से आ जाते हैं, डिफरेंट से आ जाते हैं, बाकी सारे बने होंगे, बाकी सारे नोट से आपको मिल जाएंगे। सो फ्रॉम मटेरियल साइंस पॉइंट ऑफ व्यू द क्वेश्चंस वर स्ट्रेट फॉरवर्ड, नॉट वेरी डिफिकल्ट। अगर इसको छोड़ दें तो ये भी डुएबल क्वेश्चन था, चलो आप उसे भी छोड़ दो, तो ये तो एकदम आप क्लास में कर चुके हो। एंड देन ये भी स्ट्रेट फॉरवर्ड क्वेश्चन, ये सारे स्ट्रेट फॉरवर्ड क्वेश्चंस थे। सो मोस्ट ऑफ द क्वेश्चंस कैन बी इजीली डन। थैंक यू। नेक्स्ट सब्जेक्ट विल बी डिस्कस्ड बाय अदर फैकल्टी मेंबर। दैट्स ऑल फ्रॉम माय साइड।
Hi students, hello everyone. Yeah, myself Sagar Pingli. I am here with computer fundamental questions. Okay. So in the ESE exam, computer fundamental questions are going to be discussed here. This is the first question in the computer fundamental subject. Okay. Consider the following characteristics of a complex instruction set computer. Okay. This is the RISC and CISC related question. Okay. According to your class notes, already you know the characteristics of RISC and CISC computer. If you remember characteristics of RISC and CISC computer, then you can easily answer this question. Okay, right. These are the characteristics given. It is having small number of instructions. It is having small number of instructions, and it is having less addressing modes. Then most instructions can manipulate operands in memory. Then control unit is microprogrammed. So total 4 characteristics given. Okay, which of the above characteristics is or not correct? So we need to identify the false statements. Okay, we need to identify the false characteristics of the CISC computer. As you know the list of the characteristics associated with the CISC CPU. Okay, what are the characteristics? Less registers, more addressing modes, variable length instructions, unsuccessful pipeline, CPI not equal to 1. Okay, general purpose computer used in the personal applications, right? Larger instruction set, less expensive computer. Okay, it supports the microprogrammed control unit. Example, Pentium processor. These are the characteristics of a CISC computer. Okay, once you know the characteristic of a CISC computer, automatically you can identify the false statements in this question. Okay, according to that first statement, it is having smaller number of instructions. This is false statement. CISC computer having more instructions. Second, it is having less addressing modes. This is also false statement. It is also false statement, because RISC computer having the less addressing modes, CISC computer having the more addressing modes. Is it okay? And remaining control unit is microprogrammed. This is true. Most instructions can manipulate operands in memory. Yeah, this is also true, because more addressing modes, there is a memory addressing modes present in the CISC computer. So according to the question, first statement, second statement both are false. Now come to the options. When we see the options, B is matching. Answer is B. Okay, all right. Next question is, yeah, which of the following processors the designer can add easily new instructions without changing the architecture? Okay, which of the following processors designer can easily add the new instructions? Again, this is a RISC and CISC related question. Okay, when you know the CISC computer supports microprogrammed control unit. Microprogrammed control unit is more flexible to implement new instructions. Okay, so in the CISC computer we can able to add the new instructions without changing the architecture. Okay, in the microprogrammed control unit we can able to add the new instructions with less small changes. So microprogrammed control unit is used in the CISC computers, right? Microprogrammed control unit is flexible to implement new instructions. So that is the reason CISC processor is the right answer. Okay, CISC processor is the right answer. Answer is A. Okay, so CISC processor supports microprogrammed control unit. This microprogrammed control unit is more flexible. When it is more flexible, it is easy to implement the new instructions. So new instructions are easily implemented in the microprogrammed control unit. So that is used in the CISC computer. So obviously this question answer is A. A is the right answer. Okay students, all right. Next question is, which one of the following is used to increase the performance of a CPU? That means executing more instructions in less time. That means we are going to improve the performance. How the performance is increased? Execution time is decreased. So here performance is inversely proportionate to execution time. So we need to decrease the execution time. When we decrease the execution time, performance of the CPU will be increased. Okay. So by using which mechanism we are improving the performance? Okay, straightforward answer is pipelining. So pipelining allows overlapping execution. Overlapping execution. So due to this overlapping execution, 2 or more instructions are executed in parallel. When 2 or more instructions are executed in parallel, execution time of the program is decreased, performance is increased. So pipelining concept I explained in the regular class notes at the time of explaining the SISD architecture. If you remember SISD architecture, there I introduced the pipelining concept. So in the SISD there is no concurrency. To bring the concurrency in SISD computer, we are implementing the pipelining mechanism. So by using pipelining mechanism, we tries to improve the performance of a SISD computers. So pipelining supports overlapping execution. So correct answer is B. Okay, all right. Next question is, yeah, this is the next question. Consider the following functions of a root hub. Okay, this is the network component. Okay, in the networks we have a different components: hub, router, switch, okay, bridge, etc. So this is the question related to the hub. First statement, it performs power distribution to the device. Yes, hub is a distributed device. Okay, it just distributes the information among the ports. Okay, so this statement is true. Okay, it enables and disables the USB ports. Yes, this statement is also true. Correct. It reports status to each port to user. Yeah, it does not report the status to user. It reports the status to operating system. So that is the reason third statement is false and remaining two statements are true. Okay. Hub is a networking component. By using the hub, we are providing the connections. So simply hub is used to enable and disable the ports, and also it will distributes the power to the devices. So first statement, second statement both are true with respect to the hub. So which of the above functions is are correct? We need to identify the correct statements, 1 and 2. So answer is C. Okay students, yeah, this is the analysis of the root hub question. Okay, right. The next question is, yes, what is the approximate rotational delay if the disk drive has 8 surfaces, each surface has 1024 tracks, each track has 64 sectors, each sector holds 512 bytes, and rotational speed of the disk is 6000 rpm. It is assumed that the sector is away from head half of the track. So if we want to bring the head to the desired sector, we need to rotate the head only half part. So average rotational latency we need to calculate. Okay, so that is the question actually. So this question is also covered in your regular class notes, right? So in this question, extra information is given. So there is no need of the surfaces, no need of the tracks, no need of the sectors, and no need of the sector size. What we want? We want only the rotational speed. Okay, to calculate the rotational latency, we want the rotational speed. So here rotational latency given, rotational speed given 6000 rpm. So here 6000 revolutions takes place in 1 minute. Takes place in 1 minute. That is 60 seconds. So one revolution takes how much time? Okay, when we calculate this, this become 60 upon 6000 seconds. this is equal to 0.01 seconds. Yeah, this is the revolution time. Revolution time or rotational latency. With respect to the rotational speed, we calculated the rotational latency, that is 0.01 seconds. But in this question, head is away from the sector half of the track. So, if to bring that head to desired sector, we need to move the head half of the rotation. Therefore, average rotational latency is equal to half of the revolution time. Okay. So, do the calculations, 1 by 2 into 0.01 seconds. Okay. Perform the computation. After the computation, value become 0.005 seconds. Is it okay? So, this is the way to calculate the average rotational latency. Now, go back to the question, identify the correct answer. Yes, this is the question. Okay. So, right answer is A. A is the right answer, 0.005 seconds. Answer is A. Okay. This is the question which is related to hard disk. Hard disk question is already covered in your regular notes. You know that. Very good. Next question is, how many pages are in the disk if the capacity of virtual disk is 2 MB and each page size is 2 KB. Memory is a byte addressable memory. So, we need to identify number of pages in the secondary memory. Dear students, again this kind of the question I explained in the regular class notes. Okay, everyone knows that. How many pages are present in the secondary memory? Secondary memory capacity given as a virtual memory, that is the 2 MB. So, direct formula is what? Formula is number of pages in secondary memory is equal to secondary memory size by page size. Okay. So, here 2 MB, that is the secondary memory capacity, page size 2 KB. Okay, byte cancel, 2 cancel, this become 2 power 20 upon 2 power 10, that become 2 power 10, that is equal to 1024. Yes, 1024 pages are formed in the secondary memory. Is it okay? Go back to the option, select the right answer. So, right answer is B. B is the right answer, 1024. Okay, students, very good. Next question. Yes, this is the next question. Which one of the following is used to keep track of program statistics that may be valuable tool for the system administrators who wish to reconfigure the system to improve the computing services? Okay. For the administrators to reconfigure whatever the information is required, that information will be placed in some area. So, what technique is required to store this valuable information required for the system administrators for reconfiguration? Okay. When you see the options, this logging is the right answer. It is a theory based question. Logging is used to store this information. Okay. So, directly you can say the answer is C. So, making file is not correct, spooling is not correct, programming table is not correct. So, logging is used to store this information, okay, which is helpful to the administrators to reconfigure the system. Clear? So, answer is C. Next question. This is the next question. If communicating process reside in the temporary queue and the queue has maximum length 0. By looking at this statement, you can identify the answer. When queue size is 0, that is 0 capacity queue, very simple, then the link cannot have any message waiting in it. So, 0 capacity queue, capacity is 0, it does not hold any waiting process in it. So, straightforward answer, Okay, naming terminology. By looking at the given question terminology, we can able to select the answer. Okay, so Q capacity is 0, that is the 0 capacity Q is used for this implementation. Okay, so answer is D. Next, this is the question which is related to the round robin scheduling. Again, this question we covered in our regular class notes, everyone knows that. So, apply that logic to solve this question. Okay, this is the round robin technique. In this question, arrival time is not given, so arrival time is 0. So, PID and burst time given. Okay, P1, P2, P3, 3 processes given, associated burst time given like this, right. Then time quantum given in the question is 4, that is mentioned here, right. Arrival time is 0, that means all the processes are arrived at the same time. So, here ready queue status, in the ready queue all processes are arrived. So, arrange them according to the PID. Yes, we arranged. After that, prepare the chart. This chart is starts from 0, process chart starts from 0. From the queue, you take the first process P1, burst time of the first process is 24, time quantum is 4. So, execute with time quantum. So, P1 scheduled only 4 units serviced and rest of the time is 20, very good. Then P1 will be preempted back to the ready queue. From the queue, next process is P2, P2 selected, burst time of P2 is 3, time quantum is 4, burst time is less than time quantum, so that execute with respect to burst time, so that 4 plus 3 7, so remaining time 0, so no preemption. Next P3, yeah, burst time is 3, okay, time quantum is 4, burst time less than time quantum, execute with burst time, 7 plus 3 10, so remaining time 0, no preemption. So, next process is P1. So, this is the last process, directly you can take the burst time, that is 20, 10 plus 20, that is 30. Okay, this is the process chart. Now, we need to prepare the completion timetable, completion time, turnaround time and waiting time. P1, P2, P3, right. P1 completion time is P1 30, P2 completion time 7, P3 completion time 10. So, TAT, TAT means CT minus AT. Okay. So, here arrival time is 0, so that 30, 7, 10. Then WT, WT means TAT minus BT. Okay. 30 minus 24. Okay. Here it is 6. 7 minus 3, here it is 4. 10 minus 3, here it is 7. Clear, right. 6, 4, 7. Average waiting time, question is expecting average waiting time. So, average waiting time is 6 plus 4 plus 7 upon 3. Do the calculation. So, calculated output is 5.66. Yes, this is the average waiting time by using the round robin scheduling with respect to the given process table. Okay. So, go back to the options, select the right answer. So, this is the question, right answer is A. A is the right answer, 5.66 milliseconds. Okay students, I hope you understand this analysis. I hope that everyone did this question correctly, because you know the round robin scheduling in your regular class notes, right. Fine. Next question is, yes, this is also the scheduling question, right. Total 5 processes given, we need to identify the average waiting time by using the priority scheduling. Okay, here priority given, lower number having the higher priority, lower number with high priority. Okay, preemptive, non-preemptive not given. So, when we are taking the priority mechanisms, by default we are using non-preemptive priority, right. So, priority scheduling mechanism we are using, fine. So, here total 5 processes given, P1, P2, P3, P4, P5. Okay, arrival time, again here arrival time is 0, all processes arrived at the same time. this is PID. Next burst time 10, 1, 2, 1, 5 given. Next priority given 3, 1, 4, 5, 2. Okay, this is the given table. Now we need to schedule these processes by using the priority, non-preemptive priority mechanism. So lower number having the higher priority, that is mentioned in the question clearly. Okay. So now when all processes are arrived at the same time, directly we are scheduling them according to the priority. So process chart always starts with 0, right? High priority, priority 1 is high priority, so P2 scheduled first. Okay, burst time is 1, so 1 unit of time, P2 completed. So next highest priority is 2, that is P5 scheduled, burst time is 5, 1 plus 5, 6, clear. Then next highest priority 3, that is P1, process 1, burst time is 10, that is 16, 10 plus 6, 16, that is completion time. Next high priority 4, P3, okay, burst time is 2, so 16 plus 2, 18. Next high priority is 5, P4, burst time is 1, that is 19. Is it clear? Now prepare the completion time chart, CT, completion time, turnaround time and waiting time. Okay, P1, P2, P3, P4, P5, total 5 processes given. Completion time, P1 completion time is 16, P2 completion time is 1, P3 completion time is 18, P4 completion time is 19. This is 19, right? Yeah, 19, and P5 completion time is 6, right? Arrival time is 0, therefore here CT minus AT. Arrival time 0 means turnaround time, completion time will be same, correct? Then WT is equal to turnaround time minus burst time. Okay, now take this 16 minus 10, waiting time is 6, 1 minus 1, 0, 18 minus 2, that is 16, 19 minus 1, this is 18, then 6 minus 5, this is 1. This is the waiting time. Now we need to calculate average waiting time. Average waiting time is equal to 6 plus 0 plus 16 plus 18 plus 1 divided by 5. Do the calculation. So that computational value is 8.2. So this is the average waiting time by using the priority scheduling. Okay. Now move back to the question. Yes, according to this question, right answer is C. C is the right answer. 8.2 milliseconds. Answer is C. Okay students, yes, I hope you understand all the questions analysis, right? Directly whatever the questions we discussed in the regular class notes, some questions are present in the paper also. Everyone knows that. I hope you all are done these questions correctly. Okay, thank you dear students, thank you all.
Hello students, I am Vijay Kumar. Let us discuss the questions based on the microprocessor. Hope you have done the paper very well. Very simple questions have come from microprocessor. Look at question number 34. Which one of the following stores all data written to and read from memory. So, one is instruction register, no, it is for instructions, memory buffer register, or it is also called as memory data register. So, this is the register which is used to hold the data before it is transferred to memory or from memory to the processor. Okay. So, this is the correct answer. So, remaining or not memory address is just to hold the address of the memory or IO device, and status register is just for knowing the status after some ALU operation like flag register. So, correct answer is MBR, memory buffer register. It is a direct question. Okay. Next one, question number 35. What does ST address stand for in 8085? STA, store the content of accumulator at some 16-bit address. So, that is the standard format. So, the standard format is simply STA some 16-bit address. Okay, very simple question, direct question. What is the meaning of store accumulator? Accumulator content, whatever is the accumulator content, this content is stored at the address. So, that is stored at the 16-bit address. Okay, fine. So, bracket stores content. So, read the options, very easy. So, copy the data byte at memory location specified by 16-bit address into accumulator. Okay, no, it is from accumulator to memory. Second one is copy, so this is wrong. Second one, copy the data from the source to destination location specified by the 16-bit address. It is saying source generalized, no, it is accumulator, this is also wrong. Next one, copy the data from the destination to source location space, that is also wrong. So, this one is copy the data from the accumulator to the memory location specified by the 16-bit address. So, that is the meaning of store the content of accumulator at 16-bit address. So, option D is the correct answer. Okay. Next question. Which one of the following buses was designed to improve bandwidth and decrease latency? Latency means delay, okay, in computer systems. See, there are different type of buses like which are directly connected to the motherboard. Some external cards can be connected to the motherboard. You might have seen some slots like 32 bits, 64 pins, something like that. So, PCI is peripheral component interconnect bus, which is the latest one. So, this can transfer the data in almost up to some gigabytes, 1 gigabyte per second is also possible here. And this is VESA, VESA means Video Electronic Standard Association bus. Okay, so these two, like Industry Standard Association bus, like in 1981 it was implemented, it is a very old, this is extended industry. So, these two are very old, so let us not worry about them. So, latest ones are VESA and this PCI. So, VESA bus can transfer less amount of data as compared to PCI, okay, like 128 Mbps, something around like this, 128 megabits per second, but here it can transfer up to some 1 gigabyte per second also. Okay. So, therefore, to reduce the delay means it must be very fast, peripheral component interconnect bus. So, in latest computers it is independent of processor also, but this is based on only 486 processors. Okay. So, this is the correct answer. So, it reduces time period and increase the bandwidth, means more data should be transferred. So, this is the correct answer. So, it works even in megahertz frequency also, 33 to 133 megahertz frequency also. So, answer is A, peripheral component interconnect bus. And the next question, let us look at question number 136. Question number 136. Look at the question number 136. So, I am just writing this question here. So, it is given as a DDR is there, double data rate synchronous DRAM is there. Okay. So, if the 100 megahertz clock rate and 64-bit data bus transfers data, then what is the approximate transfer rate for DDR3? So, he is asking for DDR, okay, this double data, see DDR means double data RAM, okay. So, this is version 3. So, for this one what should be the transfer rate? So, he has given clock of 100 megahertz, clock of 100 megahertz, and what is the bus it is having? 64-bit data bus. Now, tell me 64-bit data bus is used. So, 64-bit means how many bytes can be transferred? 8 bytes parallelly at a time, 8 bytes can be transferred. But here what is the clock? See, it is double data rate, the name itself says it is double data rate, synchronous dynamic random access memory. Double data rate means, for example, if this is the clock, right. So, normally what happens, whether it is rising edge or falling edge, only 1 bit is transferred, but in double data rate, in rising edge also 1 bit is transferred, in falling edge also 1 bit will be transferred. So, therefore, in one clock 2 bits can be transferred, one clock 2 bits can be transferred. So, now tell me, very simple, clock is frequency is this one, what is time period? One clock period 1 by 100 megahertz, it means simply 0.01 microseconds, that is one clock, okay. One clock is equal to this much. So, tell me now, in one clock period, in 0.01 microseconds, 8 bytes of data is transferred. So now for 1 second how much data will be transferred? So 1 second how much data means it is simply sorry, it is double data, right. One time it is 8 bytes for one clock, but it is double data means how much it is into 2 means how much it is 16 bytes, because normally if it is 1 bit that is 8 bytes, so it is double. So you can understand in a simple way. So therefore here you can easily understand that. So total for 0.01 microseconds 8 bytes into 2, 16 bytes can be transferred. So for so for 1 second it is 16 bytes can be, for 1 second 16 bytes are transferred, because it is double data, right. Normally it is 8 bytes, it is 64 bit means 8 bytes, but double means 16 bytes. So for 1 second how much it is? 16 by 0.01 microseconds. If you solve it, it is simply 1600 megabytes per second. So the option should be A. Is it understood? 64 bits means 8 bytes, so it is double means 16 bytes. Is it understood? When one clock period this much is there, 1 second that is the data. So the questions are very simple, you would have easily solved it. So all the best, may God bless you.
Good evening students. Right, welcome to electrical measurements. I think most of the students are waiting for electrical measurements, still live watching. Right. Yeah, question number 121. I think around 12 questions came in measurements. Yeah, a set of independent current measurements, a set of independent current measurements are recorded. Right. 10.03, 10.10, 11, 10.08. Okay. What are the values of average current? Yeah, I average is equal to 10.03, plus 10.10 plus 10.11 10.11 plus 10.08, right, divided by how many values? 4 values. Simplify this one, we will get 10.08. Yeah, this is your average current. Okay, I average, you got it, 10.08. Option may be either A or B. What they are asking? Range of error. Range of error. But how to calculate range of error? Right, generally minimum range or maximum range not asking, it is nothing but average range of error only. So, whenever asking average range of error or range of error, maximum minus minimum, I maximum minus I minimum by 2, right. What is the maximum value? 10.11 minus 10.03, right, divided by 2. So, plus or minus anyway. So, simplify this value, 11 minus 3 8, right, 0.08 by 4, 0.04. Hence, which is the correct option, tell me? Hence, option A is the correct answer. Okay. Question number 121, sorry, option B is the correct answer. Okay. Fine. So, go to the next question. During measurement of low resistance using potentiometer, the following readings were obtained. Yeah, read the question carefully here. The voltage drop across the low resistance under test is 0.4221. So, under test is nothing but let R be the unknown resistance, let R be the unknown resistance. Okay. Capital R be the unknown resistance, I need to find. Okay. Voltage drop across unknown resistance is how much? Let E1 be the voltage drop across unknown resistance. How much given? 0.4221, 0.4221. This is E1, you got it. Let S be the standard resistance. S be the standard resistance. How much standard resistance? 0.1 ohm. Okay, clear? Right. Voltage drop, let E dash be the voltage drop across standard resistance. How much E dash is given as? 1.0235 volts. But we know that very well, we know that very well, right. Unknown voltage E1 is equal to E dash upon L dash into L1, or otherwise in terms of resistance value, E1 is equal to E dash upon unknown resistance is, E dash upon S into R. Yeah, directly you can substitute. If you are substituting here, E1 already you know it, 0.4221 is equal to E dash 1.0235 divided by S standard resistance 0.1 ohm into R. I need to calculate unknown resistance R. Yeah, simplify this value. Unknown resistance R is how much? Whose value is around 0.04124 ohms. This is the unknown resistance. Yeah, this is the unknown resistance, you got it. You got unknown resistance, but what they are asking? What are the values of unknown resistance and current respectively, right? You know the voltage drop across unknown resistance E1, and also you see this is the unknown resistance 0.04124, voltage drop across unknown resistance E1, also you know it, just you calculate the current here, right. So, current I1 is equal to E1 upon R, E1 upon R. E1 is how much? E1 already you calculated, right. E1 is how much you got it? 0.4221 given, divided by R value 0.04124. You simplify this one, your current value is around 10.235 amperes. So, hence option A is the correct answer. Option A is the correct answer. This is your answer. Okay, right. Next. Coming to next question. What they are asking? This is a PMMC instrument. Given that PMMC instrument, right? PMMC voltmeter we are talking about. So, area of the coil. What is the area of the coil? Length into width 40 mm into 30 mm. Right? Directly we can write 40 into 30 into 10 to the power of minus 6 meter square. This is the area is given. Right. I can write directly given data. Number of turns 100. Number of turns is 100. Right. Control torque. What is the control torque? 240 Newton meter. Control torque is 240 Newton meter. Okay. When the deflection is 100 divisions, deflection is 100 divisions on full scale. Deflection is 100 divisions on full scale. Magnetic flux density B 1 Weber per meter square. Right, everything is given. What they are asking? What is the maximum? What is the value of how much value of resistance in series with the coil to give 1 volt per division? Okay, directly we can write it at steady state. If I am calculating, deflecting torque is equal to controlling torque. What is the deflecting torque in PMMC? BINA, BINA is equal to controlling torque, directly given, but current I is equal to, we can write V by R, right. Let R be the meter resistance, directly we can write it. So, current I is equal to V by R, you can write it. Okay. This 1 Weber per meter square, current I is equal to V by R 100 by R into number of turns 100, area 40 into 30 into 10 to the power of minus 6. What is the control torque? 240 micron. Directly I think these are cancelled, you can simplify. So, after getting simplification, what is the value of R? The value of R will become, right, 100 into 40 into 30 divided by 240. You can simplify this one, right. This value is around, R value is around 50,000 or directly 50 kilo ohms. Yeah, this is your answer, right. Hence, which is the correct option? Option C is the correct option. Okay. Right. Go to the next question. 124. Yeah, what is the 124? Tell me, which of the following statements are correct regarding moving iron instruments? Regarding moving iron instruments. Yeah, what they are talking? Tell me. Right. It indicates same value of the measurement for both ascending and descending values. Actually, MI instrument suffers from hysteresis error. We know hysteresis error very well. MI instrument suffers from hysteresis error. If you are drawing the BH curve, right. Okay. If you are drawing the BH curve, how is it? So, this is the BH curve. Yeah, for descending values, how is it? Right. If you are going to observe here, it indicates higher value of the measurement for ascending values. No, it indicates higher value of the measurement for descending values. You see this OA portion, loading energy of the coil, while it is unloading, right, at this currents, it indicates higher value of the measurement for descending values of current. While it is unloading, right, even though supply is switched off, still some amount of flux is present because of hysteresis error. It is called residual flux. Because of hysteresis error, it indicates higher value of the measurement for descending values. So, hence option C is the correct answer. Okay, right. Right, next question. Yeah, again it is a numerical question only. What they are giving, tell me. PMMC instrument, shall I write directly? PMMC instrument. What they given, tell me. Full scale deflection. Current is given, full scale deflection, IFSD 10 milliamperes, right. Potential difference VFSD, how much VFSD is given, 100 millivolts. Yeah, what is the meter resistance, tell me. Meter resistance RM is equal to VFSD upon IFSD, right. VFSD is how much, 100 millivolts by 10 milliamperes, simplify. So, 10 ohms, meter resistance is 10 ohms, right. Yeah, what they are asking, tell me. 0 to 10 milliampere meter, they want to extend up to 0 to 100 amperes, right. Directly we are solving. So, meter current is given, everything. This is the meter current IM, extended current is I extension is given. Multiplication factor M is equal to I extension by IM, 100 by 10 milli, I think 10,000, M value 10,000, directly we can write RSH is equal to RM by M minus 1, directly you can substitute 10 ohms upon 10,000 minus 1. Simplify this one, whose value is around 0.001. It is a regular class notes question. Every time we are going to discuss in the class directly, regular class notes question, 0.001. Hence, option B is the correct answer. This is the question number 125. Okay. Yeah. Next question. Question number 127. Yeah, 126. We know very well in a 2 wattmeter method. In a 2 wattmeter method, the 2 wattmeter readings are suppose W1 or otherwise P1. P1 positive. Another one W2 or P2 is negative. One of the reading is negative. We know very well in low power factor loads, if the power factor is 0 less than or 0.5, in between power factor is, suppose if the power factor is in between, right, if the power factor is in between 0 to 0.5, definitely one of the wattmeter reads negative for lagging loads only. So, hence option, right, which option is correct? Option C is the correct answer. In between 0 to 0.5, one of the wattmeter always reads negative. Okay. Right. What is the range of frequency measured by a typical frequency meter? Generally several heads to, I mean some heads to several gigahertz. This is the typical range of frequency. Here megahertz, heads, several heads to gigahertz, that is the reason, hence option D is the correct answer. Okay, D is the correct answer. Question number 127. Right, next question. Yeah, good question again. Again class notes question only. 3.5 digit DVM. What are they given? Tell me. 3.5 digit DVM. Okay. What is the reading value? Reading value 5 volts, I think. Check it. Reading value 5 volts. Full scale value VFSD is how much? 10 volts. 10 volts. What is the specifications? Tell me. Total error is equal to, error specifications are given as 0.5% of reading, 0.5% of reading plus 1 digit or 1 count, right, no problem. It is nothing but error 1 plus error 2. Again it is a regular class notes whatever we are discussing only. What is error 1? Tell me. 0.5% of reading, remove the percentage symbol, reading is 5, 0.5 into 5 by 100, 0.025, this is error 1. What is error 2? 1 digit. What is this 1 digit? 1 digit or 1 count is equal to 1 digit or 1 count is equal to VFSD upon 10 to the power of n. Full scale value is how much? 10 only directly, 10 upon 10 to the power of n, 3.5 dVm, n.5 dVm, 10 cube, 1 by 10 square is nothing but 0.01. 1 digit is 0.01. Total error, tell me. Yeah, total error is equal to error 1 plus error 2, 0.025 plus 0.01. Right. And now add these two, 0.035 is the total error. Hence, your answer is option C is the correct answer. Okay, fine. Right. Yeah, look at the next question. It is a theory bit question only. Question number 129. Which one of the following statements are correct regarding potentiometric recorders, right? Anyway, just you read it. A sensitivity of 4 volts per mm is attained with an error of, directly I am giving the answer, right? The available options is the more correct answer is this option A is the correct answer. You can check it, right? Remaining options also you can check it, but directly I am giving the answer, option A is the correct answer. Okay, right. Next. Yeah, again this is again class notes question on previous ES question also, right? What they are giving, tell me. It is a oscilloscope, right? CRO. CRO question. What they are giving, tell me. Bandwidth is given. Bandwidth is 10 megahertz. What is the fastest rise time they are asking? Fastest rise time. So rise time equal to TR is equal to 0.35 divided by bandwidth, 0.35 by bandwidth. Bandwidth is how much? 10 megahertz. 0.35 into 10 to the power of minus 7. So I think 35 nanoseconds. 35 nanoseconds. So hence option, which option is correct? 35 nanoseconds. Option A is the correct answer. Okay, go to next question. Yeah. What is the key factor that must be considered while selecting a transducer? While selecting a transducer for a particular application. What is transducer? Transducer is a device which can convert one form of energy into another form of energy, generally non-electrical to electrical, non-electrical to electrical, mechanical to electrical or any non-electrical to electrical. Okay. So definitely non-electrical to electrical. If it is mechanical, hydro, so that is the reason input also depends upon output and transfer characteristics. Hence option D is the correct answer. Input, output and transfer characteristics should be considered while you are selecting a particular transducer. Okay, clear. Suppose LVDT, force or pressure is the input, output is the electrical voltage, displacement and final output is electrical voltage. Okay. Right. Yeah. If a transducer has an output impedance, right, of 1 ohm, output impedance of 1 ohm and load resistance of 1 kilo ohm behaves as constant voltage source. Why constant voltage source? This is something else. This is a transducer, output resistance of 1 ohm, this is a load resistance is how much? Load resistance, this is a source, the source is nothing but transducer converting mechanical energy into electrical energy. So output resistance 1 ohm, low resistance only. Ideal voltage source, internal resistance is 0, practical voltage source low resistance, low resistance. Load resistance is how much? Load resistance is 1 kilo ohm, load resistance is 1 kilo ohm. So hence it acts as a voltage source. Option B is the correct answer. Okay. Right. So and 12 questions came, right, you can verify your answers. So, measurement is always important in particularly ESE examination, more numbers will come, right. All the best, right. Thank you.
Hello everyone, welcome to the video solution of EMT. So in this question they are asking what is the magnetic field at this particular point, right. So at this point, now let us consider this to be B. The magnetic field is given by the formula IA square upon 2 times of A square plus B square 3 by 2, right. So this is the H. So B will be how much? B will become mu naught into IA square upon 2 times of A square plus B square 3 by 2, right. Now if this A and B, so what will be the value of R? It will become root under A square plus B square, right. So this is equal to mu naught, this is M, M is nothing but your magnetic moment, M is nothing but your magnetic moment or magnetic dipole moment, and its value is given by IA square, right. So mu naught M divided by 2 times of this is your A square, so this is your R cube, right. So this is the answer finally. So mu naught M 2R cube. Now here extra pi they have given, so this pi should not be there, right. So if you check the answer, it is mu naught M 2R cube. So option A is correct. Okay. So thank you everyone.
Hello students, welcome to the digital electronics session. We got questions from the digital electronics so simple way. Let us see the questions here. Here it is, they asked this one as the reference voltage is 4.5 given and it is R to R ladder type. What is the percentage of resolution? As you know, the percentage resolution is nothing but VR by 2 power n minus 1 like that. So based on that, this is a direct formula based one. And here if you observe this another question here, how is a JK flip flop created from SR? So let us just draw this one. Actually, as you know, let us consider here NAND gates latch. This is SR. Of course, from these NAND gates also we can just make like this the way, and this is SR latch. Of course, here we are having like this, it is connected here the clock. Now it is SR latch basically, but to make it as a JK, what we did is just we made like this, the output is taken here and connected from that here, and this is taken here and it is connected like this. So then it is going to become as JK. So based on that, the connections from the outputs we just made to the input connections. So this is the way we are making the conversion of SR into JK, right. Let us check like that another question also here. You can check from that the options also. Now this is a demultiplexer related also, the question is asked here, and in this one this is 1 to 8 demultiplexer. Basically here demultiplexer is nothing but a decoder with enable input is going to be treated as demultiplexer. So for this particular 8 means we are having here, let me say first of all with 4 to have like this, AB will be the select lines, and based on this we are going to make the connections Here the connections are going to be from 0 0 0 1 1 0 1 1 like 0 1 2 3. This is actually for this particular thing only we are going to have some enable input. That means this enable input is going to be connected like this. So then it is going to be considered as 1 to 4 demultiplexer. So for 1 to 4 demultiplexer 2 select lines are required. Then for 1 to 8 demultiplexer, here the select line should be A, B, C. Then we are going to have 1, 2, 3, 4, 5, 6, 7 and 8 like 0, 1, 2, 3, 4, 5, 6, 7. So for this one, enable input we are going to connect to all these. So 3 by 8 decoder, for that enable input when it is connected here, it is going to be treated as 1 to 8 demultiplexer. So the select lines how many required means 3 required. Got it this one? Right. Thank you. Dear students, you can check here a flash type A to D converter they asked regarding to that. For the flash type, number of comparators used, it is a direct question and a direct formula based, because we know when we want to make the conversion process of this one, we require comparators, and the comparators are 2 power n minus 1 number of comparators required, because for the 0 there is no need to make the comparison, and for that there is no need of comparator. So we are having 2 power n minus 1. Got it? Right. Thank you.